Hello everybody, Chris here. In this mini series, I'm going to be showing you guys the basics of setting up a projectile based 2D platformer inside of Godot. And we're going to be doing it using a 1-bit platformer pack by Kinney, which you can get off of itch.io for free. So I'll put the link to this art pack in the description. And we'll be using it to set up some basic projectile mechanics inside Godot. So for this project, I'm going to be using version 4.3 of Godot, which is in its third beta. Most things will be consistent regardless of version, but one difference is going to be using TileMapLayers instead of the TileMap node. So let's go ahead and create our new project. I'll call our project something like Projectile Platformer 1-bit Tutorial. I'll choose my folder for tutorials and my computer, and we'll just use the mobile renderer. Our graphics are about as simple as they can get. So inside of our project, we're going to need to import that art pack. So I'm going to, in the bottom left for file system, going to right click on the resources folder and create a new folder. So I would generally call my folder something like art or assets. So I'll just make it art here. And I'll right click to open this folder in File Manager. Okay, and navigating to where I have the 1-bit platformer pack downloaded from the website, we can either use individual tiles or just the packed tile maps. So for the project, I'll use the transparent packed version of the tile map. Packed meaning there's no spacing between the tiles, and then transparent means instead of a black background, we just have a transparent background. So we can actually set the background color easily to be whatever we want, and we don't need to worry about filtering out the black pixels or anything like that. So let's copy and paste this into art. I might even create another folder inside of here and say something like Kinney 1-bit platformer, just to know where it came from, and put this in. And let's copy and paste the license into there. So of course, license-wise, you can see the art, of course, is Creative Commons 0. So you can use it in educational or commercial projects. So it's great for stuff like what we're doing here. Let's jump back into Godot now. So back in Godot, the first two things you're probably going to do are start putting down a tile map and creating a scene for your playable character. We'll do both in the first part of this series. So I'll start with the tile map. Let's create a new 2D scene, and I'm going to rename this to be level 1. I'll save it to the project. So we might have a levels folder inside of here. So I'll just call this levels. And in levels, I'll save level1.tscn. Now note in Godot, if you don't know already, file names are generally lowercase separated by underscores. So level_1.tscn. Let's save that there. And now our level is going to need a tilemap layer. So if we search tilemap, you'll see that tilemap is being deprecated in 4.3. Of course, it's still going to work for a while. I don't know when they're actually going to finally remove that. But the new way of doing tilemaps is going to be using TileMapLayers. So it's not actually all that different, except instead of having one tilemap node and then layers over here in the inspector, you just have a different node for each of your layers of your game map. So you'd probably have like a ground layer, a background layer, maybe like a sky layer, like foreground, background, that kind of stuff. And you would just have a different node for each of those in the hierarchy instead of everything being condensed into one tilemap node. So for the tilemap layer, we're going to need a tile set resource. So note, you don't need to create one for each layer necessarily. You can just create one new tile set resource, and you can save this to the project and then reuse that across different nodes and different levels as well. So I'm going to right click this and save it. Let's say that since basically tile sets are going to be used exclusively on our levels, that we could create another folder inside of here, and I'll call it tile sets. And inside of here, we'll say Kinney 1-bit platformer, and automatically the extension will be .tres. So we'll save that there. So if we click on our tile set, we'll see a bunch of different subcategories in the menu here. We'll come back to that in a second, but more pressing at the bottom of our screen is the tile set menu option here. So we want to switch to tile set to set up the tile set. And when you're drawing onto your 2D level, you would switch to tile map mode. So we need to be in tile set so we can set it up. Let's go find our monochrome tile map transparent packed.png. I'm going to pop this in here to tiles. And in recent versions of Godot, you can just automatically create the tiles. So I'm going to hit yes to that. and all of these spaces are going to automatically be recognized as 16 by 16 tiles. And you can see because of the transparent version of the tile set, there's only one color here. So in one bit, you would have generally black or white. Some games like to add red to that mix, but one bit would just be on or off, so black or white. And we can use these for basically creating our game levels, and then these sprites down here can be our characters and enemies, as we'll set up in a bit. Okay, so if we were to switch to tile map mode, you can select these tiles now, and when you have it selected, you can left click somewhere. As long as you have TileMapLayers selected, it'll place it onto that layer. Now you might notice that these pixels are kind of blurry, so we want to change that in project settings. Let's go up to project settings, and then down to rendering textures, and change linear to nearest, and hit close. You'll basically want to do that for every pixel art game, so that all of your pixels render much clearer as they are intended. Now you can build out your ground tiles by clicking on each one you need and left clicking, and then okay, you need to go across, so now you use the across tile, you click the corner tile, you go down like this. But that can get a little bit tedious, and if you recognize an obvious pattern here, then a better way is to create a terrain set. So in TileMapLayer, under the tile set, the Kinney 1-bit platformer, let's expand terrain sets, add element, and expand terrains, add element. So for each set that you want to basically match with each other, different tiles that go together of the same type, you're going to want to give it a name and then a color. So I'll call it dirt and just leave the color the default brown because, I mean, it's dirt, it makes sense. Mode we can probably just leave at match corners and sides for now. So in order to add tiles to the set and then create a bit mask so that it knows which tile to place in which location automatically, we want to go to the tile map window at the bottom and then go to terrains. So in order to define which tiles are in this dirt terrain set, and then to assign a bit mask to it so it knows which tile goes in which location with reference to the other tiles, let's go to the tile set window at the bottom. And we want to go to Paint, and then select a property editor, Terrains, select the terrain set 0, and then we'll choose Dirt here. Okay, so basically find all the tiles which you would consider to be dirt, and I would say that's these 9 right here. And then left click, hold, and you can drag over each of them until they're lit up white instead of grayed out. And then once that's done, you can click on them and you can start assigning a bit mask. So if I left click and hold, you'll see that this makes the squares light up that brown color for dirt. And basically with the bit mask for terrains, you want to tell it which parts of the tile are fully defined as dirt, as opposed to the edges, which are only partially dirt and are probably adjacent to either nothing or a different terrain type entirely. So if a part of the tile is completely enveloped by dirt, then we want it to show as dirt. So that's going to basically look like this in the end. All of these border bit mask squares are going to be left blank. And the result of this is it'll know which tiles to place adjacent to each other, so that we know which ones are facing outwards to non-dirt and which ones are facing inwards to another dirt tile. So if we go to tile map now and we click on terrains, we select dirt here, and then we can start drawing. So I'm going to left click hold, and you'll see that it will automatically change the tiles to be the correct dirt tile based on whatever is adjacent to it. Now it's not perfect with just these 9 squares. You can see that in cases like this where you just have like one tile sticking out, it's not going to fill in the gaps perfectly. In fact, in this case, I think it needs to be at least 3 tiles wide for the tiles to assign, but we can quickly just kind of draw on our tile map and get at least a decent result. So we can kind of just go around the edges and get a pretty okay result. So we can see, of course, that although it does a pretty good job of tiling with just 9 tiles, we can't cover every possible case. So In this square right here, there should really be like a corner piece here and one there as well. I think that's just a limitation of having a simple 9-piece tile set right there for the dirt. Generally, when you have a more robust tile set, you have a bunch of extra pieces for covering these kind of specific cases where you have like corners and stuff like that. But for this case, it might just mean that there might be some limitations in which shape we can create, which is fine. And yeah, let's just kind of do something like that for right now. Another thing you can do for quickly just kind of putting some tiles down is to use the line brush if you want to go from one point to another. Or you can use the rectangle shape and just draw in a huge blotch of tiles. So I could just click here and create ground just like that. Instantly has all the top, left, bottom, and right tiles. And we could go up a little bit like that. Maybe the space needs to be a little larger. We can come back and kind of fix that in a second. And maybe we have this go on a little bit further to the right. Okay, so for this bit, I'll just switch to the pencil tool and get those left sides in there. And that's probably good enough to at least have some basic playtest space. So let's save the level, and I'm going to create a new scene for our playable character here. So click to add a new scene, I'll right click and change the root to a character body 2D. And then let's rename this to be player. I'll save this scene to our project. So in the root, I'll create a folder. I might call this something like characters, and then hit OK. And then inside of here, I'll create one called player and save it. So let's zoom in on our scene. We'll need a sprite to render our players. So I'll right click on our player, add a child node, and search for sprite. So we could either use a sprite 2D node or animated sprite 2D node. I'll try going ahead with an animated sprite 2D first, since it contains a little extra features for playing multiple frames of texture as a animation. So we'll create that. In the animated sprite, if we go over to the right, under animated sprite 2D, we can see animation as a category. We want to add new sprite frames into here. So new sprite frames resource, I'll create that. And since this is a resource, we can save it into our project. I might want to do that so that it's separate from this scene and reusable. I'll right click and save as, and in the player folder, I'll call this player sprite frames.tres and save it. So now we can expand this and add in our animations. So let's create a idle animation. I'll rename default to idle. And FPS, I think we're going to want something like 20. We'll figure that out for sure in a minute. And we want to add in frames from our sprite sheet. So I'm going to click on the add frames from sprite sheet button. And then we'll go to art, Kenny Platformer, and the transparent packed.png. Open that up, and if we zoom in, we can see basically the whole sprite sheet. So our frames are going to be 16 by 16. So on the right, I'm going to do 16 and then 16. So these are the frames for our playable character for the pack. So our character is around here for this pack. As far as I can see, it doesn't appear to have like an animated idle animation. So we can just use the first frame here, add frame, and that can just be our idle. And let's add in some other animations. So add animation, and we want a run animation. So we'll select from the pack, once again, zoom in, and that is going to be here to here. So I'll add those frames in, and let's also add in a dad animation, and I'm going to make all of these 20 FPS. While I'm doing that, let's actually test the run animation. Okay, maybe that's too fast. Let's make it 10. Yeah, that appears more like what it's supposed to be. Okay, so 10 is actually the FPS for all the animations. And for dad, it looks like it's going to be just this one little frame over here. These actually appear to be other variations on the character. So very simple character, but that's okay. We'll add that in. Idle, run, and dad, and we can just reverse the direction of the sprite when we need it to run left. So this at least gets us our minimum requirements. So another thing we need for our player is to add a collision shape 2D for the physics body. So the character body 2D is a physics body. So I'm going to right click, add child node, and let's get a collision shape 2D. So a collision shape 2D, you could either make it a rectangle, a circle, or a capsule. I'm going to go with capsule. And then we want to adjust these handles right here until the capsule matches our character. So let's shrink the character or shrink the capsule until it basically matches our character. Okay, so regarding the position of the sprite versus the collision shape, generally what I'll do, partially for sorting reasons, is to take all of the characters and position their 0, 0 position. That's where the axes meet, the 0, 0 position, and make that about where their feet are. So I'm going to move the character up to, I guess we'll just say right there, yeah, and move the collision shape as well. So to do that, you hit W to go to move mode or Q to go to selection mode. So in W move mode, you can just reposition it, and Q to select between the different elements on the screen. So W move, and just kind of make it something like that. Okay, so we have a collision shape for our character. We might even want to make it a little bit smaller if we're also going to be using this as the hitbox. So just kind of favoring the player by making a smaller hitbox. And then we position that down there. So if like an arrow projectile happened to hit the ears, we just wouldn't count that as a hit until it hits this blue circle here. Okay, so let's put the character into level 1 for right now. So I'm going to search the file system for player.tscn and add it to the scene, drag and drop. Okay, now we want to hit W to move it, and we'll move our player to right around here. So we have our character in the scene, but right now it's not really going to do anything. We haven't attached a script to the character body 2D. So let's attach a script, and I'll just call it player.gd. Okay, so for our character body 2D, whenever the physics runs on each frame, so physics process, we want it to move and slide based on our input or lack of input, and we want it to be affected by gravity as well. So I'm going to start by implementing the function underscore physics process, and we'll just say move and slide here. So on the physics body, we're going to be telling it to move and slide on every frame. If I hit play on the level scene, you'll see that nothing happens there still. So let's get input from the user to make the character move. So generally for doing that, you want to get an input vector, which is going to have your left, right, up, down movements in one go using the input class. So if I say var direction equals input dot get vector, then here you would give it 4 string names for 4 different actions, which are going to be like left, right, up, and down. Now those actions need to be defined in project settings. So if we go to project settings and then input map, we can say left, right, up, down. And then for each of these actions, you can assign keys or controller buttons in order to trigger those actions. So I'll add A for left, D for right, W for up, and S for down. So there's your standard WASD movement input. So we hit close here. Now for the action names, which are string names, we could just type in left and then go right, up, down for that. But I'm not the biggest fan of that hard-coded approach. So for me, rather than hard-coding the names of the strings into the script, I will actually create a class that will hold all of the player input action names and then use that instead. And I'll also make those variables for the action names exportable so that you can change them without going into your script. I just think that's a little bit of a better way of doing things. So let's create in the player folder. I'll right click, create a new script, and I'm going to call this player input, or player input actions actually. And it will inherit from resource instead of node. So let's create that and double click into the script. I'll give it the class name, player input actions, and that'll be much easier to reference this in other scripts like the player. And this will define the action names for the player input during gameplay. So we want to have at export var left And then this will default to left. At export var right, which will default to right. At export var up, which will default to up. And then at export var down, which will default to down. Now, for each of these, you can optionally give it a string name typing. By default, when you just say equals a string, it's going to automatically make these strings. So a string name is supposed to be more of like a constant string that you don't change during gameplay, where generally a regular string you can change all the time or append to it, add things. But for things that are supposed to stay consistent, string name probably makes more sense. So I'll use tabs to make this a little bit cleaner. And that'll basically be all we need from this class for right now, but later we'll come and add extra actions for stuff like maybe a shoot button to launch projectile. So back in the player script, I'm going to @export of var, and let's just call this actions, but of type player input actions. And then with this, it's going to expose a field for this resource to be assigned in the inspector. And then we can use these actions instead of hard-coded strings. So it might seem like a lot of extra steps, but I think it just gives you a much cleaner result in the end, because now we can say something like actions.left, actions.right, actions.up, actions.down, and we don't have a hard-coded string here in this file. And that means that we can change it without accessing the player script. So if we click on player now, you can see the actions resource needs to be assigned here. So I'll create a new player input actions. And if we expand that, we have left, right, up, down string names. And these correspond with, in the project settings, our left, right, up, down actions. So also, if we aren't using these names in our actual project, maybe your project uses something different, then you can just change them here, like left action. And then if you go to project settings, you can rename this to left action, and you can change it once again without needing to be inside the script. Also, stuff like that is more handy in projects where not everybody is really touching the code necessarily, and they just, kind of want to be able to use the inspector here and just design things without messing with code. So that's basically what we need there. Because this is a resource, we can save it to the project and reuse it. So I'll right click, save our resource, and I'll just put this in player. So player input actions.tres, save. It's also handy to save resources because if you ever happen to delete your scene here, these files still exist in your project. So you're not starting from scratch. You can just re-access the same resources or load it into a completely different scene. Okay, so we have our direction for the input. We want to use that to basically change the velocity of the character. So how fast do we want a character to move? Well, that's going to be another @export. So let's say up here @export var move speed, and this will be a float, and we can set it to something like, it's kind of arbitrary. Let's say 50 to start and hit save. Okay, so there we have our move speed exported to the field here. Now this can be like -50 by default, which is kind of weird. So if we want to prevent our editors from being able to make the move speed a weird number like -50, let's revert that for a second, then we can change this to an @export range instead of just an @export. And we can define kind of what value should be in that range. So you could say something like 0. The max isn't going to matter as much because we're going to make it set to or greater. So it can actually go above this, even if we set it to 100. And then how much we want it to increment, which can be a floating point. So it could be like 0.1, or we could just say 1. And then the fourth parameter is going to be either hide slider or greater or less. So we want or greater so that when we hit save, and we left click and hold on this, it can go to 0 and it can go above 0, but it can't go below 0. So the move speed has to be a positive number now. And I think even if we type something like -100, it'll force it back to 0. So that's pretty helpful for us. And now this is going up 5 at a time. We might not want that, so we could change this to something like 0.2. I wonder if that'll make it a little bit slower here for the increment. Yeah, so maybe that's a little better. So it goes up like 1 at a time instead of 5 at a time. So now let's set the velocity on the character body. So a character body already has a velocity property, and that has an x and y component. So we can say the velocity x is going to be equal to the move speed times the direction.x. And then move and slide will basically execute and move the character. Okay, so if we go ahead and hit play on our game, then we can see we can move our character left and right, but it's way too zoomed out. And we'd also like a camera to follow our player around the scene. So if we go to the level 1, we can right click on the root, add a child node, a camera 2D. And then this camera 2D, you can see the purple box representing it, the lighter purple. It's way too big at the moment. We want it to be more of a section of our game level, not bigger than the entire game level. So to change that in the inspector, we go down to zoom. I'll set this to 3. And then that's a much more reasonable zoom level. You could even go further or less. And I think you can do like 3.5 too, if you want to. Okay, and then for focusing the camera on our player, we right click on the player, add a child node, remote transform 2D. So this pushes the remote transform position or in other settings onto the other node, which is our camera. So remote transform 2D, and we assign the camera. So now you can see that immediately the camera jumps to the player because that's where the remote transform 2D is. So if we hit play, not only are we zoomed in, but we also have a follow camera. Now, one last thing I want to fix for the video is to make it so that when our character moves to the left, our sprite actually faces to the left. And this is something we're going to want to do for all of our platformer characters. So this will get a little bit involved coding-wise, but hopefully by the end of this section, you'll see that this kind of setup will be really flexible and good for the long term. So first off, I want to go to player, and I want to create a node that's a parent of the animated sprite called facing. So I'm going to right click here and add a node 2D so that it has a position and rotation and scale. And I'll rename this to be facing, as in it's the node which controls which direction the character is facing. And then I'll take the animated sprite 2D and make it a child of that so that this sprite 2D's scale is dependent on the parent. So if I click on the parent facing node and I go to transform, make sure X and Y are unlinked, and I set X to -1 for scale, then that will make the character flip. Now this also means other objects like a collision shape, if it's a child of facing, are going to flip from the right to the left. So you can use this to control hitboxes as well. Now for the facing node, we're going to want to attach a script to that. And this is going to be more of a component node, not necessarily specific to the player, but more specific to any platformer character within our game. So let's right click and add a script. I'll call it facing, and I'll make it not in the player folder, but the characters folder. So facing.gd inherits from 2D, node 2D. Now for this, we're going to want to get reference to a character body 2D, but not every character body 2D actually has a direction. If we open up the player script, the direction I'm talking about is the direction our character is trying to move. So we declared that in the player script as a local. We want to make that more of a script-wide variable or property now. And the way we would do that is by putting it outside of the function call. Now I don't want this to just be for the player script though. I want this to be for all platformer characters in the game. So I'll right click on the characters folder in our file system to create new script. And I am going to call it platformer character 2D. Inherits from character body 2D. Create. And we open up that script. I'll give it the class name platformer character 2D so that we can easily reference that in our other scripts like the player script. And inside of here, we're going to have a reference to the direction property. So var direction is a vector 2. Now if we open up the player script, instead of setting the direction locally here, I'm going to remove the var part, and we're actually going to set it to the properties. But right now, the player script does not actually have the direction property because it's not a player character 2D. So we need to change the extents from character body 2D to platformer character 2D, which if you remember also inherits from character body 2D. So it's still character body 2D, just with the extra custom steps we created now. And we might also want to give this a class name player if you want to be specific about it. Now, when we're creating the facing component, as I mentioned, we do want to apply it to the player, but we also want it to be able to apply to any other platformer character. So instead of referencing a player, we're going to export var reference a character, which is a platformer character 2D. So if you click on the facing script, we can assign the player, because it is a platformer character 2D, but we don't necessarily need to reference a player. It can just be any platformer character 2D, and that's important. So at the top here, I'll give it a class name facing, just in case we ever need to reference this script. And now what we want to do is whenever the direction changes on our platformer character, we want to respond to that within our facing script. So a not great solution would be to use the process or physics process function and then just check the direction on each frame. But a much better solution is to use a signal from the platformer character script, and then whenever that signal is emitted, we have a function activate inside of our facing script to update the direction or the scale on our facing node so that it makes the animated sprite face left and right. So let's go to platformer character 2D, and this property direction, whenever that's set to a new value, we want to emit a signal. Now we don't have a signal for that yet, so let's create one. So signal direction changed, which is going to take a direction, which is a vector 2. So we're going to pass in that direction argument, and that will be received by our facing script later. So you don't necessarily have to use a setter property, but I think that's a pretty good way of handling this kind of thing. So basically, when we attach a setter function like this, set value, so like colon up here, and then set value colon, then whenever we try to set this property value, it's going to execute this code. So the code we want to execute is going to be direction equals value. So as it is right now, it would be exactly like we didn't have a setter at all, but now we add extra stuff to it. So when the direction changes, we want direction changed to be emitted using the new direction value. Now we can also take this a step further. We only really want to change the value and emit the signal when the value is actually a new value. So as a precondition, we'll check up here that if the direction is equal to the value, we just return, and we don't set the direction and we don't emit the signal. That'll just reduce the number of unnecessary direction changed signal calls, because when we have direction changed, we expect the value to have actually changed. So that prevents it from just calling on every set, and then it'll only change when the vector is actually different. Okay, so in the player script, we're setting the direction, which is going to run this code. If the value actually changes, direction changed gets emitted. So now in the facing script or any other script we want to respond to that, referencing a player character 2D, we can put our own setter function to connect to the signal whenever our character changes. So if the character is a valid instance, instance valid is instance valid, and we'll check the current character, then before we add the new character in, we want to disconnect from the old character signals. So character.direction change.disconnect and on direction change. Now after disconnecting from an old character signal, we want to set the value to the character property. And then once we have the character set, we want to connect to that character's direction changed signal. So I'm just copy pasting this down here, and we're going to do connect. At this stage, there might already be a character set, but we're setting a new value here. So we want to disconnect old signals, and then we set the character. And once we set the character property in this script, we want to connect to the direction changed signal. Now we get errors because we don't have that callback method. So function on direction change, and as a parameter, we need the direction vector. But I often like to put a p in front of the direction, p for parameter, so that we know that it came from the parameter specifically, and it's not a local variable, and it's not a property of the class. So on direction changed, what do we want to do? Well, first we want to see if the x direction is actually 0, and then just ignore the rest of the function, because if the direction is 0 on x, that means that the character is not moving left and right, so there's no need to flip the direction of the facing component. So if p direction is equal to, p direction.x is equal to 0, we'll just return. Okay, otherwise, we want to take the scale.x, and we want to set that equal to, let's say, the absolute value of the scale.x. So this is the raw value of the x scale. Whether it's positive or negative, it's going to return a positive. And then we want to figure out what direction we should be making it face. So if we take the sine of the p direction.x, then that's going to give us either a plus or -1. Now it can also be 0 if this is 0, but we already handled that case right here. So we're not going to do anything with the scale when the x direction is 0, only when the character is actually trying to move to the left or actually trying to move to the right. So this is going to be plus or -1, and this is going to be the raw value of the scale. So when the character is facing left or moving to the left, this is going to make the scale, whatever it is, raw value times -1. And whenever it's facing to the right, it's going to be the raw value times 1, which is going to give us our left-right facing direction. So hopefully this coding setup made sense. The reason we create a separate script for facing is so that it's a reusable component. We create the platformer character 2D class so that we can have certain aspects applied to different characters in our game without re-implementing them in every enemy script. And then we inherit from that script so that that direction is part of the player as well, but not exclusive to the player, because any platformer character 2D can now have that. So we'll be able to easily reuse that for our enemies later on. Yeah, and hopefully this setup with a custom signal all makes sense. Signals just kind of reduce a lot of the unnecessary function calls you need to have so that you're not calling process to check on a variable every single second of the game, or millisecond even, but rather you're just waiting for something to change and then your code executes. It's just a better way of doing things. So if we hit play, we're going to have a character here. If I move to the left with A, you can see that it flips to the left, and then D will flip it to the right. So back and forth. And if the character's not moving, nothing happens, which is exactly what we expect. So to show what this is actually doing, if I expand the remote view, which is our current gameplay scene, local is for the editor, remote is for gameplay, and we expand player, we can click on facing and see that the scale is set to -1. Now, if I move to the right, the scale is set to 1. And remember that as the parent of these child nodes, whatever happens to the scale affects what's down here. So we don't need to change the scale of the animated sprite to face left, because the parent, the facing node, already does that for us. So this controls all of its child nodes, and if you need it to flip directions, you just make it a child of facing. So that should pretty much be a good setup for the start of this project, I think. I'll have a link in the description if you want to download the part 1 of the tutorial. And of course, on each part, I'll have the updated version of the project going all the way to the conclusion, and those will be on my Ko-Fi and Patreon pages. So if this tutorial helped you out, thanks for watching to the end. I've been Chris, and I'll see you in my future video content. Hello everybody, Chris here, and in this part 2 video, I want to continue working on our player for our 1-bit projectile platformer. So the player script that I set up before, it extends from platformer character 2D, and it has that direction property, which we're using to control the X velocity or the left-right movement of our character. So I kind of want to pull some of this out. When we're getting the input, we can, of course, keep it inside of our player script, but we could also make it a separate component like we did with the facing script. So the more functions we put inside of a single script, basically the harder it becomes to reuse that same script across different objects. So we might have, for instance, different types of players that behave a little bit differently, but they might, for instance, receive input all the same way. So let's go ahead and pull our player input out to a new script, and then we'll have the input target a player character 2D, the player, for controlling the velocity here still. So I'm going to right click on player and add a child node. So this one will just be a basic node because it doesn't really need any 2D position or transform elements. So let's create that. I'm going to rename this to be player input, and then let's attach a new script to it. So right click, attach script, player input, and we can save that into player, create that. So I'll go ahead and give this the class name player input. And then inside of the player script, I'm going to grab this direction equals, and we're just going to pull that out to the player input script. So function, we could keep this on physics process for now. So we'll say the direction is equal to the input line that we got before, the actions. So the actions, we probably also want to put them in this script rather than the base player script. So I'm going to pull out export var actions. And then I'm going to paste that line in here. Okay, so where are we setting the direction? We're setting that on the platformer character 2D. So we need reference to export var we'll say character of a platformer character 2D. And then character.direction is equal to this because the direction property is set on the platformer character. So we're going to change the direction from within our player input script, but the actual direction, at least for now, rests inside of our player script or platformer character 2D script. Now, why would I make it reference platformer character 2D rather than the player script, which extends platformer character 2D? That's just because the platformer character 2D base class has all of the necessary properties for the player input to run. So we don't need to specify it any further. And this would allow other types of characters to theoretically be used by this player input class. So when you make your class type more generic, it would allow more types of objects to actually be used here within the script. So let's assign to the player input our export properties. The character is, of course, the player. And then the actions, we already created that. I'm going to load this from the project with quick load. And we have our player input actions. So we put that in there. And if we click on the player script, you can see that the player input actions is no longer needed there. So we're not concerned with the input actions or the player input inside of our player script anymore. We're only moving the character body based on its directional input and its move speed. And that's basically all that's going on in the player script. So if I hit play now, it's going to work exactly the same way. I can still move left and right. The facing script is controlling the left movement, and the facing script is controlling whether the animated sprite faces the left and the right. Can also once again be used for other nodes if we put any collision shapes down there, like a hitbox over here, if you want to flip that to the left or the right, depending on which direction the character is facing. But yeah, we're just kind of starting to take our character and separate it into different smaller scripts that all work together to generate the final behavior of the character. So I just thought that it would be a good idea to get that out of the way now before we start adding a bunch of extra script logic to our player and we end up with a very bulky player script. So now that we've done that, we can also add an action to our player input actions for jump and then work on the gravity affecting our character. So inside of player input, I'm just going to click on the script to open that up. We want to add to player input actions the jump action. So I'll right click here and look up symbol. So that jumps us into the player input actions class. And we can do @export var jump, which will be a string name. I'll use tab to get over to the same spot as the other colons, and then string name, and we'll default this to jump. While we're at it, since this is going to be a projectile-based platformer, we're obviously going to have some kind of shoot action. So let's @export var shoot tab colon string name, and I will just call this shoot as well. So that'll be there for later, and we can go to project settings input map, and we can define those. So it looks like I actually forgot to assign S as the down key. So let's do that now. Add input, press S to automatically select the S key. Okay. And let's also add in those other actions, jump and shoot. So jump, shoot. So for jump, we could make that, let's say, spacebar. So just add a key, press the key you want it to be, or the button on your joystick. And then shoot, add event, and we'll do left mouse button press. Okay. And close that. So next up, let's go back to player input. Where we have physics process and we're getting the direction, I think I actually want to change that to process so that we can get this direction possibly more than one time per physics frame update. So physics process usually runs at a set number of times per second, but in that fraction of a second, we might actually change our input. So we could probably improve this a little bit by doing _process. And then getting the vector here. So having the input be got on a process frame instead of a physics process frame just means that potentially we can update that 1, 2, or 3 times, maybe more, per physics frame update, depending on how often the physics frames are actually updating. So it'll basically take the most recent input, and when we get to the physics frame, it'll update with that. And I think that might make the character feel a little bit more responsive than having the direction be gotten on a physics frame. So that's what we'll go with for now. And just keep in mind that when you have code executing on the process function, it's going to be updating on every single frame of the game. So it can be kind of resource intensive, but For this, it should be perfectly fine, just to be aware. So now we also have other key presses that we need to watch out for. So we can handle those in, let's say, unhandled input. Unhandled input meaning if nothing else in our scene consumes the input first, then we'll execute the code in unhandled input, as opposed to function input, which I believe will execute that no matter what. So if some UI is consuming the input, we don't want the jump key to actually execute or the shoot key to execute. So that's why I'm doing unhandled input instead of underscore input for the function. Okay, so when you have unhandled input, you get an event, and this event may have an input action associated with it, like these string names up here. So if we check if the event action is the jump action, then we can execute a jump or execute a shoot action for our character. So let's do a if event.isActionPressed, and we're going to check for actions.jump. So if jump is pressed, then we want the character to jump. So for the actual movement of the jump, I think that makes sense to have on the platformer character. So now we could say character.jump and just run that function, which currently doesn't exist. So at this point, you might actually decide to take the character and change this from platformer character 2D to player. The reason for that is that maybe not every platformer character can actually jump. Maybe a lot of them can only move left and right. So if that's the case, then you may want to just take this and change it to player. Now, that's not really going to cause you issues because in player import, we've already assigned this as a player. So you see, even when we change the class name, it doesn't unload this property or anything like that because the player was already a player character 2D. And now we're just being more specific and saying it needs to be a player because this character needs to be able to jump. But maybe we change the property name to be more reflective of that. So if you want to rename the property and every instance of the property in the script, just fix everything at once, you can double click on the text you're trying to update, hit Control R on your keyboard, and then replace it with what you want. So we want to call it player. So player. Now to be careful about this, there might be cases where you have like a comment and player would match there. So you may want to check match case so that only the lowercase instances of this text. And if you want to be more specific, whole words, just making sure that you don't like rename comments or anything like that unless that's your intent. So we have these three instances selected. If you see the gray box around them, we can replace all, hit Control S. And now we do need to reassign the property because the property name changed. So just assign that to player. And we're all good. So I know I'm changing the code around quite a bit to update it as we go, but hopefully you can see that like as your requirements change, you can use some of these tricks in order to update your scripts very fast and not really run into too many issues as you are kind of updating your game prototype. So we require player to have a jump now. If I was to go hit play and we press the jump key, which is spacebar, it's going to give us an error because jump does not exist on the player script. So we can go into the player script now. Okay, so now in the player script, we're going to create the jump function. So function jump, notice no underscore because this is a public function, so calling from other classes. We don't probably need a return type, so we don't have any need for this. Unless we wanted to say that it was like successful or not, then we could return a Boolean. And this will say, makes the character jump if possible. So we might want to decide for our character, what are the conditions where our character would be able to jump? So first off, a basic character would be able to jump on the ground. You can add double jumping for your platformer character, where you can do like an air jump. That's super common. So inside of our player script, let's first check if the character is on the ground, and then we can do a ground jump if that's the case. So let's see if self dot, let's see, ground or is grounded. So let's start by checking if the character is on the ground, and if it is, then we'll allow a jump. So if is on floor is a function that you can get out of character body 2D. Now we can check if is on floor or is on floor only. So if you wanted to prevent the character from being able to jump when it's also on the wall or also on the ceiling, then you could check this instead. For now, we'll just do is on floor. So if the character is on floor, then I guess we'll execute the jump. I'll go down here and create another function called jump. and I'm going to make this a underscore for private. But here, I'm going to rename this one to be try jump. And let's return a Boolean, whether the jump was successful or failed. I said I probably wouldn't need to do it, but when I think about it, I think this makes more sense. So if is on floor, then we're going to jump. And after we jump, we'll return true for a successful jump. If we get down here because the character wasn't on floor, then we'll return false for a failed jump. And let's go down here and add a comment. Returns true if jump successful, or false if failed. And then the jump itself will be modifying the y velocity. So velocity.y plus equals, let's say a jump force, because this is going to be instant and it'll decline over time due to gravity. So let's add a export range up here. At export range, let's say 0 to 100, 0.2 or greater. We can modify that later if we need. Var jump force, which of course is a float, and I really don't know how much we need, so we'll say 100 to start. And of course in the inspector you can modify it as you need. We won't allow negative jumps because that's kind of weird. If you really needed to have the character jump upside down, you'd probably flip the character upside down with like scale Y and then add the jump, which would make it propel in the negative direction, negative Y direction. But yeah, that might be all we need there for right now. So let's jump into player input, and we're going to call, instead of .jump, we'll do try jump. So we're requesting a jump from the player, but it's actually the player script itself with its try jump function that's going to determine if the jump executes or if the air jump executes. And we'll return true or false whether the jump or air jump executes, just as basically an informative piece for any other scripts that need to know about it. And we could give a comment down here, execute a ground jump. For the air jump, we might have an air jump force that's different than that. So later, I guess I'll create a function air jump, which will add the air jump force instead of the jump force. You could also rename this ground jump force if you want to be really specific. Okay, so let's hit play, and I'll hit space, and we'll see what's going on. So when I hit space, nothing really happens. So what we want to check in player input. So what we're going to want to do is set a breakpoint here to see if player.jump actually executes. So let's hit play and spacebar, and we can see that it does hit here. So why is our character not actually going up? Well, if we jump to the player script, we can, let's say, add a breakpoint here and hit continue or F12. And we see it's not actually going there. So our character's not on the floor probably. Let's set a breakpoint there. I'll hit space, and let's check our character and see if he is on the floor, if that property actually shows here. Okay, and I'm not seeing that being publicly showing. So let's stop that for a second. And what I'll do is I'll create a variable is on floor, and this will be equal to the result from is on floor. And then we'll use that over here because this is a Boolean. If you not required, it's pretty obvious, but you can type this if you want. And now when we hit play and hit spacebar, we'll be able to see that local variable is on floor. Is this on floor true or not? And we can see is on floor is actually false, which is odd because our character does appear to be on the floor. So we need to figure out what's going wrong. So let's actually take our player and hit W, move him up here and play and see, okay, gravity isn't affecting the character either. And that's probably a big part of why it's not showing on the floor. So we can always check the error log and see if there's anything weird going on here. None of these warnings should really be causing an issue, but we can go ahead and clear them up right now. So if we double click here, we can see that this delta is never being used in physics process. So if we want to eliminate that error, just give it an underscore and indicate it's never used. If we click here for the is on floor, well, this has the same name as the function. So we might want to rename that. Or really, I think in most cases, we could just take this and put it back there and just use the function call instead of having the variable. We already kind of checked that it wasn't on the floor, so we don't really need that variable there right now. This is already clear enough. If it's false, then it's not going to jump. And if it is true, then it will jump. And then we have that third one over here in player input. Can add an underscore delta. Just make sure if you are trying to fix this never used property thing. That if you ever do use it again, you just remove the delta because now it is expected to be used by this function. Okay, so that'll eliminate all of our warnings for now. Okay, so if I recall, what we actually need to do in our player script is to add the gravity in. So the character body 2D by default doesn't have gravity added to it. If we check project settings, and we search for gravity, we can see that there are settings here, which we can use and pull from to add the gravity to our character. So on physics process, after getting our left-right import, we do want to update our character with the gravity. So we'll say velocity.y plus equals, and let's say get gravity, which is a function we can use, but we're going to times that by the delta, which is the time between physics frames, so that the character moves at a consistent amount, and that's based on the amount of time that has actually occurred. So times delta. Now you might see that we put the underscore there just a second ago because we weren't using the delta. Now I want to get rid of that. Okay, so we can see that a vector can't be automatically applied by a delta float in Godot, but we can easily work with that. So let's actually create a function here, apply gravity, and then we'll take this bit in here and pull it down to the bottom, apply gravity, and I'm going to paste that in. We're actually going to make this underscore for private as well. I can't imagine a reason why another script would be needing to say this, because the player is going to manage its own movement, basically. And then we have velocity y, and we're going to plus equals the y gravity. So a vector 2 is going to have an x and y. So let's say var gravity equals the get gravity here. Okay, so we're only calling get gravity once, and then we take gravity, paste that down there, times y, times delta, which we need to actually pass in. So delta float. Okay, now for the function, that means we need to pass in the delta up here. So apply gravity, delta. So we pass in the delta, and then we get the gravity for our character. And then we're going to plus equals the y gravity times the delta onto the y velocity. Now, if we check project settings, you can see that it is actually possible to do a x vector for the gravity. So you could, in theory, have gravity going to the left or the right. Maybe certain game levels are kind of like that. So what we can do is say velocity.x plus equals gravity x times delta as well, just in case the x gravity is in fact not 0. So with that, we can hit play, and we can see that our character is actually falling, which is kind of what we want. So before we fix the falling through the ground issue, I want to take apply gravity and move it up a level to the platformer character 2D script, so that any platformer character 2D has the option of applying the gravity to itself, as most characters would, but all characters should really have that option. So let's cut this function with Control X, go to Platformer Character 2D, right-click, look up symbol, and just paste it in there. So now if we have an enemy, our enemy can also call apply gravity in its process or physics process functions, just like the player can. And if we go back here and Control S, we should be able to resolve the issue where apply gravity doesn't exist because it's now coming from Platformer Character 2D as a parent class. Okay, so why is our character falling through the floor? Pretty simple. The reason is that our tile map has no physics collision shape. So that's very easily fixable. If we click on our tile map layer, and we have tile set expanded here, so we can go to tile set at the bottom, open that window, and we can edit our tile set. Then we want to paint on physics layers, but we haven't added a physics layer to this tile set yet. So expand physics layers, add a physics layer. We'll just leave layer 1 as our ground. So if we want to name that, which is a good idea, click here and edit layer names. So we'll call layer 1 ground. So anytime we want to collide with the ground, we reference layer 1 in the collision mask for, let's say, our player or any other objects, possibly arrows or anything. And now that we've done that, we can go to paint, select a property, select physics layer, and let's click on these tiles. So left click, left click, left click, or you can press and hold and just add the physics shape to all of those. Now, we can see that it might be a little unfair at the corners for this to actually be collision worthy. So if you want to adjust that, you can add more points on the collision shape here, so to speak. So I'll press left click there to add one and left click there to add one, and then pull this inwards. So now these corners shouldn't cause collision. Also, you might want to pull this in 1 pixel and 1 pixel. You can zoom in if you need to. I think there's also a snap to pixel option, so we might want to toggle grid snap, and make that, let's just say 1 pixel. And we probably want to do half pixel snap. We'll kind of just adjust these points to get the shape we want. And up there, only the solid grass, not like these individual pop out pieces, are going to block out collision. So that's a bit more involved and a little tedious if you do that to all the squares, but it might be worth it. So I'll click here to assign what we just adjusted to there. Now you can also rotate and flip these with R, E, H, and V. So if I press R to rotate, I can left click there and assign the new collision shape there. R to rotate, R to rotate. Okay, there's the 4 corners. And now we can kind of do something similar with these. So let's reset to default tile. Press there, left click, and just pull these down a little bit at the top to there, and on the right side to there. So that's going to give us that 1 pixel buffer. Now we can click there, so it's consistent with our side pieces. R to rotate, click, R to rotate, click, R to rotate, click. And now we've created a good collision shape for all of these pieces. And if we go to the top window, we can do debug, visible collision shapes, and that'll show the collision shapes when we hit play. So let's hit play, and there we can see the collision shapes of our ground. If we hit spacebar now, it's still not jumping, but at least we're hitting the ground. And we can also see the collision shapes apply up there at the top. And we have like a little bit of a curve here on the sides. Depending on the game, you might or might not want that, because you can see that kind of lets you kind of curve around the edge. So it's up to you if you want it to be like a pure classic box, or you want that kind of curvy collision shape. Okay, so why is our character not jumping? Let's figure that out. In our player script where we have try jump, let's do a print, and I'm going to print is on floor. So this is for debug. Obviously we're calling is on floor twice, but this is just to get a console of the true false value. So let's hit play and let's hit space. We can see that, oh, our character is actually on the floor, which probably means this is executing. So if I hit space, okay, we come here, we add the jump force. Yeah, so now that I think about it, in Godot, I believe down is positive and up is negative for the Y value. So we actually want minus equals the jump force. Let's run the game again. I remove the breakpoint, we hit space, and there's our jump. So that's my bad. You subtract the jump force to go up. So negative values to come up here, positive values to go down. And our jump isn't very high, so we might want to click on our player and increase the jump force, let's say 300. And this is the instance of the player, not the original player. So you can see in the original player scene, it's still 100, but out here in level, it's 300. So be aware of that. We're changing the copy of it inside of this scene, not the original values. So if we come in here, we hit space, and there's our jump. Our character doesn't move very fast, so we might also want to increase the move speed to like 120. And there we have like much better movement. Now our character can't quite get up here yet, so we could either add in a double jump, or we can increase the jump force. So I'll increase the jump force for right now. Let's hit play. Okay, maybe that's a little too much. Let's make it 350. You can also change these values during gameplay. You don't have to actually stop for that to happen. But we have basic gravity and jumping working there. Now, if you like those values and you want those to kind of be the defaults for your game, you can go into the player script and just change these and update them here. So 120.0, and then whenever you have a new instance of the script, these will be the default values. So jump force 350.0. If you save it, then we should see that they kind of reset there. If they haven't, then it's probably because the value is different in the player scene, not the instance, but the original saved one. So if we reset that in there, it should reset to the script default. Okay, now any copy of the player should move basically like this. And that's pretty much it. So to show one more thing, when our character is not on the ground, if I hit spacebar a bunch of times, you'll see that it's false because is on ground, it is false. So that kind of confirms that our is on floor check is working. We can remove that. So for now, our character can only do a ground jump. But I think we'll leave it there for this video, and we'll work on animations and possibly double jumps, adding in the shooting functions and all of that stuff in the upcoming videos. So thanks for watching to the end. I'll have the snapshots of the course for this part 2 video in the Ko-Fi and Patreon links down below. And hopefully I'll see all of you guys in part 3. So in this part 3 of the Projectile Platformer series, first I want to do a little bit of cleanup before we continue, and then I think we'll start setting up a simple projectile for our character. It won't be the final one, but we can at least get started with having our character be able to shoot something. So first off, with 1 bit, generally the background would be a solid black color. But since the start, it's just been a gray, which is the default background color when you don't have any tiles showing over it or any background images. So if we want to change that, we can go up to Project Settings, and I think if we search for color, we should be able to get it. Rendering Environment, and we can change the default clear color here to just a solid black if that's what we prefer. So if we think that looks good, we can do that. Or we can try changing it to something else too. It doesn't necessarily have to be black. 1 bit just means that you switch between 2 different colors. But I think we'll go with the black for now. So let's close that. So after setting it to black, I'll just close that out. And just to make sure that it's running in game like that as well. Well, there we go. We have our black background. So as much contrast as possible with the white. Okay, now I want to jump over to the player script, and we'll see that we have the try jump and jump functions. So the player obviously needs to be able to do that, but many platformer characters, whether that's like an NPC or an enemy, may also need to be able to jump. So I think what we should do is take our jump functions, so that's underscore jump and try jump, cut this away from here and put it into platformer character 2D. So I'm just going to paste that right in there under the direction property and save it. And then if we go to player and save, well, it looks like we also need to bring in the jump force property. So I think I'll grab both of these over to platformer character 2D as well. Let's put them above direction and save. Okay, and now jump force is a property in the platformer script, so that should be able to save. And if we go back to player and hit save, we should be able to do that. So really the only thing the player is doing now differently than platformer character is that it actually has a physics process function for controlling how this character moves. So in 2D, let's hit play and make sure the character is still working. Okay, cool. The advantage here is now that we have the same code that will be shared with other enemies that might need to jump later. Though how the jump actually executes is going to be based on that enemy's logic, not player input, is really the main difference. So as a condition for that, maybe we should go to player character, and above jump force, I'll add a @export var can ground jump and set that to true by default. Or if you prefer, you can just have all your Boolean toggles off until you manually turn them on. So maybe we do it like that. Can ground jump is false, and then you have to manually set it in the inspector for platformer character 2D, like here, if you want the character to be able to jump. Up to you if you prefer those to be off or on. So as an extra condition here for try jump, we're going to want to put can ground jump and is on floor. So now if the character does not have ground jump enabled, then the jump is never going to work. This is also useful if you ever need to just disable this one function of ground jump, so that let's say there's a scene where you have a player that moves left and right, but for that scene you don't actually want him to be able to jump whatsoever, so you're restricting the player, then you can do that with this Boolean toggle as well. But also useful so that for characters who are platformer character 2Ds that shouldn't be able to jump, like let's say you have a flying enemy, then you can just disable it here. And you don't need to worry about the jump force or any of the other properties because it's already disabled. So that character already won't be able to jump even though the code is technically there for that character. So let's hit play and I'll show you that I hit spacebar and the character can't jump. But if I toggle it on here, then once again, our character is able to jump. So you probably want to save that property on in the player scene to just make sure our player can still jump. So now in the level view, if we look at our tile set, we can see that there's like a bunch of extras we can add to our scene. So we might want to do that for a bit. So why don't we rename the first tile map layer ground layer, and then I'll right click, add another layer. So that's going to be a tile map layer, position it above it. And then let's rename it and call it the foreground layer, as in the objects that are sitting in front of the player. So I just want to have these tiles in the foreground layer. So on foreground, make sure that the tile set's set to the platformer one. And then I'm going to select the tiles and just put them in where I want to have some trees. So I'm selecting 2 tiles at once so that I actually basically post both of them around the scene. And we can have like some random foliage. If you want to kind of go randomly between these, you can select all 6 and then click the random button. And then when we left click a tile, it's going to randomly put in one of those 6 types of foliage. You can also set probabilities on the foliage if you want. I think you do that in tile set, and then you go to, let's see, paint, property editor, probability. And if you set the probability to something different than 1, it's going to show up more or less depending. So if you have a higher probability, like 2 or 3, then it's going to show up 2 or 3 times as much if you're randomly generating compared to a tile that has a 1.0 probability. And obviously you can go below 1.0. For right now, I don't really think that's needed. Just wanted to show that. So yeah, this is helping a little bit. Now, I also noticed that these tiles here look a little awkward with the trees. So I'm almost thinking that this isn't actually supposed to be the ground tile, to be honest. This is my first time working with this specific tile set. So maybe we need to set up some of these, because this looks more like it would be the ground for what goes under the tree. So let's go to ground layer on the top left, tile map, and then we'll select these tiles here and just kind of draw there and see if that's a little better for us. Of course, there's some other types of tiles we can choose, but let's kind of see what works for us. And we can set up a terrain again as well. So if we want to do that, we should add another terrain in the inspector for ground layer. So down here for terrain sets, let's add one, and I'll call this ground 2. I don't really know precisely what we should be calling these, but we can rename that terrain later if we need to. So to set up ground 2, we'll go over to tile set at the bottom, paint, and instead of probability, we're looking for terrains, and terrain set 0, ground 2. So we can set all of these. Okay, so you might notice that this set actually has a bunch of other pieces as well. So let's basically select all of these. And although it looks like there's nothing inside of here, I think we still need to set the bit mask to the inner pieces, not the outer pieces, because this is still on the inside part of the terrain that we're trying to auto tile. So it should still look like this. And we might need to create a manual tile there for like the blank space, but we'll come back to that in a second. And then this goes down like that. This is just a one piece in the middle, and then over here like that. And you can right click to remove if you make a mistake, but I think that is basically how our bit mask needs to be, minus this one tile. So to set up that one tile, let's click it just in setup and then one click. Okay, nice, that was easy. And then we add it to our ground 2. And then this will be our centerpiece. So we want to go to tile map now and terrains, ground, and let's drag over the space where we had previously set the dirt tiles. So kind of like that. And we can see that's going to be our ground. Now, obviously this means that there's a lot less inside, but maybe that's actually preferable. Okay, let's try getting this bit in here, and I'll left click and go up the edges. Still no corner pieces, but that's okay. And to make the bottom like way further under, I might use the rectangular tool and just drag this further too as well. Okay, so yeah, I just thought it would look a lot better if the trees were actually flush against the ground rather than with these tiles up here where there's like that 1 pixel where it's mostly black space. It just feels like that wasn't intended to do for trees, so to speak. So maybe this is a little bit more correct. So, oh, well, there we go. We still need to add physics into the trees. So if we remember how to do that, if you go to paint mode on tile set, we just do physics layer 0, and we can add that to all of these squares. Now, you can see for these squares that all of their pixels go flush against the edges, so we don't actually need to customize the physics shape at all. Just having a like a solid square will be perfectly fine for those. While we're at it, if you want, you can just add in these other ones as well. Maybe we go to setup and click there for an extra tile. All of these are perfectly square tiles, so setting this up is basically as easy as it can be. You just gotta drag over all the tiles with the physics shape for ground, and that's pretty much it. So later on, if we ever use these other sets of tiles, then they'll already have their physics set up. And now we can hit play and have our character move around the scene. If we want, we can turn off visible collision shapes and then restart the scene and kind of see a bit more how it's actually going to look. So not too bad. Maybe we need to make the ground run on for a lot longer. So for our level, we can still just take the ground terrain, ground layer, terrain's ground, and drag this out a lot further and worry about the details later. But it's kind of weird if our level ends after, like, you know, 5 seconds of walking. So just take this out as far as you want it to go. E for eraser tool if you need to remove a layer of these tiles. One more time, we can get a general sense of the feel so far. So pretty much where we need to be to start setting up some other mechanics and probably some basic enemies. So I'm going to jump into our player scene. And for our player, when we are setting up a projectile, we're going to want a launch point for the player. So I think by the end of the series, what we're going to do is make it so that the launch point actually follows the mouse cursor. So it'll be a distance away from the player, but rotated around in a circle so that we can kind of shoot in all directions depending on where we aim the mouse. And maybe we'll put a little sprite for that too. But let's right click for now, and I'm going to add a child node. So this will just be node 2D, and I'll call it something like suit position, or maybe positioner. I think I like that a little better. And I'm going to hit W, and I'm just going to move this away from the player. So this will basically be the point where we instantiate a projectile from whenever we are pressing our shoot button, which I think we already set up in project settings import map. So we have the import there. Then we just need to press the button and make sure that we execute the shoot action. So since positioning where we instantiate the object and actually calling the shoot function are so closely related, I'll put those in the same object. So I'm just going to call this the shooter, and let's right click and attach a script to it. So we'll call the script shooter.gd. I'm going to put it in characters instead of player, since this is not really specific to the player. Just like any character that needs to be able to shoot a projectile is going to probably reuse this script. So I'll put it in characters instead. And let's call the script shooter. So our shooter class is going to launch projectiles when try shoot is called successfully. There might be some conditions where a player or a character can't shoot, for instance, being out of ammo. So I think having a try shoot method is making some sense. So we'll have a function try shoot, which is going to return a Boolean. So for now, I'll just have it return false because it's not implemented. If you want to be fancy, you could say something like push error and then not implemented too, which will put an error in the console log whenever you call this function and just make it very, very clear that you haven't written the code yet. Then we'll also have function shoot underscore shoot, which when try shoot conditions are met, will shoot a projectile. And then in order to shoot something, we need to know what our projectile is. So I'll say export var projectile, and this will be a projectile class. So I'll actually create this resource projectile. And for that, I suppose in our project, I'll create a resource folder for weapons. So if we right click in here, do a new folder for projectiles, and then I'll right click here and do a new script, which will be a resource, and I'll call this projectile.gd. Okay, so this will be class name projectile, which is a object that can be shot. Not every projectile necessarily would do damage, but the idea is that it can be fired from some kind of projectile weapon, like a bow or something. And then we need to set up the properties for this, which you probably want something like a display name as a string name for the projectile. So that would be how you want it to be represented in game if you ever need to refer to it by text. We could say that each projectile can have an icon, which I think is a texture 2D. And it's going to need a scene to instantiate. So export var scene, a packed scene. So whenever you instantiate a projectile, you're instantiating a packed scene. So when we're thinking of a packed scene, you should think of whatever you build in the scene editor, all of the nodes under it, when you save it to one file in your project as a .tscn. So then you can create copies of it by doing the packed scene.instantiate and then add it as a child to your scene and position it where it needs to be. So this might be the basics of what we need. We can always add extra properties to it. So let's go to shooter and Control S here to save it. And then in shooter and the inspector, we should be able to see it as a exported variable. But currently I don't. I'll actually reload the player scene in the hierarchy. So player.tscn and see if it pops up there. Okay, still doesn't. I'll even try reloading the project. Okay, and this time it actually loaded. So you can try that if it wasn't working for you. So we need to set a projectile in the shooter in order to have something to launch. So let's create a new projectile here. Remember, projectile is a resource. And we'll give it the display name basic, I guess, basic projectile. Icon, well, we could select a atlas, right? So I'll do new atlas texture. And then from the atlas, we want to quick load the monochrome tile map package and then edit region to select what we want as the icon for our projectile. So I'll change this to grid snap and let's zoom in here. Now this pack doesn't really have any projectiles, so to speak, but I'm just going to kind of work with what we've got. So I think that these kind of look like a bullet. So I will select this as the icon and then as a scene, we'll need to create a new scene. So let's create that up here. Control S to save the player first. And actually, let's save this projectile to the project. So in weapons, projectiles, I want to save, let's say projectile basic.tres and save that there. Okay, so that just saves the resource to the project. So it's not solely existing in this scene, but in the project itself. Now let's create our actual instantiatable projectile. So add a new scene, 2D view, 2D scene. The root of our projectile, let's see, what type do we want that to be? Probably some kind of body. If you want to apply physics to it, then rigid body makes sense. So if you want your projectile to be easily affected by gravity or that sort of thing, then you can make it a rigid body 2D. I think I would point out in my testing, I've seen that rigid bodies 2Ds are a lot more resource intensive because obviously they're part of the physics system. If you just want to manually move everything in code, then an area 2D might make more sense. So you have to move it manually and then you detect when the area enters another object. And then you can do stuff like damage the enemy and remove the projectile. So for this project, it'll probably be perfectly fine if we have like 50 bullet rigid bodies in the scene. But you may want to stress test your game and make sure that if you have like 500 or 1,000 bullets on the screen, that it doesn't start causing problems. Or else you might need to drop the rigid body 2D and try a different component as your root for your projectile. So let's rename this and just call it basic projectile. I'll save it to the project under projectiles. So basic projectile.tscn. And we're going to need a sprite or animated sprite for this. So let's search for animated sprite 2D. In the animation, I'll do a new sprite frames. Animation we can leave set to default, the FPS 10. And then I'm going to add frames from the art pack. So of course we want probably these 2 frames, or we can take all 3 of them as well if we want. So let's see. We got to make the size 16 by 16 over there. And then 1, 2, 3. Add 3 frames. We can hit play. And if we zoom in, that's kind of like our animation there for the projectile. I think that kind of works. I was thinking of going like 0, 1, 2, 1. If we want, I think you can copy and paste that. So let me see that. Copy frames and then paste frames after. Yeah, so that does make it look different. This is a little bit more dramatic, but you can see the difference there if you have the 1 frame also be the 3 frame. But honestly, I kind of like this a little better. So we created the projectile script, but we also need a projectile script of sorts to attach here to the actual scene instance. So for the projectile script we already created, I'm actually going to rename that to something else. Let's call this a fireable and save that. And I'm going to rename the script fireable.gd. So then in shooter where we need a fireable, let's do fireable and then fireable as the type and save that. And then that'll free up the name for projectile, which will actually attach to the basic projectile. So when we shoot a fireable, we get a projectile in the scene. I just thought that makes a little more sense name-wise. So in basic projectile scene, let's add a new script to the root, and this will be projectile.gd. I'll create the script, and it doesn't necessarily need to extend straight from rigid body 2D. We could try something like physics body 2D, which you can see already has move and collide as a function and can get the gravity. So probably no need to constrain the script to that level. So I'm actually going to extend physics body 2D for right now, and we'll give it the class name projectile. And in a sense, the projectile is going to be a moving object launched from some source that can collide with other objects inside the scene. When you do the two hashtags like this, that's just setting a comment describing the class. So if I was actually to search projectile within our project now, if we reload, we go back to projectile. Okay, so for our projectile, we're going to need a move speed. So export var move speed is going to be a float. And let's set that to something like 300. We can also make this at export range like we did with the other properties. So at export range, and this would be 0 to 300, 0.2 or greater. Control S, and then that gives us this little slider bar, and we can't go below 0. So we'll reset that to 300. And so when our projectile enters the scene, we want to set the speed or the velocity of our projectiles. So I guess we can do function ready. And we want to take, let's see, do we have velocity on this? Or does velocity actually only exist on a rigid body 2D? So for a rigid body 2D, you would actually use linear velocity. You can either set that directly if you want to manually override the speed, or you can add forces to the rigid body with like apply force. So basically, it'll take the mass and the amount of force and use that to calculate how much extra speed that gives the object. So rigid bodies can get a little bit more intricate in that way, but we can keep it simple on the launch. But we do have to make it extend a rigid body 2D now, because linear velocity is of the rigid body 2D class, not the physics body 2D class. So we'll say linear velocity is equal to, or we should say linear velocity.x is equal to the move speed. And the way that we will basically control the projectile's movement in non-left, right, x values is that we will rotate the object. So even if it's moving on left, right, if it's rotated a certain number of degrees, then it will actually be moving in terms of game space at an angle. So let's actually rename this to be initial speed, or initial velocity, I guess. And we'll rename that, save that, and yeah, I think that should be okay, actually. So in our basic projectile scene, we do need to give a rigid body a collision shape. So we'll right click here, add a collision shape. And this is kind of a spherical shape. So if we do circle shape, it's gonna make perfect sense here. I'll shrink this down to be, yeah, actually right there. Seems good. So that was like a 3 pixel radius, so 6 pixel diameter. And we could test this scene. It should move actually. And there's our projectile moving with gravity. So if you want to turn gravity off, you can just take the gravity scale and set that to 0. Or you could set it to something like 0.1 gravity scale if you want gravity to still affect the projectile, but for it to actually still keep falling a little bit. So just for right now, I'll leave the gravity scale set to 0.1. Let's go to our player scene, and we're going to have the shooter, right? So we need to assign our fireable, which, well, yeah, I guess we did rename the projectile basic to be fireable. So we should rename that resource as well, fireable basic. And for that, we need to assign the scene. So quick load, and we're going to quick load the basic projectile as the actual scene we instantiate. And we want to set that in the shooter up here. So our default fireable is going to be the basic projectile shot. So now we actually need to instantiate the projectile at this position using the shooter script. So if we click here, when we try shoot, we're not going to have any ammo yet. So we're just going to actually shoot and then return true. I'll give it the return false for right now. Eventually, we probably will have some conditions here that might make it so that you can't fire a projectile. But for right now, that'll work. So inside of shoot, we're going to get our projectile by instantiating it. And we're going to do fireable, if I can spell, dot instantiate. Oh, wait, fireable.scene.instantiate. And when we instantiate it, we want it to be as a projectile. Okay, and now we need to know where we're going to add it as a child of, right? So in the level, we probably want to have a group node here for holding all of the projectiles. We don't want to make the projectile a child of the player, because if we do that, then first off, deleting the player would delete all the projectiles too, but also as a node hierarchy situation, if we move the player, it's also going to affect the position of the projectiles. So that's not great. So if we go to, let's say, level 1, we could right click here and create another node 2D for, let's say, and hit OK. Okay, so projectiles is right here as a group, and we can access this group name to find this node and then add all of the instanced projectiles to that node. So let's go into the shooter script. So when our shooter is starting to get ready, let's say function underscore ready, we want to grab the projectiles node. So var projectiles node, so there should be some kind of node at least, and we'll say projectiles node equals, we'll say equals to get tree, and we'll say dot get first node in group, and that'll be the name of our group. And so maybe for our group, we call it something more like projectile parent instead of projectiles. So I'm going to go back to the level scene, 2D. We have our projectiles node here. I'm going to delete the global group projectiles. I guess we only really need it as a scene group. So let's add a local group, projectile parent, and hit OK. So in player now for shooter, we can give it the name here for the projectiles parent. So I want to make that a export var. So I'm going to say projectiles parent group, and that'll be equal to projectiles parent. Okay, and now we put this down there, first node in the group. We're looking for projectiles parent. If we wanted to be a little bit more consistent here, and instead of setting this on every instance of the shooter, we could actually create a group name script and a resource for that, and then share the group names that are important to our game across every node in the game. So set once and share everywhere, basically. So I don't know, I might create a folder here for like data, and let's create a new resource. Let's create a script for a resource. So it inherits from resource, and I'll call this group names.gd. Now we'll open this up, give it the class name, group names, and then we just need to basically pull those fields into here. So shooter, we had projectiles parent group. Let's cut that out to group names and paste that in. Okay, so now we need a actual group names resource that has that data. Let's create that. So a group names resource, we can just call it group names because there's probably only going to be one. Save it in data, and you can see we have it here. Now we want to reference that in our shooter script. So at export var group names, which takes a group names resource, save it. And instead of doing projectile parents group, we're going to do group names dot projectile parents group. If we click on shooter now, we can assign the resource. And now we have these names shared inside of one resource, and we can apply that to every object in our game that wants to reuse those same group names. Yeah, so just basically thinking ahead there, but generally we want to make sure that these names are pretty consistent so that all of the projectiles, regardless of if it's a player projectile or an enemy projectile, gets added to the same parent group, and this is a good way to do that. So we get our projectiles node when this script launches. So now we just need to add our projectile as a child of that node. So projectile.add child projectiles node. Okay, and that is going to mean that in the level, it's going to be under here. So let's go back to the shooter script. And one thing I probably want to do, especially during dev, is to test and make sure that the projectiles node actually is there. Because if we get to the point where we try to launch a projectile and there's no parent here, that's going to be an issue. And actually, I have this backwards. It's projectiles node.add projectiles. So if you want to make sure that something is true, and basically to immediately interrupt the game during development mode, but not during a published version of the game, then you can use the assert keyword, and we can give it a condition. So basically, if the condition is not true, then it's going to break at this line and immediately let you know something's wrong. So I'll say projectiles node is not null. Yeah, okay, I guess that's a question mark equals null. So we expect our projectiles node to not equal null. And that should work basically like what I was trying to do, but I was getting too fancy. Okay, so if we run our scene now, we can basically get this assert to hit. So the projectiles node is not there. And that is probably because the node is not in the group. So if we click on the node here, we can see that the node is in the group projectiles parent. Let's copy and paste this and make sure it's the same name here. Maybe it does actually need to be a global name. Oh, actually, no, it's because there's an S at the end. So we save that. If we hit play now, the node is in the group. So you can see that our script runs. So we just have that little assert to interrupt and tell us that something was horribly wrong with our setup. Like a more solid way of doing that would probably be to get something like GDUnit4 or GUT, which is Godot unit test, and use that to run tests against your game and make sure that everything is set up properly before you go and publish things. But this is like a very, very basic version of that. Just testing things as you run it and make sure that things are set up properly. Now, we have our projectiles node inside of the level, and I think that's a bit redundant. So what I will actually do is create a parent world. So let's add a scene, and we'll call this 2D scene world. I'll cut the projectiles node out of the level and paste it into the world. And then let's save world.tscn, maybe just at the root for now. So the world can basically have levels inside of it and load or unload a level, but then the projectiles is separate from that. So if you do want to clear all the projectiles, you could just get all the nodes in the projectiles node 2D, all the child nodes, and just clear them out whenever you load a level. Or maybe you want the projectiles to persist between levels. So let's save the level, and I would just add level 1 as a default here. So not going to have any fancy level loading script for right now, but that would be the kind of thing that you might put on the world node. And then we want to make this the node we actually load in the project. So project settings, and let's choose the default scene on run. I'm going to go up a level from levels and choose world.tscn. So of course, we're still loading level 1, but now it's a child of the world. And we only need this one projectiles node for our entire game because we're going to be loading and unloading levels, but the world is always going to persist, which means we only need one projectiles node, or projectiles parent node. Okay, now we just need to wrap up with the shooter script. So we added the projectile to the projectiles node parent. Okay, so let's select this and actually rename it to be projectiles parent rather than projectiles node. Okay, just keeping it a little bit more clear. And once we add it as a child to the parent, we want to set its position to where our shooter is. So in our 2D view for the player, that's right here. We want to instantiate our object at where the projectiles base node is right here. We want it to be instantiated at the position of our shooter, but we do want it to be a child of the projectiles node so we can manipulate it here in terms of hierarchy. So the way you do that is just that we get the position of the shooter node and we set that to the projectiles position. So let's see, right here we want to take projectile.global position and we want to set that equal to the global position of this shooter script. So that means that the projectile is going to appear right here. And if we move the shooter around our player, then it's going to change where the projectile instantiates. That is probably most of what we need here. Now we go to player input and we set up our event handling for when the shoot button is pressed. So if event.isActionPressed is actions.shoot, then we're going to do shooter.tryShoot. Okay, of course that means we need a reference to the shooter. So up here at export var shooter is of type shooter. And if we set that on player input in the inspector, let's assign that node. Then now when shoot is pressed, we should be able to shoot with our shooter. Once again, we come in here, that's going to immediately call the shoot function, which instantiates the projectile and sets the global position. The projectile itself is going to be setting its initial velocity. So now that we have a projectile set up, we can go ahead and hit play. And a lot of things going on here, but if we left click, you'll see that the projectile launches. Because it's a rigid body 2D, it can be affected by gravity and bounce off of other physics objects. We can even launch a bunch and they'd be able to kind of stack here. We can jump on them. They are a physics body. So unless we disable the collision layer that they're on, we can actually jump on them and interact, which probably isn't what we want for our basic projectile, but interesting things to think about going forward. Now I do want to add in the basic mechanics of, okay, it hits an enemy, it removes itself from the scene and all that, but this tutorial is going on really, really long. So that is going to be what we're going to cover in the next video. For right now though, we should have a shoot button that works. It should instantiate the projectiles. And to just double check, if we look at our remote view under world and projectiles, we should see all of our projectiles pop up here. Now they give it a default name that you might not prefer. So you can set the name when you instantiate the projectile as well. So I guess that'll be the last thing I'll do here, and then we're wrapping up the video for sure. So in Shooter, when we create the projectile, let's take the projectile.name. All nodes have a name, and we're going to set that equal to the fireball.displayName. So if we hit play now and we launch a bunch of these, then you'll see that they're all called basic because that is the display name of the projectile. And they're just numbered in the sequence which they appear in this scene. So all the way up to 8 and so on and so forth, we keep creating them. And that'll pretty much be it for this tutorial. So we have a lot of the projectile mechanics already set up. I hope this tutorial series is getting interesting for you guys, and I will see all of you guys in part 4 of this series. Hello everybody, Chris here, and in this video I want to take our projectile, which only shoots to the right now, and make it actually aim wherever our mouse cursor happens to be pointed, and then the projectile will travel in that direction instead. So before that, let's go into project settings and change the window size to be, well, I'm going to make it 14 by 880 to be a bit bigger on my screen, so that whenever we do a test play, it's more like this. You can make it whatever size you want. So now I want to give a sprite to the shooter so that we actually have an indication of where our projectiles are really spawning from. So with the shooter, I'm going to right click on it, add a child node, and let's look for a sprite 2D node and just add that in. For texture on the right, I'm going to do new atlas texture. And then for the atlas, we will select quick load from the project and choose the TileMap transparent packed sprite sheet. So let's grab something we can use as the sprite from here. Make sure it's in grid snap mode so we can easily select it. And I think I saw something that kind of looked like a wand somewhere in here. So let me see if I can find that. Ah, yeah. Okay, where's this one? I guess it's really supposed to be a torch. And I'll take the sprite and rotate it by hitting E. And then let's rotate it. Let's see, if we hold control down, we can do it in specific increments. So by default, we want it to face the right, which is 90 degrees. And let's make sure that the shooter position is at the tip of this. So that makes a little more sense. So I'll move the sprite 2D node, W, to go into move mode. And I'll move this over here so that the shooter position is more to the right. So move this further to the left. Okay, and then the shooter point is right there. So I'm going to have to move the shooter further away from the player. Something like there, I guess. And we might even shrink the sprite 2D. So if I go into transform for the sprite 2D, I'll just take the scale and cut it in half. And then W to move it again. Okay, there we have the shooter position. Let's move this over here. So now that it's shrunk, let's reposition it again. W to go to move mode. And yeah, just kind of make sure that the shooter point is right there in front of it. And then we can move the shooter node over to the right here and down a bit. Okay, so there it kind of looks like it's in the character's hand now, right? If we hit play and run, then we can still left click and it's going to be basically firing from that point. Now we want another 2D node, which is going to serve as the anchor point for this sprite and the shooter rotating around our player. So I'm going to add a new node 2D, and we'll make that the parent of the shooter. You can see the hand anchor and the shooter are in the same position. But we actually want the hand anchor to be over here and the shooter to be to the right. So I'm actually going to move the hand anchor to the center of our player. So in transform, let's make this 0, 0. Okay, and now we need to click on the shooter and offset this. So W to move it and by default we want it to be like right here. Okay, so there's our hand anchor. That's not quite right. We want it in the center of our sprite. So W to move that, move it up here, 5 pixels, and then this comes down 5 pixels. Okay, just gonna adjust it a little more. Down a couple pixels, so we do want it to be where the wand / torch is kind of in the character's hand. I know this is just a lot of back and forth a little bit, but let's actually try rotating this now. So if we hit E to go to rotate now and we move this around, we can see kind of where the wand is going to be with respect to the mouse position. So the mouse position is going to rotate the pointer, and that also means that the shooter position right there at the tip of the wand is going to change as well. So that'll be at least the basic idea. As for controlling the rotation of the hand anchor, let's right click and add a new script. So attach script. I guess for now I'll put this in the player folder as a player component. So it'll extend to node 2D. Let's create that. I'll give it the class name hand anchor. And so this will rotate the node around to face the direction of the mouse cursor. So specifically this hand anchor node, which will affect everything that's a child of it or a grandchild of it. And I think we're going to want to do this on function process. So just updating on every frame and pointing our new direction, our rotation, towards wherever the mouse cursor is on the screen. So let's get the cursor position, which is going to be equal to get global mouse position. And then we'll want to get the direction to, which is going to be, let's see here, global position dot direction to cursor position. Let's rename this direction to cursor, since direction to is a function and we don't want to reuse the same variable name. Okay, so now we have the direction from our current position to the cursor position. Okay, so we're going to want to know what our default position is. So our 0 degrees rotation would be facing to the right. So we're going to want to set up our default direction. So default direction is going to be equal to vector2 dot right. We can save that. You can change it if you need to in the inspector. So basically, we're going to get the difference between the X, Y for the default direction and wherever the mouse cursor is. Do some math to figure out the angle, and then that will become our new rotation. Okay, so I guess if you were in a math class, you'd be doing some trigonometry stuff, but I'm just going to use some built-in functions and make it easy if possible. So var angle, or I guess we'll say var rotation angle, is going to be equal to, let's say, the default direction dot angle to point. But that would be the angle between 2 points. Maybe we can actually skip doing the direction to. So hold on a minute. If we comment that out and we do, let's say, the global position dot angle to point, and we do the cursor position. I've never tried this function before, so it may or may not work, but we'll see. And then we just set that to the rotation. So rotation equals the rotation angle, which should be fine because this is already measured in degrees. Let's hit play and see if that works. Well, okay, I guess that's all we needed there. So we hit play, and as you can see, it's actually working exactly as intended there, pointing between one point and another point. So we even got to just skip the directional vectors part. We don't need that, actually. Okay, now I don't super like how small that is, so we might actually increase the size and then move the shooter point up here. Okay, so the sprite will just be like that. The shooter comes over here to the right. Just be sure which node you're adjusting. So we do want the hand anchor to stay there in the center. And let's see what this larger shooter, is that any better? It's a bit comically large here, but I think that actually works pretty good. I am going to crop these 2 pixels off of the torch though. I don't particularly like that part. So if I go to the sprite 2D and let's do edit region, and we turn off grid snap to pixel snap, then we can just pull this up just like so and hit close. Okay, and that's going to kind of adjust how our sprite looks because we're removing some of the pixels. So we rotate around and yeah, I mean, I guess that works pretty okay for a wand. So now the only thing is we also need to cast the direction we're shooting to the angle direction of the hand anchor as well. So in the shooter, let's add the global rotation to the projectile. So this will automatically inherit the global rotation of the hand anchor. We could also directly get the hand anchor's rotation, which if we do some testing, it might make more sense in the end, but let's do global rotation equals global rotation. So the projectile's global rotation is going to be equal to the shooter's global rotation. Let's hit play and see how that works. So I left click, and is that what we want? Yeah, right. It's not the rotation of the projectile, it's the direction it's actually shooting. So let's go into the shooter script. So in the projectile, we actually need that launch direction, don't we? So you know what? I will create a function launch, and this will take a parameter move direction, which is a vector2, and we'll convert that angle to a vector, I guess. And this will take the linear velocity down here and set it equal to this times the p move direction. So we're going to want not the linear velocity dot x, but the actual full linear velocity with xy to set that initial movement. And we no longer need the ready function. So this means that we'll need to call the launch function whenever we set up a projectile so that we can actually make it start moving. So let's go into the shooter script and call that. So we're going to do projectile.launch, and we need our move direction. Okay, so to get the launch direction as a vector, we actually need to take the angle of the rotation and rotate a vector. So the one we want is that default direction that we put in the hand anchor script. But I'm actually thinking that that might make more sense in the shooter script for right now. So I'm going to cut and paste that. Let's say down there. Okay, and then we can take the var launch direction, and we're going to say the default direction dot rotate or dot rotated by an angle, which is the global rotation. Global rotation degrees, I think. Hold on, does this take a radians or does it take a... No, it does take radians. Okay, so we want the global rotation, which is measured in radians. And that should give us the launch direction, which can be the move direction for the projectile when it starts actually launching. So if we hit play now, if I've done this right and we hit play, then we can see that the projectile is going to shoot in the right direction now, which is basically what we're looking for. Now note, it can kind of shoot through the walls. That's somewhat problematic, but aside from that, we are shooting the projectile wherever our mouse cursor goes, which is mostly what we're looking for. So basically, when we're taking that default direction of facing the right and we're rotating it by the global rotation degrees, then we are making sure that the launch direction rotates to the same direction the cursor is pointing, and then we pass that into the launch of the projectile. So the way we have it set up now, we do have to remember that we have to call launch whenever we launch a projectile, or else it's just going to be stuck there in air and affected by gravity and just fall to the ground with no movement. Aside from that, setup is pretty decent, I think. Now, one thing we do want to make sure is that if our pointer is stuck inside of the ground, so I guess we can attach like a raycast to it and just see if it is colliding with the ground already, then we will deny it the ability to shoot. So if we, let's say, go to the shooter and we change this to a raycast 2D type, yeah, I think that might be good. And then in the script, we'll also change this to a raycast 2D. So a raycast 2D is a 2D node that can cast a ray out in a direction. Now the target position we're actually going to want is not 50 pixels down, but 0, 0. And before we actually launch a projectile, we're going to see if this shooter position is colliding with the ground or anything on layer mask 1. And if so, then we're not going to shoot because basically our shooter is stuck in the wall. So inside of try shoot, we'll say if get position shootable, then we'll shoot and return true for a successful shot. Otherwise, we're going to return false. So now we need to create this function. Get position shootable. I'll put it above shoot because that's a private function. So generally it's like public functions and then private at the bottom. So function get position shootable. This will return a Boolean. And in order to do that, we need to check for collisions. So we'll say var collisions equals self dot, what function did we want? Force raycast update. Actually, we probably don't need to do that because I think it automatically does the raycasts on like a physics frame update. So we just need to get the collisions. Let's see. Is colliding. Yeah, you know what? We can actually just use that. So let's get rid of this function. And we'll just come here and say if not is colliding, and we're talking about the raycast there, then we'll be able to shoot. So if I hit play and we aim down here, well, we could definitely see that it's colliding there with the ground. If I left click, then try shoot. Hold on. Oh, we need to reassign the shooter because it's changed its type. So the player input is now going to assign the shooter raycaster. Hit play, and we come down here and left click. Okay, it should not have been able to actually spawn that. So let's see what's going on. So I think what we need is to check hit from inside. So that if we're starting inside a collision shape, we already count that as a collision, which is exactly what we're doing, hit from inside. If we hit play and we come down here, left click, okay, good. Now it's actually not allowing us to shoot, but up here, we're good. So as long as our shooter is not stuck in the wall, we can shoot, which is, once again, exactly what we're looking for. And yeah, it looks like they're not allowed to spawn inside of there either. So cool. So that's pretty much going to cover it for making our projectile shooter rotate around and shoot in the direction of our mouse cursor. Next steps would probably be to add in some targets we can hit with our projectiles and make damage mechanics. So that could include enemies. It could also include destructible objects. We'll see where we get to in the next video. So until I believe it's going to be part 5 coming up next, I will see you guys in my future video content. And once again, if you need the project files, they'll be available on Ko-Fi and Patreon for download. Hello everybody, Chris here. And in this part, we're going to be adding some objects or enemies for us to hit inside of our 1-bit projectile platformer 2D Godot tutorial series. So we already have a projectile, which is using a rigid body and being affected by physics. There's a couple changes I want to make. First off, I don't want the player to be able to actually physically collide with our projectiles like this. So we can do that just by moving the projectile onto a different layer or moving our player onto a different layer than what the collision is occurring here on, which currently is layer 1. So if we make a layer for player and enemy, then we can adjust that accordingly. Okay, so aside from that, for any object in the game we want to be able to be hit and take damage, we should create some kind of damageable component for those scenes. So we might call this something like health, or in other tutorial series I've called it damageable, which would have a health property. And we just need to make sure that anything damageable has that so that our weapons can target the damageable component and deal damage to the health of that component. So let's start off with the first part of making it so that the projectile does not hit the player. If we go to Basic Projectile and we click on the root here, then as a collision object 2D, we can come down here to the collision layers and we can see which layers it interacts on and which layers it interacts against. So the layers it's on is the layer section here, and the layers it connects with is the mask. So we still want it to affect the ground and run into walls and stuff like that. Let's add a couple new layer names. So edit layers. Let's say that layer 2 is player, layer 3 is object, and layer 4 is enemy. Let's also add another one for hitbox. So when I have a hitbox layer, I'm referring to the area where an attack can hit a target, which could be like a player, an enemy, or an object, but not necessarily the physics layer of that player, object, or enemy itself. So we entirely might have a different collision shape for the hitbox than the collision shape for how the enemy stands on the ground, for instance. So we'll have that be a separate layer, and our projectile can hit both the ground and the hitbox layer. But then this hitbox on each of the characters is probably just going to be an area 2D, so physical interactions like pushing the character out of the way won't occur on the hitbox layer. So let's hit close there, and I think that'll be good for now. So we of course want the projectiles to hit the hitbox like that. And if we go to player, we want to change the player's collision layers from 1 to 2. Now it's still going to mask layer 1 because we still want the player body to land on the ground, so we need that mask of layer 1 on the ground. But if I hit play now, our player can land on the ground, but let's launch some projectiles and our player should just be able to walk straight through it. Now that's not the case, so I messed up a bit somewhere. Let's see what happened. So if we go to projectile, it's still on layer 1. And that's probably the issue. We need to change this to a different layer. Let's edit layer names, and I could say layer 6 is projectiles. And then we move our projectile to layer 6. Okay, so now it's not part of the ground layer, so our player should be able to walk through it. Let's launch some projectiles, and some up there as well. And if I walk through it, okay, there you can see our player can no longer physically interact directly with the projectiles. Now when we add a hitbox of sorts to the player should still be able to be hit. Okay, also on the projectiles, I think I want to bump the gravity scale. They do fall just a little too slow. So on the basic projectile, let's take the gravity scale and make that 0.2, hit play, and try again. Yeah, okay, maybe that's a little better. And we'll hit play, try it out, and I think that's a little bit better. You can play around with numbers, so you can just change it to 0.3 in the editor, and now it should already fall faster. So let's go ahead and hit play and shoot a couple of the projectiles, and we can see that they already fall a lot faster, but not nearly as fast as the player does with the 1.0 gravity scale here. So it depends on how floaty you want your physics objects to be. Okay, so now I guess we should add in some kind of targetable enemy to our game so that we can shoot it with the projectile. So let's create a new scene. This will be a 2D scene. I'll change the type with right click to character body 2D, or platformer character 2D actually. Since we made the class name, we can actually create the node straight from in here. We don't have to assign the script manually, because when we create as a new platformer character 2D, the custom script we created is already there. So that should be good there, and then we can extend to make it a enemy later on as needed. So let's just call this enemy for now, and I'll right click, add a facing node, because the enemy is going to need to face a certain direction just like the player. And let's select the enemy as the character node here, and then inside of here we'll do a animated sprite 2D. So for the animation, sprite frames, new sprite frames, we'll extend this and we'll get like our idle animation or something from the sprite sheet. So let's add from the platformer pack, the frames we want for this enemy. So let's control middle mouse wheel to zoom in, and I think all the characters are down here at the bottom. So let's have in these frames for the walk cycle. Add 4 frames, we'll rename this walk, and then add frames. We'll zoom in and get this one at the end for the dead state. Oh, whoops, I forgot to create a new animation. So Control Z to undo that, add animation, and then we'll rename this death animation, add frames, and grab the one where he's on the ground right there. So for both of these animations, change the FPS to 10. So that it's consistent, and if we go to walk and hit play, we should be able to kind of have our character walking there. Yeah, by the looks of it, we might want to take 2 and Control C to copy it, go to frame 3 here, paste it in, and then frame 1, copy that to frame 4 and hit paste. Is that better or worse? I'll hit Control Z a couple times, and that looks more sporadic. Obviously, the walking, we're just talking about moving a couple pixels here. It's really as simple as it can get. Yeah, maybe it's just better like this. Just the original 4 frames. So our enemy from the platformer character inherits the move speed and the logic for jumping. Currently, ground jump is set to false, so this character can't jump at the moment. And we have the facing node, so if we need to switch its facing direction, we can do that. Though for this character, we might not even need to, because it basically is facing the front. Okay, so for our character to get hit, we're going to need some kind of hitbox node. So I'll right click on enemy and let's add a child node. So I'll right click on facing and add a child node, and let's look for an area 2D node, create that. So our area 2D node has a collision shape just like a physics body, like a character body 2D or a rigid body 2D does. But generally it's not there to be affected by physics. So if something runs into an area 2D, it tends to just pass through it. But what the area 2D does is has monitoring and monitorable, so that it can check if something entered it or another area could check if this area 2D passed into another area 2D, and that would be the monitorable. Other areas can detect this area, and then monitoring would be able to detect collision bodies or other areas that enter it. Now, when that happens, all of that has to be handled in code. So basically on body entered or on area entered, you do something with that, and that would require you to, of course, create a custom script. So for this, I'm going to rename this to be, let's say, Hitbox2D, and I'll add a script, and we'll attach this to, it's not even really a characters, it's more of a objects kind of thing, because a lot of games these days would also have destroyable environments. So that would be things like boxes or chests or trees. You'd be able to actually damage them as well. So maybe we create an objects folder here, and I might move characters directly into that later. So I'll have objects, hit OK. And then inside of here, hitbox2d.gd. Let's create that script. OK. And before we start editing that, let's save the enemy scenes. So Control S, I'll put it in characters, create a new folders, enemies. And for a name, kind of looks like a Space Invader from like the classic game. So yeah, why don't we just go with invader.tscn. So if we want, we can also move characters into objects. So I'll right click on the folder, do move, duplicate, select objects folder and do move. Make sure it's not copy because that'll duplicate everything. We want to move it. Okay, and now characters is inside of the objects folder, and all the references inside of the project should kind of update there. It's definitely preferable to use the menu here to move stuff rather than going to the file manager and moving it there. Just because if you move stuff around outside of the Godot engine, who knows what kind of missing references it'll cause for your game. So for our hitbox, rather than reacting to the projectile entering the area, I'll let the projectile detect if it connected with a hitbox, and then read properties from the hitbox in order to deal damage to the enemy object or player. Okay, so in our hitbox class, first I will give the class name hitbox2d, and then we're going to want it to reference, let's say, the stats of our enemy, which will include the current health of the enemy, which is going to be the stat that we directly try to affect. So in objects, we could right click and create a new script. Let's make it a resource, and I'll call it object stats. I think that makes sense for now. Okay, and then we expand this. We'll give it the class name object stats. So this is a set of statistics about an object, and what's important to us is probably going to be export var max health, and then we'll have our current health. So for the health values of your game, you can decide if you want to make it a integer or a float. I think most games would just make it an integer, because if you read damage values on the screen and it's something like 0.2 damage or 0.2444 damage, it's kind of hard to understand. So usually full integer values is the way to go. So if we have every object have a default health of 100 before we change it, then we can do that. Probably say that the current health is also an integer. And we are going to want the current health to by default be set to the max health value. So, and we might change this later, but I'll try setting it equal to max health. So kind of when the script loads up by default, the max health should be set to the current health, which is usually what we want. There would be cases where like you load a game and then you want to load that data into this resource and override that value, but you can do that with the load function when you get to saving and loading data, which honestly, probably not part of this tutorial series, but just kind of an idea there. Okay, so in the Hitbox2D now, we need to have a set of object stats, export var object stats, which will be of type object stats. If we click on the hitbox, that's a resource we can create. So new object stats. Now, these stats, we do want to make sure that they are unique to each enemy. So when we are basically creating our object stats here, you don't want to right click and save them to the project and then keep reusing the same resource like we did with these down here, the player import actions and player sprite frames is also a resource. Because we're not reusing them across different enemies. We actually have a local one for each enemy in our game. So if you just leave it right here, then that is going to be local to the scene. And if you need to put it into a different field, but within the same enemy scene, you can right click it and then copy and go over to a different script and then paste it in. And that's still going to reference the same one as far as I remember. So just be aware of that. We're creating a local resource, not one that's global for our project and shared across everything. Now, of course, another object like a UI can get reference to this object stats from the enemy. And that's fine. They can still reuse it in the UI. But you just need to have one per enemy or one per object in your game. That's the important thing. We have our max health there and our current health, so we should be able to deal damage to the current health. I think I'm actually going to rename the field here just to be stats, and then new object stats. So reason for renaming it just to stats instead of object stats is depending on which kind of character is using this setup, the object stats actually will probably be a parent class to a child class like character stats. Obviously, an enemy is a character and a player is a character too. So we just need some kind of object stats to assign here. Any child class that inherits from here is also assignable here. So just calling it stats makes more sense. Okay, now our hitbox 2D, you can see there's a warning here that we need to have a collision shape. And also, we need a collision shape of the enemy as well. So let's right click on the enemy and create a collision shape 2D. So for our physical collision shape, I might want, let's say, a capsule shape, and let's make it very small. Also the animated sprite, I'm gonna go to that, hit W and move it up here. So remember, I try to make about the feet area where our 0, here is. So wherever we're standing on, that should be about where the feet are located. So either there or like right there. And that's just kind of for consistency between scenes. So let's move the collision shape up and then shrink it to our character size. You can also rotate the collision shape if I remember right. And then we can move this down and shrink the sides in. Okay, maybe that's fine. So it's like a 90-degree rotated capsule shape, and that basically gives us a sideways egg. And then for the hitbox, let's right-click and add a collision shape 2D. So we need to define a shape here as well. If you want, you could actually right-click on the capsule shape here, copy that, go to the collision shape 2D, right-click, paste it in, and then you have the same shape here. But the transform needs to be set individually. So we could do something like -5 on the Y, and then 90-degree rotation. And now we have the same capsule shape being reused across both of these. One's -90 and one's 90. So I might want to change those for consistency. But because this is now a shared resource, I could actually go up here and expand the radius. And you'll see that if I go to the other object which uses this, it has the same radius value, because it's actually being shared locally within the scene. So that's kind of what I meant by the object stats. You'd be able to actually share it the same way by just copy and pasting it within the same scene, and then multiple objects are referencing the same resource, even though it's a local resource and not saved to the project. So let's go with that for now. The hitbox and the collision shape for the enemy itself are both the same, but we have the ability to change it anytime we want. So we could always just assign a custom shape 2D here, and it can be completely different than the physics shape your character interacts with. So now we need to make sure the enemy is actually on layer 3 or layer 4 for enemy. Okay, and the mask should be 1 because the enemy is going to walk on the ground. And you know what? I realized I got the terminology a little bit wrong here. So a hitbox is where you are to actually damage another character. A Hurtbox is where the character can take damage. So I need to rename this to Hurtbox 2D. And in the script, we'll also call that Hurtbox 2D. And let's rename the script to be Hurtbox 2D. So if we had like a melee attack and it needed to be in a certain zone where it could hit another character, then that would be the hitbox. But this is the Hurtbox because this is where it can take damage. And if we want to, we can also tell the collision shape, Hurtbox shape. Okay, and this can be the physics shape if we so desire. So that, you know, the names actually make it a little bit more specific what's what. And you can hover over the nodes and see how they're named down there. So Hurtbox is, of course, where a object can take damage. Okay, so then for the Hurtbox 2D, I did create the hitbox layer, but let's actually add in a hurtbox layer as well. And I might want to, while I'm ahead, take projectiles, move that down there, and then put hurtbox here just so that they're closer together. Okay, so because of that, I'll need to go back to the projectile and make sure it's not on the hurtbox layer, but the projectiles layer. So once you do name your layers, it's probably a good idea to keep them kind of set in stone so that you don't need to update everything. Otherwise, you'd need to come in here and manually change it. But let's make sure that the mask here can hit the hurt box instead of the hit box. Okay, so our projectile needs to be able to hit a hurt box. And since we're doing it the way where the hit box is going to read the hurt box on entering the area, then I guess our projectile doesn't need to have its own hurt box area. So if we right click on the basic projectile and add a child node, we'll do a area 2D. And then this one will also have a collision shape 2D. We can copy and paste the same shape from the physics component, copy, into here, just to keep it simple. Then I'll rename this to be Hitbox 2D. We'll add a new script, and this will be, Hitbox could just go into weapons. Maybe that makes the most sense. Yeah, okay, well, let's do that. And open, save, give it the class name, Hitbox 2D. So this is going to be the area where on entering another hurtbox area, we can do damage to the object associated with a hurtbox. So for the hitbox, we want to connect to its own signals on the node section of on area entered. So let's create a ready function where we connect to area entered dot connect on area entered. Okay, then we need to create the function. So function underscore on area entered, and this gets a area 2D as a parameter. So I'll call it p area of type area 2D. And first we want to check if the area is actually a hurtbox area. So let's say if not p area is hurtbox 2D, we'll return. So that's just a simple way of skipping the rest of the script unless the condition is met. And then we don't need to keep everything within the if statement as well. So we could just come down here. We verified that the p area is a hurtbox. So inside of our function, let's convert the p area to a hurtbox if it is one. So hurtbox equals p area as hurtbox 2D. So if not hurtbox, then we're just going to return because we only affect hurtboxes with our hitboxes. And since we verified that it's a hurtbox now, we should be able to do something like hurtbox.stats. Yep. So we can deal damage to the character. So hurtbox.stats.current health minus equals, and we would say some kind of damage value here, right? So I guess it would make sense to have, let's say, a weapon stats resource for the projectile or anything else that hits enemies or players or objects. And then we can reference the damage value on that weapon stats. Let's see here. In the weapons folder, we'll right-click, create a new script. I'll call this weapon stats, and it's going to inherit from resource. So the weapon stats, class name weapon stats, pretty self-explanatory. We can give it export var display name, which is going to be a string name. We can give it export var damage. We're just going to make everything an integer in this game, keep it simple, easy to understand. And we could give it a default value if we want, possibly something like 10. And I guess that's all we really need for right now. We can always add stuff to it. So a hitbox now needs to have reference to weapon stats. So at export var, I guess we call it weapon stats here just to be a little bit specific, weapon stats. And then we're going to do minus equals weapon stats dot damage. So our hurtbox has reference to the stats, and then we take the current health and we subtract the damage of the weapon stats. Make sure there's no diagonal slash there. Okay. Then we need to create a weapon stats inside of our hitbox. So we'll do new weapon stats here, and this will be the basic projectile weapon stats. It'll deal 10 damage. And we will save this to the project in case we need to reuse this. So right click, save as, and weapons. We could say new folder, weapon stats, and then inside of here, weapon stats basic. So that would work okay right here. But we do already have the fireball.gd, which has a display name. So I think it might be a little better even if we do export var stats and then weapon stats in the fireball script. So now if we save that and we expand fireball basic, then we can create a weapon stats inside of here. So new weapon stats. And if we edit the script, we'll just edit again on the script.gd. Then we'll just remove the display name there, because I guess the name isn't exactly the stats of the weapon. So we'll keep that separate. Okay, and now our fireball basic has the weapon stats. So anything else that would go in here, like the type of weapon, the damage it deals, maybe a checkbox for if it's over time, that kind of thing, we can all put that inside of here. If you wanted later, you could put a field for the basic projectile to have a reference to the fireball. So like the fireball resource that it was created from, you could put that here. But we don't necessarily have to do that, at least for now. So to make sure that this is the weapon stats from the fireball basic, I'll expand the resource, and then I'll give it a name, let's say basic fireball stats. Now if we close this, I'll right click copy this, and we go to the Hitbox 2D, I'll paste it in here. Then we can see, okay, it's referencing basic fireball stats. So that's nested inside of our fireball basic, but I think we should still be able to reference that properly. And then we don't actually need to have a external weapon stats because it's already inside of that resource. So I will just delete this folder for right now and just keep it nested inside of one place. Okay, so we have our weapon stats here, and we want to make sure that that's the same weapon stats we use in the Hitbox 2D. You can go into here and copy and paste that into the other one, but maybe we want to save this inside our project as well. So for weapon stats basic, I'll overwrite it with this. You might need to actually make it unique first here by right-click Make Unique, and then Save As in the project. Weapon stats basic will override that. Okay, and then if we click on Hitbox, we need to make sure that's using this. And the fireball basic is also using this. Okay, and basically just make sure that they're actually using the same resource. That's the important thing. Now, it's up to you if you want to move this to the projectiles folder. I might actually do that just to keep everything grouped with one scene directly inside of there. And you can still search the project by the name of the resource here. So I'll actually just move that into projectiles. Then I'll create a new folder in projectiles. Let's call this the basic projectile. And I'll move anything that's associated with the basic projectile, that's these three with the basic name, into the basic projectile folder. So the scripts for basically creating a projectile are still up one directory, but the basic projectile associated resources and the scenes are nested in the same area. And as a result, I might not need the weapon stats folder. I'll delete that for right now. We can always recreate it later. And so basically, after playing around with the resources and putting them in the folder and referencing them between our different objects, at the end of the day, all that we're really doing is reading the damage value from this resource and assigning it to the current health of the other resource, which is the stats on the Hurtbox. So to test that that's working, let's hit a breakpoint and add one of these invaders to the level 1. So in level 1, let's search for invader. I'll zoom out a bit. Let's add this guy over there. Let's add one above the ground and just make sure physics is working. And another guy right over here. Okay, might want to zoom in and just pixel snap to the ground. Okay, cool. So let's hit play. And what I'm going to do is I'm going to left click and select one of these guys in the inspector. So let's search for invader. Okay, what are they actually called in this scene? Let's see, enemy 2 and enemy 3. So I probably want to go to the invader scene and rename those to be invader. Okay, so on the object sets, so to make it easier to see it in the inspector, among other things, let's actually export the current health value as well. So now if we hit play and we shoot a guy and we go to Hurtbox stats, we can see the current health there. So we can see that setting the max health to the current health didn't work. So I would just go into object stats and let's manually set the current health to 100. If you spawn a new enemy into the game, then after you spawn, you can just set the current health equal to the max health, whatever the max health is, if you want them to be fully healthy. Inside of our level 1, of course, let's make sure that these are called Invader, Invader 2, and Invader 3. So if you just type Invader, it'll automatically assign the number after it. Okay, now you can go back into play mode. we can shoot our little guy there, and the hurt box will be able to see the stats. Okay, so we hit play, and let's shoot again, and let's see if the damage was assigned to the current health. Okay, it's not showing there in the object stats. So to show that the character is going to take damage, let's put a print message here, and then we'll print the current health of the stats on the hurt box whenever we deal damage to it. Also, one thing I probably think we should do is go in here and change this to an export var and not have the equals health thing. That is just going to have it set to 0. Resources work a little bit differently than nodes, where they don't automatically have like a on ready where they set everything when you launch a scene, like a node would, but rather I think you have to manually set these values. So if we default this to 100, then the character's current health will be 100 whenever it's created. In your node scripts, you can have something like when the player character or the enemy is spawned into the scene, you just on ready, and then you set the current health equals to the max health. But you would do that through a node, not a resource. So that's one of the limitations here. Technically, you can also use the init function to probably do that, but I think that might be a little bit more messy. And it's probably better to modify these values with the node script than try to set them in the resource script itself. Okay, so anyway, when we hit the Hurtbox stats, it's going to show the current health inside of the console. So let's shoot at one of these guys. We can see on every hit, it takes 10 damage. We can also go over here for a bit. So that's all well and good. Now we can see that the character can drop below 0 health. So what we probably want to do is when a character drops to 0 health, that they are going to enter the death state and no longer be hittable. So that's what we'll work on in the next video, having a character become immune to damage and changing its animation state from walking and moving around to the death state. So continuing on with our 1-bit platformer, now that we can damage a object or an enemy, we do want to remove the projectile as soon as it does damage in this case. And also we'd like to change the enemy to be able to have like a death animation, which we already kind of set up in the animated sprite. But actually switching to that death animation when the enemy reaches 0 health. Also, when the enemy is at 0 health, it should no longer be damageable while it's being removed from the scene, which should occur a couple seconds after it dies. So let's close that. Let's go to the projectile window, the basic projectile. And I'm going to say on the projectile script, let's add an export variable. So this will be export var remove on hit, which is going to be a Boolean set to true, of course. So if we want the projectile to remove itself as soon as it hits another target, then we have this in here. So for that to work, we have to connect to the hitbox. So we'll add in a @export var hitbox, which is going to take a hitbox 2D. And whenever this hitbox is assigned, we want to connect to its hit signal. Well, we haven't really created a hit signal, but basically, when it hits a target, we should have a signal that it dealt damage to the target. So in here, I'll put in signal hit, and let's say target, which is going to be a Hurtbox 2D for now. And then we'll say the amount, so the amount of damage that it dealt, if any. So when our hitbox connects to a Hurtbox, first we make sure it's a Hurtbox, and then maybe as another condition, we want to set that the Hurtbox is actually hittable. So if it is a Hurtbox, then we'll add in another check. We'll say not Hurtbox.get hittable, let's say. So a Hurtbox script will be able to define if it is hittable or not. And if it's not hittable, then we'll return before we actually deal damage to it. So that means we need to jump into the Hurtbox script. So I'll right click here for the symbol, look up symbol, and then let's add in the function get hittable, which of course is going to return a Boolean whether it's hittable or not. And for now, let's say return stats.currentHealth is greater than 0. If the current health is above 0, it's hittable. Otherwise, it's not, and we'll ignore it for projectiles hitting the target. Okay, now in the hitbox, we'll emit the signal hit if the target took damage. So let's say down here, we'll take the weapon stats.damage and assign it to damage dealt, like this. Then we'll replace weapon stats.damage with damage dealt. And we'll say hit.emit and the target of the Hurtbox with the amount, which is damage dealt. I'll make sure that's spelled correctly as well. So damage underscore DEALT, no H, replace all. Okay, that should clean that up. So now there's going to be this hit signal that gets emit whenever the target successfully takes damage. And we want to connect to this on the basic projectile. So go to the basic projectile script. So we need to connect to the hit signal on the hitbox. You can do that when the script is ready, on ready. Or you could do it when the hitbox is set, which is usually kind of my preferred method at the moment. So I'm going to add a colon here, and we'll add a setter for the property. So set value, when we set a value to the hitbox, we want to set the hitbox to the value. So as it is right now, nothing's changed. But we want to unsubscribe from the old hitbox and subscribe to the new hitbox's hit signal. So if instance valid is instance valid of the current hitbox, then we'll disconnect from its hit signal. So hitbox.hit.disconnect on hit. And then down here, if is instance valid on the new hitbox, because remember we just assigned that right here, then we'll connect to it. Hitbox.hit.connect underscore on hit. So now we need this on hit callback function on hit. And when we get hit, according to the hitbox script, we get a target and an amount as a parameter. So we want those same parameters in this function. So p target is going to be a Hurtbox 2D, and then the other one is p amount, which is the damage we took. And we can pass that for right now. So the amount here isn't exactly that clear. So I could say health changed or health change, p health change. And then we go back to the hitbox, and I'm going to put health change there just to make it more clear exactly what this is. So the target gets hit, and then its health changes by an amount. And I think that's just a little bit more clear of a name. So when the target gets hit, we're just going to remove this projectile from the scene. So we'll do, you could do QueueFree, which is probably preferable because this gives everything else in the scene until the end of the frame to interact with this projectile, and then it will clear itself up. So to remove itself from the scene, usually I think you want to do QueueFree over free, because this will make it so that anything else trying to interact with this projectile has a chance until the end of the current frame to finish its operations, and then it queues free and then it frees the object or removes it from the scene at the safe time, rather than freeing it immediately with free, which usually works. But it may, I guess, lead to stuff like missing references to the object which no longer exists in the scene. But this removes it safer. That's generally my understanding. We could, of course, go right-click and remove and kind of read through it. So yeah, it just gives it a second to be accessed until it's deleted is the general idea there. So it'll remove itself at the end of the frame. Okay, we need to assign the hitbox and the basic projectile script. If you wanted to, you could make it like an array of hitboxes and then do this for each one of them. I think almost every projectile in every game is only going to need one Hurtbox, so we'll just keep it simple for right now. Yeah, just assign the one Hurtbox. So now we want to test if this is working. I'm going to set a breakpoint right there and see if this part hits. I'll hit play. We shoot at the guy there. It gets QueueFreed, so that's going to mean that that projectile has gone from the scene. But if the enemy is already dead, then you can see that our projectiles pass right through it. So that's when we should play the death animation on the enemy, and then remove it from the scene once that animation is done. So let's see. We can put the signal on the resource object stats. That's often a good idea because a resource is easily shareable between objects throughout your scenes as long as you have some reference to this. It's easier to share resources than it is to share nodes, because a node has to exist in the same scene in order to grab its reference. So let's go into object stats and create a signal. So signal, what should we call it? Signal death, signal out of health. I guess we'll just go with signal death. You could pass in a value like the current health, but I don't think that's going to be needed. We just need to know that the object died, and then we can play the animation when that occurs. So when the health is set to 0 or less, when the previous health was above 0, then it should play the death signal. I think that would be correct. So we'll do that with a setter. So remember, colon at the end after the value, and then set, and with parentheses, the parameter value, and we're going to get the old value first. So old is going to be equal to current health. And then we set the current health to the new value equals value. And then if the old, let's say old is greater than 0 and current health is less than or equal to 0, then the character just died or the object just died. So we'll say death.emit, hit save. I think that's pretty much all we need there. Yep. So we have this death signal and we can react to it now. So in the platformer character 2D script, every platformer character, if its health drops, we want it to receive that death signal. So we'll need a reference to the object stats. So in our platformer character 2D script, remember we still haven't made this invader a enemy script. It's still just a platformer character. Then we will grab a reference to the resource we need. So at export var, let's say stats. Yeah, we could just call it stats for right now. And we probably will be calling this like character stats at some point. Yeah, we could just create character stats right now. So this doesn't exist yet. We need to extend the script. Under objects characters, I'm going to right click here and let's create a new script. We're going to call it character stats. And this is going to inherit from object stats because it's going to contain the same health that an object would. And in character stats, we'll give it the class name character stats. And we're going to leave it alone for right now. Now back in Invader, we'll just save this script again. And if we click back on the script, we might need to reload, but it should pop up here. So let's reload the project if you don't see it in the inspector. And there we have our character stats. So character stats inherits from object stats. So if we do a new object, we can see it still has the max health and the current health. So every damageable object has a health, and that can include characters, which could include players or enemies. So it starts from something generic and it goes up to a more specific character and then player, enemy, and probably NPC. After that, getting more specific and accumulating the different properties along the way. And that's basically programming inheritance in a nutshell. Okay, so when our platformer character dies, we want to play the death animation on it. So let's connect to the character stats signal, and I'll do that once again with a setter. So if the instance is valid on stats, then I'm going to disconnect from it before I assign the new one. And the reason I've been doing this with most of my properties is just to prepare for the case that there might be a situation where you actually change the stats out or the property that we're setting in each of these fields with a different one. And whenever we change it, we want to make sure that we're not connected to the old signals and that we connect to the new signals. So in most cases, it's not needed because you only assign one stats to a character. So you could skip the check and just connect to the stats signal directly. That would look something like stats equal value, stats.death.connect on death. And so if you assume that in your script that you're never going to change the value, then this will work. It's just that if you change it, then there's going to be an issue because you might be connected to two different objects because each object you assign here is going to have its own death signal, and then you're connected to them, but you never disconnected from the old one. So it's just kind of forward thinking, right? So if instance is valid on the current stats, then I'm going to disconnect from it, stats.death.disconnect _ on death. And then down here, we just kind of do this, copy paste, tab this over. And now you're disconnecting from the old one and connecting to the new one. So in the event that you change it, you're prepared for that. So we need to create a onDeath. So function _ death. And when that's the case, we want to play the death animation. But you know what? Now that I'm looking at it again, I think we can break this up into another script as well and just keep things even more separated into their respective components where it makes the most sense. So what we want to do is change the animation. So really, instead of grabbing a reference to the animated sprite and changing it in this character script, we could actually just extend animated sprite 2D to have a connection to the character stats, and then the animated sprite will handle changing its own animations. So let's rename this to be character sprite 2D. Right click on it, attach a script, and we'll put this in the characters folder. Note it's inheriting from animated sprite 2D, so we'll create that. Now let's grab from the platformer character 2D script, clicking up here, and we'll just cut and paste this away into the character sprite 2D like this. And in Invader, let's grab on death, and we're going to go to the character sprite 2D again and paste that in there. So now any object that has a character sprite 2D, or should we even call it an object sprite? Because I guess like a tree or something would need to have a death animation too, wouldn't it? So yeah, let's make this even more generic. I'm going to rename character sprite 2D to be object sprite 2D. And we'll move that up to the objects level. And in object sprite 2D, we're going to have the on death reaction where we set the animation. So class name object sprite 2D. We have the connection to the signal right here. And then we need to on death, we're going to play the death animation. So I think it might be a good idea for our game if we have consistent naming for these animations across all of our objects, so that when anyone's working in the project and they open up a character and they see the list of animation names, that they know exactly which animation corresponds to what. So we should have a list or a resource of names for those at some point. Now, I don't remember. In data, we had a groups name resource. So that would be kind of similar. We could just have a animation names resource as well. So that's what I'll go with for now. Let's right click on data, create a new script. Animation names. Oh, whoops. Snake case animation names. So lowercase and then separated by an underscore. Create names. Let's go into this. It's a resource. Class name animation names. And we'll need @export var death, which is a string name, equal to death. Okay, now let's create that resource. Right click, create new resource, animation names. And I will just call it animation names.tres. Okay, now we go back over to the character sprite 2D and let's @export another variable @export var. Let's see, animation underscore names, which is of type animation names. And now when we actually play the animation, we just reference that field from the resource. So let's see, a animated sprite I think has a play method. So we play the animation name. So rather than typing in death directly here, just like before with the group names, I'm going to do animation underscore names dot death. So once again, the reason for this is just to have consistency between all objects. So the death name isn't set locally here and the character. It's actually set in our resource here, which is kind of serving like a dictionary across our project where we share all of them. And therefore, every object should have the same death animation name when we're setting it up here. Otherwise, we'll get some kind of error, and we would actually want that so that we can keep the consistency. Okay, so we just need to do play animation names.death on death. If we hit play and we shoot our guys a bunch, then we should get the death animation. We did not. I see some error messages in the debugger. Oh, and also, it looks like these resources have not been made unique. So in errors, these are just notices that if you're not using something, you should make it an underscore when it's a parameter. So it's not really problematic here. You can, of course, click on each one and underscore it if you're not using it. So we could do underscore health changed. And then over here, we're not using the delta, so we could just underscore until we do need it again. And then there's one over here. Oh yeah, p target is also not being used by this method specifically. So as for making sure that when you damage one target, you're not damaging all of them, for the object stats resource, we should make sure that local to scene is toggled on. Now, if you want to just make sure that that applies to all resources that are of this type, and I think we do, then we can edit the script. So I'm going to edit that resource, and then we're going to edit the script here. So in our object stats, if we want to force it to always be local to the scene, then we could do something like function underscore init. And whenever the resource is initialized, we'll say resource local to scene equals true. So I'll save that. We hit play. And let's shoot this guy a bunch. Okay, he's dead. And this guy a bunch. Now he's dead. So they each have a separate health now, which is more like what we would expect. Alternatively, if you still want to set that value here in the inspector and not be confused between this and this, another thing you could do is say if resource local to scene is not true. So we'll say if not resource local to scene, then we'll print a message. So let's say prints resource not local to scene. Let's do %s to import a string here. And then to replace that string with what we want, let's do % resource name, or resource path even, resource path maybe. Okay, and remove this part. So now if we hit play and we look in the output, then we'll see that this resource for the object stats of the invader is not local to the scene. So that'll just kind of be a notice that, hey, we're trying to load object stats and it's not local to the scene, which means that we might be duplicating it across our enemies. Now, one reason to do this might be there is actually some kind of enemy that maybe shares health between different enemies. And in that outlier case, you might actually want local to scene off, even for object stats. But we'll just check it here so that all of our object stats on the invaders are local. We'll hit play, and if we don't get that message, then okay, then they should be damageable separately. So that guy got hit 10 times, and this one gets hit 10 times again, and like that. So that's just like using a message instead of forcing it. If you want it to be more like a warning, you could do like push warning, and if we toggle that off and hit play, then it'll show up in the debugger instead. So in some cases, you might want to do that. So if in the case that you're never going to be like sharing object stats, the health between multiple objects and you're seeing like multiple enemies all sharing the same health pool, then this might actually make more sense because this is more of a strong message, and you'll definitely know that there needs to be a checkbox here so that they have separate health pools. Okay, so our character sprite 2D, we can see that we didn't really get a message about the stats being empty. So we never set the stats, and that means we're never going to connect to the signal. So maybe we want to require there to be a stats value. So we could say function ready. We're going to check if stats has actually been set. So if not stats, then we're going to push a warning. Stats must be assigned. Then I'll say like square brackets just to emphasize the property name. Stats must be assigned in object sprite 2D. Okay, and that should be fine. If you want, you can also do one for the animation names. If not animation names, then push warning, animation names must be assigned in object sprite 2D. Well, instead of saying the name of the class, what we could do is %s. So we're going to replace that %s with a string with a % following the string, and then we just say name, which is the name of the node. Okay, so here we'll say %s, and then we do %, and then what are we replacing the %s with? Name. So s here represents string. You can also do like d for decimal values. So if you're doing a number instead of a string, then you would just put a d here, and then give it a float or an integer over here instead of a string. So if we hit play now, we should get some debugger messages. Okay, there we got 6. So just in that little ready check, we actually know that a bunch of stuff is not assigned properly inside of our scene. So kind of handy to have little checks like that, just to kind of know that you haven't set up the inspector yet. So we want to copy the object stats. So I'm going to right click here, copy over to character sprite, and then we paste the stats in. So we need to have character stats here. And currently the Hurtbox has object stats. So object stats can set a character stats, but the character stats can't set an object stat. So we actually want to create a new character stats here. And we're going to check local to scene. I'm going to right click here, copy, go to Hurtbox, and paste it in here. Okay, now they're sharing the same character stats. And animation names, we can quick load this from the project. Click the dropdown, quick load, animation names from data.animationnames.tres. So there we have the death animation name, and there we have the health and current health of our enemy. If we hit play, the debugger messages should go away because we properly set these values. So if I shoot this guy 10 times, well, it's not playing the death animation. So let's actually toggle right here, a breakpoint on death, shoot this guy a few more times, and we can see it's not actually triggering. So if we check stats, we can make sure that the death signal is actually emitting. So I'm going to right click on the death signal, look up signal. We have signal death here. It should emit right here. So let's set a breakpoint right there when death gets emitted. And I'll shoot this guy 10 times. And we can see we actually hit the breakpoint. So we can continue that. Okay, and if I check the character sprite 2D in the inspector resource, we can see that the value or the ID of this resource and the ID of the other resource are not consistent. So I think if we save the character stats to the project, let's try going up to enemies, and we'll say invader stats here, invader stats.trs. Okay. Then we're going to have it from the same file, and it's going to be local to the scene. So let's try this. Character sprite, we're going to, once again, quick load the invader stats. Okay. And now let's hit play and see if those are still connected. Okay, so death emits, and then we do hit the play for the on-death response. Okay, so if I hit play again, okay, good. That's exactly what we want. So this character died. These characters did not. So here's what's happening. We're loading from the invader stats on our project directories. When it's loaded into these scenes, it becomes localized to the scene. And then character sprite 2D and Hurtbox 2D are sharing the same file, which is a duplicated copy of the original. And that happens for each of the 3 invaders we create. So they each basically get their own duplicated copy, which is local to the scene, but we have it saved on our project, and we can edit it there as well. That's actually better than what I was doing before, where we have it embedded inside of the scene. So now it's saved to the project, but we get a new duplicate for each invader. So awesome. That's pretty much what we're looking for. We can go to object stats and remove the breakpoint now, because we know it's working. So now we can run our project again and just test. So all of them should be able to play their animations when they run out of health. So I think it would make sense for the projectile to just do a bit more damage. So I'll go into the projectile scene hitbox. We'll change the weapon stat basic and change that to 25. So because this is saved to the project and saved inside of the fireable basic TRES, if we click in here and we see the stats, well, we've updated the stats. So this references the weapon stats basic on the hard drive, and we already updated that, so it updates here as well, because this is just a reference to that object in the project. So all well and good, our projectile now does 25 damage, so that would mean 4 hits to deal 100. And so, of course, we still have a bunch of work here to do. It's kind of boring if we just hit them and nothing happens, so we probably want some knockback, and maybe we can have the characters flash red when they get hit, so more of an indication about what's happening. And after they play the death animation for maybe a second or so, they should remove themselves from the scene. So we'll continue with all of that in the next video. I've been Chris. I hope you guys are enjoying the series so far on the Projectile Platformer 1-bit series. So we'll continue all of that in the next video or two. If you need the project snapshots, again, you can find them in the description from Ko-Fi or Patreon. And until the next video, I've been Chris. Thanks for watching, and I will see you then. So in this part of the series, I want to make sure that when we hit our enemies, that they can be knocked back a bit. So we could call that, say, a hit or knockback state. Also want to be sure that gravity is affecting our enemies. And we may want to also do something like churn the color of the enemy red after getting hit to further indicate that our objects or characters are taking damage. So let's start with the simplest part first. Our player had the ability, if we check, to apply gravity, but we haven't added that to our parent class, the platformer character. So what we might want to do is take this apply gravity line, cut it, and go up 1 level. And then we'll implement the physics process function on this class too. So to do that, go here above try jump and do function underscore physics process, and we paste this in. So now what we should do on any class that is also going to call physics process, but is a child of platformer character, is we make sure we call the super method to make sure this code executes in addition to whatever else we add to it. So if we go to the player class now, and we have our physics process, we need to do, I think it's called super in Godot. So we just do super, and we pass in the delta, because physics process is still going to expect this delta. So we pass this into the parent class version of the function, let that run, and then execute our custom player movement script. So now any platformer character, by default, as long as we remember to call the super function, is going to apply gravity. So if we hit play, then the gravity should affect this character over here as well. Of course, we can see that this didn't activate here because we never called move and slide on that character. So there would be a couple ways of handling that. One would just be to do move and slide here, and then we would remove it from the player class. But we probably want to make sure that the super calls afterwards now. But if for some reason you need to separate when you apply gravity and move and slide so those don't execute in the same block. I think you could get away with also doing a call deferred on the move and slide. So we pass in the function name, or we could say move and slide dot get method, which is going to get the string name rather than setting the string hard coded into here. And that'll make sure that move and slide gets called at the end of the frame. But I think I want to try this for right now. So move and slide will be called here. And when I'm designing classes, I just need to remember that the platformer class already calls move and slide on any object in the scene. So if we go to player, we just need to call super delta and remember that that'll handle the rest of the physics processing. If we hit play, now our character should fall to the ground. So we only need to call move and slide from one class, and they're all affected by physics. So next, especially for our invader, he's going to have multiple states. So there's going to be a hit state, a death state, and a walking state, possibly even a seeking player state if we want to give it a little bit of a computer brain so that it can actually target the player and run towards it. So even though we're working on a simple enemy for the invader, he is still going to have multiple states. For instance, he's going to have a walking state, a hit state, and a death state at a minimum. So 3 separate states, and each of those states needs their own code. You can, of course, pump everything into one script. You could just create an invader script, but there are more elegant solutions to handling that. For instance, one way is to have a state machine as a node, and then child states below that. Another option would be to go to the asset library and look for, I think we want behavior trees. So if I can look for that, Behave is a behavior tree AI for Godot engine. So at a glance, we can look over here and see that Behave, using behavior trees, allows you to create a pretty complex AI situation for your enemy. Now, of course, to specify, when we're talking about AI in this instance, we're not talking about generative AI where it analyzes, let's say, 1,000 photos and then generates a photo that's similar to those. We're talking about AI where you hard code every bit of it. It's just separated into different pieces in a behavior tree. So big distinction there. Game AI is usually the second, not the former. So we're going to try to set up behave for our behavior tree for our character. This kind of method just ends up being a little bit more flexible in the end than state machines. So we're going to try using behave for our character. This kind of method ends up being a little bit more flexible in the end than a finite state machine because it allows us to use all of these nodes to help us navigate what the character should be doing at any given time based on settings on the character. So for instance, we could say that something like when the character drops below half health, it should run away. So that could be an option, and that would be pretty easy to set up with a behavior tree. So we'll keep it simple for this video, but I just want to introduce this plugin as one of the AI options. So I'll download this, and we will install it to add-ons/behave, install. So if you have any questions about the Behave plugin specifically, you can find the documentation at bitbrain/beehive. Note the period right before the .in. Right here. And yeah, that will basically detail everything about the plugin. So for our tutorial, we'll just set up a simple tree. So back inside of Godot, I'm going to go to project settings and make sure we enable our plugin. So behave, enable that, currently in version 2.8. Now if we right click Invader, we should be able to search behave and find the behave tree, which is the root of all of our behave, which is going to be the root of all of our behavior tree logic. So I'll add in behave tree. And if we hover over this warning, we'll see that it should have exactly one child node. So we need to right click here, add child node. And let's start with a selector composite. So this will execute our children sequentially until one of them returns a success. So basically, if one of our logic nodes is able to run, it'll return success and we don't continue on to the other ones. Otherwise, it will go down the tree and select the other behavior logic to run, and if the conditions are met for that to run, it'll run it instead. So let's do selector composite. So under here, we're going to want to add in a sequence composite. So our sequence composite has basically a list of actions or conditions that need to be met in order to finish the completion of it, and if all of them complete, it would return success, I believe. So we want a sequence composite, and then under here, let's add in a condition. So add a leaf node. Our condition needs to be met in order for us to take the action leaf below it. And then in the action leaf, we'll actually write the code for what our AI is doing under those conditions. So condition leaf. Okay, so then in addition to the condition leaf, we're going to need an action leaf. I'll add that in there. So our most prioritized action, I'm going to say, is if the character is dead. So I'll rename this is dead. And then the action leaf is going to be to play death. After that occurs, we're going to remove the character from the scene. Okay, so this is going to be the death sequence. We can add another one in now, add child node. So this will be another sequence, composite, and I'll duplicate that. So the first one is going to be the hit sequence. And then if that fails, so our character is not dead and our character is not currently hit, then it's going to be the wander sequence. So let's add in here a leaf for the condition. I'll rename this to be is hit. Let's add another action leaf, play hit. And then the wander sequence is going to just be a action leaf, wander action. So if we actually run the project now, we'll be able to go to the debugger and click over here on behave. So we have 3 behave trees running in the scene, and we can kind of see what's going on with the logic here. So basically, it's going to go down the first one of the death sequence. And if that succeeds, it's not going to continue to the hit sequence or the wander sequence. So obviously, our enemies are not dead, so we need to be sure that we set the condition before playing death, and then playing death actually needs to do something before we move on to the hit sequence and the wander sequence. So let's stop that. I'm going to rename this tree to be invader behave tree. So now we can see in play mode that that'll be more specified here. So we know, of course, that this is part of the invader. So to actually add the condition for is dead, we need to right click and extend the script. So condition leaf is dead. And we could actually put this in objects, I think. So in objects, let's say we'll have a behave folder and the is dead condition leaf. Okay, so we'll create that. Okay, and how these condition leaves work is you implement a function called tick. And in tick, you determine whether it is a success, a failure, or to basically continue checking. So we implement function tick, which is going to give us a actor, and it's also going to give us a blackboard. So a blackboard is basically an object that is going to hold certain pieces of data, and we don't know the full extent of what can be set in there because I think it operates as a dictionary that will be adding and removing items from it. But we can check the blackboard to see if the property is set in it to the value we would expect and use that to determine true or false whether the character is dead. So somewhere else, we target this blackboard and we set the is dead property. And then in our tick function for this condition leaf, we check if is dead is true on the blackboard, and if so, then we will return success. So we could say var is dead equals p blackboard dot get value, and we're going to be looking for a key value. So this might be another situation where I want to have a data set that I keep consistent with all my AI scripts. So basically, if we're looking for death across anything, then I want to keep the blackboard names consistent. So I guess I'll create a new script in the data folder. We'll call this blackboard names, or blackboard keys, actually. I think makes the most sense. This will be a resource. We'll create that. Inside of this resource, we'll have the export var, let's say death key string name, which will be equal to death. This class, of course, is class name blackboard keys. And then we'll create a resource for that blackboard keys and save that there. So blackboard keys.tres. So now we'll just use this in our leaf script, but I got a note that I was actually editing the condition leaf from the plugin. So I'm going to cut that and make sure that I open up this script, which is the isDead condition leaf. So class name isDead, which is a condition leaf. And that's where we should be implementing this tick function, not changing the original script, of course. So at export var, and we'll say keys, which are going to be blackboard keys. Then we're going to look for the keys dot death key. So we get the value there. Now we just need to assign blackboard keys.trs and the inspector for isDead. Okay, now we have our key names. Cool. So we get the value from keys.deathKey. So this we expect to be a Boolean. So we could mark that there. And then basically if is dead, then we're going to return success, else we're going to return failure. So if the character is dead on the blackboard, we return success, and then we try to play the play death action sequence. Otherwise, we're going to return failure. So right now, nothing is setting the blackboard values, so this will always return failure. If we go to the behavior tree, we can create our blackboard here. For some reason, it's set to a node there that probably doesn't exist, but what we should do is create a blackboard node in our hierarchy. I'm going to right-click on Invader Behavior Tree, add a blackboard. I kind of like this at the top, and then we'll assign the blackboard to the blackboard node. And now this blackboard is going to automatically get passed into all of these tick functions on basically anything that's running in your tree as an action or condition leaf is going to have access to this blackboard. So as long as we set the dictionary values in our blackboard, we'll be able to read from those in our scripts. Okay, so let's add a breakpoint in our isDead script. We'll hit play, and it should run into this. But it looks like we're getting an error there, so I guess we have to put blackboard outside. And we're still targeting it in the behavior tree. So that's fine, just make sure your blackboard's out. And in the script, we want to set a breakpoint, so we'll check isDead at our breakpoint, which we would expect to be false at this point. So we come into there, of course, trying to assign a value nil to a type of Boolean is an error we would expect because there is no values in the tree. If we check the blackboard object, we can see in its dictionaries, and I don't remember if it's in the data of the blackboard, but we would have in here the value for the death key. That's not being set, so we need to set that in something else in order to read that properly. So we actually kind of want this error to pop up because that's a pretty big issue. So I have been thinking a little bit about this one. With the invader stats, we might actually want a health component that's separate from that. And then when the character dies, we don't have the invader stats / object stats necessarily calling the death signals. But we'll still have the invader stats for all of the statistics about it. But for our current health, we can pull that out to a health component, and that health component can mark the blackboard with the information it needs to for when the character dies. So let's add to our invader a new node, and at the top, I'll just call this the health component. We'll create a script. It'll go in the objects folder, so not in characters enemies, but objects/health.gd. This will get a reference to the stats of the object stats. And then this will also have the current health. So for our current health, which is going to be an int, and function ready, we'll say that the current health is equal to the stats.maxHealth. Okay, so this means that our character enters the scene for the first time, and unless we override that with something else, it's going to be initially set to max health, which we pull out of the object stats. So for the invader stats, we can load that in from invader stats. Let's look for the stats script inside of our project. So we have character stats and object stats. I want to take the death signal, and I'll put that in the health class instead. So let's put that up here. And then in object stats, the current health, we're going to paste this into there as well. And just override what I had just wrote a second ago. So we don't really need a default value here because we're going to set it on ready. And this will be the health node. So our health node is going to have a reference to the blackboard, where whenever our health node dies, we'll set the blackboard value of isDeath to be equal to true. And actually, that's the death key death. So death will be true. Okay, for that, we'll need a reference to the blackboard. Okay, maybe we also put in a alive signal. Or, you know what, let's change this. Is alive signal. So this will be a value, whether it's alive or not. And let's make that a property. And I'll also call it isAliveChanged. So we can make this into a property now. Var isAlive by default is going to be true. But we'll do a setter function. So if the value is the isAlive value, then we're going to return because there's no change. It's already the same thing. Otherwise, we're going to set the isAlive to the value, and we're going to emit isAliveChanged with the isAlive value. So now whether this is set to false or true, it's going to emit a signal anyway, and I'll do a .emit here. Because remember, we're doing a signal, so the new value will be emitted, and we can use other scripts to respond to that. And instead of this bit, let's also have another signal in here. So signal health changed, and we'll have like a new value and an amount that it changed by. So I'm going to comment this bit out here, and we'll say health changed.emit, and the new value is going to be current health, and the amount changed, so that'll be amount changed is equal to current health minus old. We pass that in here. Okay, so now we have those two parameters from our signal. But if the current health is already equal to the value, I don't want to bother emitting a signal because nothing's changed. So if current health equals value, then we'll return. And I'm going to reverse that also down here. So if is alive equals value, then we'll return. Okay, so we have this signal, and we can actually connect to the signal within their own class as well. So I'm going to say down here, health changed.connect on health changed. So we'll create that function on health changed, which we get the new health and the amount changed. So whenever the health changes, we just want to tell is alive equal to if the health is above 0 or not. So is alive equals current health is greater than 0. So we update this Boolean property whenever we update the current health now. And that basically handles our health script for right now. Okay, now I could also have the health script directly set the blackboard, but rather than permanently constraining our health script to the blackboard and the behave tree necessarily, what I will do is have a enemy blackboard setter script. So basically it'll connect to any other components, grab their signals for like is alive changed, and then set that on the blackboard as a in-between step. So I'll right click on Invader. Let's add in a node, and I'll position this, let's just say under blackboard. So for this node name, I'll call it object blackboard setter. So for any object that needs to set the blackboard, we'll use this script to do that. So I'll put this once again in the objects folder. Let's open that, create it in there. To set values on the blackboard, we need to get a reference to the blackboard. So export var blackboard of type blackboard. And remember, whenever we have the plugin installed, the blackboard, we're specifically talking about the behave tree blackboard. Other plugins may have something similar, but just keep that in mind. So we have that, and our object needs to update the blackboard whenever its health component changes is alive to false or true. So we need a reference to the health component at export var health, which we can do the connect disconnect trick I like to use. So if instance valid, if is instance valid health, then health.isAlive, we're going to disconnect on is alive changed, and I forgot the underscore changed part. Then we're going to set the health equal to the value, copy paste this down below, and then just change disconnect to connect. Okay, so now we're connected to the signal on the health component. We need to create the on is alive changed function. So this is going to have the Boolean of the value. So p-value Boolean, and basically whatever the value is, we set it on the blackboard. So this is going to be for the death value on the blackboard. So blackboard.set value, and we need a reference to that key. So let's get the keys resource at export var keys, which is of type blackboard keys. So keys.deathKey is going to be equal to the p value. And I think as a last thing, we maybe want the ready function to set that on ready. So function underscore ready, we're going to take the blackboard.set value of keys.deathKey to health.isAlive. Okay, so before we receive a signal, we've already set the value on the blackboard, which is going to hopefully mean that it can run immediately. If not, then this might need to occur before other things happen, but we'll see if this works on ready. So assign the blackboard, we'll load up the resource blackboard keys from the data folder and assign the health component. And that should set the blackboard up with the values it needs for isDead to be set here and get the value so we can use it in our behave tree logic. Okay, so let's hit play now and see if that's working. Okay, so I did some testing, and it seems like when you try to set the Blackboard values on the ready function, that the Blackboard actually resets its default values. So there's a couple ways to handle this situation. I guess using onReady is not the way to do it. One would be that on the Blackboard, we could manually add in the key, or we can just default until this value has been set to something new, that we have something set in our scripts. So if we go to isDead and we try to get the value, the death key, then we can just say that by default this is false. So basically the idea is just that the Blackboard, we should wait till everything initializes before we try to set anything into it. I don't know why it's set up like that, but that seems to be the case. So the Blackboard setter will just be updating the value with new values after the script has already loaded. So if I add this back in, I bet you could actually do something like call deferred. And this is a little hackish, but let's do blackboard.setValue.getMethod. And then we give it the parameters, which is going to be keys.deathKey. And then just for testing purposes, let's say this is true. So we'll go to isDead, and this should be false by default because that's the default. But I'll set a breakpoint here. So if we were to go back to the Blackboard setter script, and I did something like, let's change this to function_physicsProcess. And then every time we run physicsProcess, we set this to true. And this is just purely for testing. Then on physicsProcess, it should be able to update here. So by default, this is false. So once we set it, it's going to give true. If we run the current scene, the first time we run it, I guess the physicsProcess has already actually ran. isDead is set to true. If we check the Blackboard, then there we have the death data listed inside of there. So yeah, I don't know the exact reason, but be careful with trying to set the values on ready, I guess, at least in the current version of the plugin. We'll just have onAlive changed to set that as we need. But by default, every object in the scene for isDead is just going to default to false until we set the death to false. And actually, to make this make a little bit more sense in the data for the project, and Blackboard keys, we're going to say isAlive. This would be isAlive. Okay, so that when we're responding to the signal, we actually set the isAlive key to the value of isAlive changed. Okay, so you see how that makes a little more sense there. And then on isDead, we're going to get the isAlive value, but of course, we want to reverse that. So isDead is going to be not isAlive. And if isDead, then we're going to success, otherwise we're going to fail. So initially we should be failing this because the character should be dead by default. But it's still set to true here because I need to change the default value for isAlive to true. Okay, so by default, we assume that a character is alive until we've set the value in the Blackboard for isAlive to false. If I run this, okay, isDead is now false, and we will not succeed. And if we go hit play and we look at the behave debugger, we should see that we're failing the death sequence there. Okay, so we can see what's happening here. We get the death sequence, isDead fails, so we go to the next one, the hit sequence. We haven't set up the isHit condition, so we automatically proceed to the play hit action, and until we fail one of these, we won't do the wander sequence. So I was getting a little stuck there myself, but hopefully now that we got that going, knocking out the hit sequence, the play death logic, play hit logic, and wander action logic should be a bunch easier to understand. So let's stop the scene and clean things up a bit. If we shoot an enemy now, then we'll see that the Hurtbox now cannot access the current health stat of the object stats. So instead of referencing the object stats in the Hurtbox, we should actually be referencing the health component now. So health and then health here. So we'll do the health.currentHealth. So now down here in hittable, we want to check health.currentHealth is greater than 0 instead of on the stats. So if we stop the scene and we look at our Hurtbox, we need to assign the health script so that we know where we're checking for invincibility from. Also on the current health property, let's look up the symbol, right-click lookup symbol. I want to make sure that this is never set to more than the max value of the object stats max health. So the value here that we set to current health is actually going to be the min of either the value and the stats.maxHealth. So that's just to make sure that the current health is never set to a value more than the max health, regardless of how we do it, how we get that value for the current health. It'll always be capped at the max health. Okay, let's hit play and see if we can clean up a couple other things. Shooting. So the hitbox was dealing damage to the hurtbox by just subtracting the damage dealt from the current health. But we're going to also have knockback. So we should have a signal on the hurtbox that we can subscribe to. So when we get hit, we can basically mark the character for being in a hit state. So let's say hurtbox.hit, and we're going to say the amount of damage. So we're now going to be saying hurtbox hit damage, and then this will give the actual amount dealt as a return. So we don't need that. So we'll cut this weapon stats.damage, pass that in. The dealt is going to be put down here. And then we're not going to automatically subtract the current health. We're actually going to let the hurtbox manage that. So in hurtbox.hit, we need to set that up. So function hit. And maybe later we'll add something for the knockback. Haven't decided on that yet. But for right now, I want to figure out how much damage I actually dealt. And this should be returning an int, not a boolean. So we're going to check the old health is var old equals health.current health. And then for this, we're going to basically add the damage to the current health and compare the two values and return the difference. So health.current health minus equals p damage. And then the var damage dealt, let's say, is going to be equal to the old health minus the health.current health. And we'll return the damage dealt so that our hitbox can know about that. And when the hitbox knows about that, we'll emit the hurtbox, the dealt damage, as a signal. And that should handle that. So let's hit play and see if we've cleaned up the errors now. 1, 2, 3, 4. Okay, if we shoot another time, well, that character's dead. Now, the death animations aren't playing because we basically disabled that script from the character sprite. So once again, we're not connecting to the character stats in order to play this on death. We're going to handle that in probably the next video or the next couple videos with our behave tree. So that's going to be it for this video. In the next part, we're going to continue working on our behave tree and get all of this condition and action logic set up to basically set our characters up with their AI logic. And we're going to keep these conditions and actions as reusable as possible so that we can just pop them into a completely different character or object's behave tree as well. So by separating it into each of these individual scripts, hopefully we'll be able to achieve that. So I've been Chris. Thank you guys for watching to the end. If you need the snapshot for the project, I'll have it on Ko-Fi and Patreon. And I will see you guys in my future video content. So in the last video, we got the isDead condition to actually be set thanks to the object blackboard setter. So if I hit play and we shoot one of these enemies a few times, they should get to the point where in our condition leaf, the isDead condition being pulled from the blackboard is set to true. So if we look up here in the blackboard, we can see isAlive is off, which means isDead, which is the value of not isAlive, is going to be true. And with a successful condition, that means we can continue on to the action, which is going to be to play the death animation. So you can probably tell that the monitor looks a little different here. So I did get a new monitor. And as a result, I know that this is really, really tiny right now. So I'm going to scale up the game view in our level to have the camera have a bigger zoom. So we'll try 5, and maybe I'll have to bump that up to 6. Actually, yeah, 5 is pretty good. So that's the change I need to make, just so that when you guys are seeing the video, that it's still big enough on your screen to see what's going on. All right, so in our invader, we have isDead being triggered. So now we need to create a play death script. Before that, I think I'm going to go into this and give the class name a condition at the end. So isDead doesn't really specify much because isDead could just be a Boolean, but we have a Boolean that's a condition that allows us to pass into the next script. So to be more specific, I'll rename that here. For the node, I'll call isDead condition. And I'll find isDead in the project by searching isDead, and I'll rename this to be isDead condition, just keeping the naming consistent between those 3 areas. And now we should clearly be able to identify that this is a condition node that allows us to pass on to the play death node. And then we'll want to create this script. Before that, I'll call this play death action since it's an action leaf. Now let's right click on it and extend the script. We're extending from action leaf and we want play death action, which actually can go in basically objects as well, because objects sometimes explode. So we'll put the play death action script inside of objects, create, and I'll give it the class name, play death action. When once our is dead condition is met, we want to go on to play death action and run the tick function until the action is successful. So it won't initially be successful in a single frame. So there's also a continue that you can return from play death. But let's go ahead and grab the tick function. So if I check behave node, which is one of the roots from a action leaf, you can see that in the enums here, you can return running when it hasn't failed or succeeded yet, which is usually going to be what you actually do during an action. And once it either fails or succeeds, then you run that instead so that the behave tree can move on to other sequences in your AI logic. So we want to implement the tick function, and then we want to return one of these three messages depending on where our action is at. So let's copy that into the play death action. Okay, also on the behave node, there is this function we can implement, which is before run. So before we start basically fully activating the behave node, which in this case is the action leaf, we can have it execute some one-time code. So I think that would be handy to actually implement. And this will be, I guess, where we play emit a signal from these actions and then respond to that in the object sprite. We can reference the animated sprite inside of here and then to play it there directly. I think for this character, I'll try going with a second, at least initially, and we'll see how that goes. So I'm gonna do it at export var, and then let's say a sprite, and this will be a animated sprite 2D. And then before we run, we want to play the death animation. So sprite.play, and we need the name of the animation. So I also need to export var animation names. And I think we called it just animation names as well. So do animation names dot death. So if you remember from before, that was just in the data folder. We had a resource called animation names, which holds all the consistent animation names for objects across our project that are going to be playing animations with the same name, so that they all use the same name for their animations, as kind of enforced here. So when we go to the play death action, we're going to play the death animation on the animated sprite 2D. So if I click on play death, I can assign the sprite, character sprite 2D, and then animation names. We quick load that from the project, and that's set up. So that handles that. And then we're going to wait for the animation to be finished. So sprite.animation finished, we can connect to that. And on animation finished. So let's see, down here, we'll need that function on animation finished. Okay, and let's pass that for a second. I'm going to click on the character sprite and check the nodes. So the animation finished signal doesn't have any parameters. So all we need to do here is set what kind of return we're going from the tick. So let's see, var, I don't know, I could call it like tick result, and this will start at running. Also want to make sure that when before run, we set this to running. We're always going to return the tick result. And then on animation finished, we're going to set the tick result to success. So what this code should basically do is play the death animation. It's going to keep running this leaf until the animation is finished. And when the on death animation is finished, it's going to return success from the tick result. So now we should be able to go to the debugger and see the behave tree a little better. So we have the death sequence. So is dead is failing because the characters are very much alive. So let's shoot them a bit and we'll see that is dead. It was triggered success. So if we continue that and we look at the behave tree, then we can see for this character that the play death animation was running, and it did play the play death animation. The reason that it didn't actually go to success is probably because it's a single frame animation, so already finished. But if I shoot this guy over here, well, death animation triggered, and again, but all of them are going to be saying running for where we're at in the state. So as things are right now, it's just going to be kind of stuck there. And we want it to finish. So if we go to the play death animation, we're going to want to make sprite.play the last line here, I think. And as you can see, it's still stuck at running. So let's see if this on animation finished is ever even being set, really. It's not. Okay, and the reason for that is that our animation is set to loop. So if we turn off the animation looping for our death animation on the invader character sprite, then we should be able to go back in. Well, okay, they're playing the wrong animation now. So we want to make sure that this walk animation is still the default. So I think we need that button right there, autoplay on load. Hit play. Okay, and now our characters are walking. If we shoot them, then we do get the on animation finished tick result. Okay, that's what we want. And if we check the behave tree on the first invader, well, we can see we're getting some glitches there. So let's see, signal on animation finished is already connected. Right, so we do need to make sure we disconnect the signal here. So I will go ahead and do that so we don't get any errors. Let's hit play one more time, shoot the guy a few times, and let's check the debugger. So we can see that it's still trying to go into is death condition success. And it seems like we don't actually want to return success, because once we do that, it's going to come back into the start of the condition and keep checking that on every frame. So although we can use this, connect for animation finished, we just always want to return running. So we actually can keep it a lot simpler. We just need to play the animation once, get rid of this bit, and that right there. And all we need to do is play the death animation, at least for now, and hit play. So if we watch the debugger on that, then now it's only going to come in here once, or it should only come in here once. And to prove that, I'll put a breakpoint here for the before run. So you can see it's not calling before run over and over again. We're just repeatedly running the death state. And then here, okay, our sprite's going to play the animation, but it only happens once. And then from that point forward, it's just running tick. So if we needed to exit the tree here, we might actually need to check the blackboard to see if is alive was set to false so that it can fail out of this state and then continue on to the hit sequence. We don't need that specific functionality for this game, so I'm not going to do that condition to check and return failure here because we're going to say that once a character has died, that they do not come back in this game. So I would just leave it indefinitely at play death action running. What I might do instead, though, is bring back this sprite.animationFinished.connect. And then this is going to be the on animation finished. And what we'll do on animation finished is actually remove the actor node. So function on animation finished. Okay, so in animation finished, we want to actually free the actor node. So let's get a reference to the actor as a node. When we before run, we'll get that initial reference. So we can say actor equals, well, it's the actor. But I'm going to actually rename that to be p actor. Okay, specify that that's from the parameter there and there. And we're going to just call actor.QueueFree. Whenever our death animation finishes, we're going to free the actor from the scene, basically. And then that means that this whole behavior tree is going to cease running because it's part of the actor scene, which is the invader root. So if we hit play now, and we shoot a few times, what you can see after it finishes the animation, we just remove the actor from the scene altogether. And if we check the debugger, the behave, you can see it no longer exists in the scene. Okay, that's probably what we really want for our play death animation. So at this point, we can use the behave tree in order to make our characters run their death animation, like so, and then remove themselves from the scene. But we need to work on all of the other possibilities of our character states. So the next is that we get hit, but our character hasn't died yet. So we'll need to have a property for is hit and set that onto the blackboard. And then we'll need to play hit action, which will be really similar in playing the animation on the character sprite 2D. So let's take the is hit condition leaf. I'll call it is hit condition. And then let's right click it and extend it. So this inherits from condition leaf, and we will put this in, I'm thinking this will still go in objects. There's the situation where you might play a hit animation, even for something like a barrel to indicate that it got hit. So I think it's okay to put it that far up the hierarchy. Let's create, and then we're going to make it really similar over here to the isDead condition. So I'm going to basically copy and paste all of this over here. Now you could reuse the same script, and then as export vars, you put in the names of the keys, but we can only change the property that we're using for the get value if we have it hard coded in here. So I guess that would be one of the downsides of pulling the strings out of this resource rather than putting them in an export var directly up above. So for this method, we're going to have a key for isHit, and let's go to Blackboard keys and add that in. So at export var isHit, string name equals isHit. Now to align them, I'll tab them over with the tab key, kind of like that. Okay, and that makes it just a little more readable. So if we go back to our isHit condition script, we should be able to pull isHit here. So we'll just say var isHit. So this is going to be equal to the get value. There's no not here because the name of the property here is the same here, so no need to invert it. So if we are hit, then we're going to return success. Otherwise, we're going to return failure. So if we return success, that means that our tree moves on to the play hit animation. Otherwise, it will move on to the wander sequence. So for our play hit, let's extend that after renaming it. So I'll call it play hit action. So I'll right click this and extend a script, and we'll put this in the objects folder as well. So play hit action extending action leaf. And since this is going to play an animation on hit, we can pull some of the lines of code from the play death action. So I want this bit about getting the sprite and animation names, and I'll paste that over there to play hit action. Let's also give it the class name, play hit action. Save that. We'll assign the sprite in the inspector to character sprite 2D, and we'll quick load the animation. And let's open up animation names and add in an at export hit animation, string name equals hit, and I'll use tabs to align them. Okay, so now back in play hit. So similar to the play death action, we're going to need a before run, which is going to play an animation. And we're going to want to connect to the animation finished signal. When the animation is finished, instead of QueueFree the actor, we're going to set the current status to success so that it can continue on to the wander sequence. Otherwise, it's going to return running. So we could probably copy most of this over to the play hit. I'll paste that in there. We don't need a reference to the actor node because we're not doing anything with that. So I'll remove that part. But let's set up a local variable, and we'll say is playing. We'll default this to false. On animation finished, we'll say is playing is equal to false. And after we play the animation, we'll say is playing is equal to true. Also, after the animation is finished, we can disconnect from the signal as well. So I'll copy paste that, and we'll change this to disconnect. So we disconnect from animation finished. And lastly, we'll check here if is playing, then we're returning running. Otherwise, we're going to return success. So otherwise, return success. And if I have that right, that's pretty much all we're going to need, aside from setting up the animation. So we need an animation called hit. We can see that in animation names. We need this hit animation. So let's click on the character sprite 2D, and we're going to need a hit animation in here. So I will add a new animation. I will rename it to hit, set the FPS to 10. It should not loop because we want it to end. And I'll just try to copy one of these frames over to the hit animation. So I'll take this 3 over here, which is the 4th frame, and I'll paste it into here. If I remember correctly, that's not really a proper hit animation for this character. So we'll just leave it to that for right now so that we can see it. And let's hit play and see how much is working, if at all. So we can see is hit condition, var is hit. The value hasn't been set in the Blackboard, and we want to default this to false also. So we can see that the keys for this condition leaf have not been set. Also, we want to make sure this defaults to false because by default it should not be hit. And we can give it the class name is hit condition and stop that. So let's click on the is hit condition and assign to this node the Blackboard keys. The nodes are already assigned on the play hit action, so we're good there. Okay, and now we can hit play again. Let's go to debugger, behave, click on the first one, and we can see that if we look down here, our death sequence is failing because the character's not dead, and the hit sequence is failing because the character's not hit. So we're actually moving on to the wander sequence, which currently isn't doing anything, but that is where it should be right now. It should be trying to run the wander action. So for our character to get hit, we would use the Hurtbox for that. So in the Hurtbox 2D, we have this hit function, which deals damage to the character's health. But what we should do here is also emit a signal so that our object blackboard setter can get that signal and use it to set in the blackboard that the character was hit. So we could create a signal up here was hit, and let's say the damage value. So after getting this damage dealt, let's emit that in the signal. So I'll change this actually up here to damage dealt, because that might differ from the amount of damage passed in after calculations and stuff for damage. So we'll do was hit dot emit, and we'll do damage dealt. And now we just need in the object blackboard setter a reference to that Hurtbox. So let's open that up, and we can do export var Hurtbox. So just like with the health component, we'll disconnect and connect to the signal as needed. So if is instance valid Hurtbox, then we're going to disconnect from the signal. So Hurtbox dot was hit dot disconnect on was hit. Hurtbox equals value to set it, and then connecting to the new Hurtbox. If is instance valid the new Hurtbox, then Hurtbox dot was hit dot connect score on was hit. Okay, so let's create that down here at the bottom. Function underscore on was hit, which is going to have a p damage dealt integer. We don't need to do anything with that in this function, so I'm going to underscore it to indicate that it's not used. And we'll do blackboard dot set value is dot is hit, and we'll set that to true. So the Hurtbox is Hurtbox 2D, so be sure to update that class name there, and we'll assign it. So now our Hurtbox will be able to set the is hit to true, which should trigger the play hit animation in our character. So I'm gonna hit play, open up the behave tree, and let's shoot this guy over there. Okay, and you can see that this time the play hit action was running after is hit is checked. Now it's kind of glitching here for some reason. So let's hit play, open the debugger, look at the invader behave tree, and let's get it to be clean here. So when we shoot one of the invaders, like so, we'll see that the play hit action is running. And once it's done, it's going to loop through here. Is hit condition is set to true still because we didn't set the false. So it's actually trying to come here, this succeeds, and then it loops again. And that's almost what we want. But when we return success here, we want to also set the value on the blackboard. So blackboard.setValue. And for that, I suppose we'll need the blackboard names, blackboard keys, which is of type blackboard keys. So we'll set blackboard keys dot is hit to false. Okay, that should take care of that. And now if we hit play, let's open up the debugger, the behave tree. It's not, I'll shrink my window a bit so that it's actually not in the way. Okay, let's hit play again, debugger, make it easy to read. And let's click on the first one. So currently it's in wander action, I shoot it, and then it goes to this part of the code, setting the value, but we haven't assigned the blackboard. That's the problem. So we need to assign the blackboard keys here. Assign that. Let's redo that one more time. So debugger, behave, click here, spread it evenly so we can see cleanly, and then shoot. And then you'll see that the play hit action was playing, and then is hit goes back to being false. So I can shoot there. They're not supposed to actually die completely, so that's a little odd. I think it's probably because the wander sequence doesn't play a new animation there. So in our wander action, we'll need to set a new animation. So we don't actually necessarily need a wander sequence. We can just move this out here like this. So rather than playing a wander sequence, it'll just be the end result. If it's not doing anything else, it just comes down here. So if we look at our, well, let's hit play and look at our behave trees. Okay, then it should look much the same, except there's no sequence here, but it will still move on to wander action. If the hit sequence is success and the death sequence is success, then it'll move on to wander action. I'll right click wander action and extend a script. This will extend action leaf. So wander action create, class name wander action. Oh, and this should actually go in the characters folder. So we'll put it in characters. So I'll just move it up one level. So this will randomly move the character left and right after a timer is set and occurs. So we could say at export var timer of type timer. So let's right click on wander action, add a child node. We'll look for a timer, and this timer can be called the wander delay timer. So I'll wait, let's say 0.5 seconds to decide whether or not we are going to wander to the left or wander to the right. So every 0.5 seconds that wander action is running, we're going to wander to the left or wander to the right. So sometimes that might randomly go in the same direction, and sometimes it may switch to the other direction. So let's open up wander action. I'll just copy some stuff over from play hit action. So we'll want the before run to start the timer and the tick to continue the timer. So before run, we're going to start the timer, timer.start. But first, let's connect to the timer timeout, timer.timeout, and we'll connect. And we'll say on timer timeout, but we'll give it a shot to start. And then function on timer timeout. When that occurs, we're going to run the randomize wander, and then we're going to restart the timer. So timer.start and then randomize wandering. Okay, so to randomize the wandering, function randomize wandering. So this will take the character node and set its direction value to left or right, which will automatically make the facing trigger. So let's do at export var character, which is going to be whatever this script is called, platformer character 2D. So I'll paste that in there, and we'll randomly get a left-right direction. So var random integer is equal to, let's see, random number generator dot new. So I need a random number generator to create the random integer. So I'm going to actually cut this, put it up here, and let's make this on ready var. So rng equals random number generator, or we could call this maybe random gen. I think that's a little more clear. And then down here in randomize wandering, we're going to do random gen dot random I. Okay, and then we can say if rand I percent. So this is going to be the remainder if you divide by 2. So this will either be a 1 or a 0. So if this is equal to 1, we'll face left, and if it's not, then we'll face right. So character dot direction is going to be equal to let's see, vector2 dot left. Otherwise, character dot direction is going to be equal to vector2 dot right. Oh, and we'll also need like a wander speed of some kind. So that could be based on character stats, and maybe that makes sense so that we can have like a consistent variable. So while it's running, let's say that the actor and the character here are the same. We don't really need an export var for the character because the actor is getting passed in. So let's take the character line down below here. This will be var character. So before we run, first we're going to say that character is equal to p actor as platformer character 2D. So we expect that the actor is of type platformer character 2D. So this is an action that's specific to platformer character 2Ds. Okay, we should also call randomize wandering right after the timer starts here before run. So we'll randomize the wandering then. And when we randomize the wandering, I guess we should also be probably setting the velocity of the character. So character.velocity is going to be equal to character.direction times, let's say stats.walk speed. Okay, so on the invader, on the platformer characters 2D, we have move speed and jump force. I'm wondering if those should actually be more like a character stat, because these are really stats of the character. They're specific to movement, but they're still stats. So we could pull those out to the character stats resource. So in here, we'll say export var stats, which is of type character stats. And then maybe all of this here, we just cut and move into character stats, like so. Okay, and then we need to, of course, update our scripts here. So it's going to be stats.jumpForce down here for the jump, and stats.canGroundJump for that. In the inspector, we need to quick load the invader stats. Okay, so we can see all of our properties are now there. Let's check the player too, because the player is now also going to rely on a character stats of type. So we'll need to do a new one here, new character stats. We can save this if we want to objects, characters, player, and let's say player stats. So we'll need in the player script stats.moveSpeed. So now those movement speed values are being pulled out of stats resources. If we go to invader. Okay, and now we can probably go to one direction, and we're setting the velocity times the stats.walk speed. Technically, that being the case, we don't really need to have in the wander action the stats set here because the character already has its stats. So we could do something like this, cut away the stats, and then we'll do character.stats.walkspeed and save that in there. So this makes sure we're pulling from the same space, and the character is definitely going to be using its own walk speed stat for determining how fast it's going to move here. And let's assign the wander delay timer and hit play and see what we got. So invalid property walk speed, I think, because that doesn't exist. So if we go to stats, it's called move speed here. We might want to rename that if we want to have walk and run. So I think that's reasonable. Let's jump into stats. You can right click on character.stats, look up symbol, and then let's change this to walk speed. And we could say export range, and then just all the same stuff or greater. Our run speed, and we can default this to a float that has a value of 200. Okay, if we want to do it like that. Of course, since we changed the variable name, we need to go back to the scripts and see if that is problematic here. So in platformer character, it's not, but in player 2D, we probably do need to say walk speed here. And then in wander action, we're using the walk speed, which we can right click, look up symbol, now exists right here. If we look at the invader, the walk speed is 120. You can adjust it if you need to. So if we hit play, we'll be able to see that our invaders are now wandering left and right. Every half second, it randomly decides if it's going to go to the left or go to the right. And they're really fast, so I probably do want to slow them down quite significantly. I might even just take the default walk speed and make that 60, and then maybe the run speed will be 120.0. Now, if I do that, I do want to make sure I update on the player that it has the custom values of 120, 200, but I think the idea is that I do not want most of the characters in the game to move as fast as they were before, so changing the default value here makes sense. Okay, so now that we have a slower value here, let's rerun the scene, and yeah, our invaders are a lot slower now. They're not unreasonably slow, but it could be touched down a bit. It depends on just how aggressive we want these guys to be. But I think that's pretty good for right now. So let's shoot them, and okay, we see that the hit state doesn't enter. If we shoot them until they're dead, they do die in the sense that they can't be hit anymore, but it's not going back in the logic of the tree. So if we look at the debugger, we'll see exactly why that is. And that's because no matter what happens here, the wander action is still running. So we need to stop the wander action basically whenever the character gets hit. So for us to exit the wander action, we need it to not return running, but to return success or failure. I have a few ideas for what we can do there. On timeout, what we can do is we just return success. So we'll have a variable is wandering, which will default to false. Of course, when we start the wandering, we'll say is wandering equals true. And when the timer times out, we won't restart the timer anymore, but we'll say is wandering equals true. So on tick, if is wandering, then we're going to return running. Otherwise, we're going to return success. Now this will be fine for basically having this wander action stop, and then it would look to future actions. But if we want to go back in time, if we want to go the other direction of having a interrupt where our characters hit, so we either play the death sequence or play the hit condition, then we're going to need in our wander code to basically, when it gets hit by a hurtbox, that we stop the wander action immediately. So as for interrupting the wander action, you can create a function interrupt, which takes an actor and a blackboard. I'm going to actually keep it simpler by just whenever we have a tick, hit condition is set to true. If so, return failure because the wander was not able to complete. Otherwise, you can create the function interrupt, which basically is the same signature as here, except you call it interrupt. And then you can call interrupt to interrupt the wander action. But I think to kind of keep it as simple as possible and not need external nodes other than the blackboard, I'll just check on tick if is hit or is dead happen to be true. So if is, well, let's say, yeah, let's create some variables up here. Is dead is equal to, and I'll say p underscore blackboard up here. So the parameter blackboard dot get value. That's going to mean we're going to need blackboard variable names. So export blackboard keys of type blackboard keys. So this can just be keys. It doesn't need to be called blackboard keys. And we'll say keys dot is alive. And we'll say, actually, let's change the variable name is alive. So we'll get the value there. And we'll say is hit equals p blackboard dot get value keys dot is hit. So if not is alive or is hit, then we're going to return failure. And then this will become an else if. Else if, actually, it doesn't really need to be. We could just make it if wandering. And then this doesn't need to be an else. It can just be the default. Okay, I think that's a little bit cleaner because we can just exit the if loop and then continue on and do another if for running. Yep. Okay, so basically, if the character gets hit or if the character dies, then we're going to return failure from here. And what returning failure from the behave tree allows you to do is restart the tree in the sense of going back down the selector, so it can check if the death sequence should run, which would be the play death action, if is alive is set to false, or it can play the hit sequence. If the hit condition is hit is set to true, then it can play the hit action. Otherwise, it'll come back into the wander action and run the wander action again. That also occurs on success when is wandering is false, which is on the timeout here. Then this can succeed, which will allow the trees to restart again. So we should be able to hit play now. And well, we can see is alive. Oh yeah, right, because we have to reference the blackboard keys. So click wander action, quick load, blackboard keys. Okay, and then you can hit play. So if we hit play and we fire a projectile, we can see that the death animations are able to play. We've got lots of bugs going on right here. So let's check the debugger and I'll also stop the scene. So as we can see, the timeout signal is still connected. So I need to make sure I disconnect that. So on timer timeout, we should disconnect the script from the timeout signal. So let's just copy that there. Timer.timeout.disconnect this function. So it should only run once. Let's see if we hit play now. Does that fix anything? Okay, the problem is that we're setting is wandering to true when it should be false there. Let's hit play and I'll try one more time. Okay, I guess there's still other issues. A true here to return failure. So there's two ways we could do that. We could either have a default value up here, or we can make this check for Boolean. So instead of saying if not alive, we could say is alive equals false. And then is hit is equal to true. So if it gives a null value because it's never been set, it shouldn't fail immediately. Let's hit play. And okay, now it's a little more correct. If we shoot them, yeah, it's going to return failure out of this tick function. And then I guess that goes to the, well, let's check what state is he on. When we return failure here, the on timer timeout never triggers there. There's probably a better time to actually set these bits right here. Is wandering is set to false. Let me look up the symbols. Maybe there's like a on exit. So we have a behave node after run. Okay, that should be good. So let's copy this bit here into the wander action. So have function after run, and after the run, we can disconnect the timer and make sure that is wandering is set to false. So we can copy that into here. And I think we don't need timer.timeout.disconnect here because that's immediately going to basically get to this after run. But we do want to make sure that is wandering is false. Even if we set it here, we still might have the situation where we return failure and then we need it to be set to false. So the next time we come in here, it's still false. So if I hit play, we have the wander going on. I can shoot, and then it plays either the hit or the death animation. The wander action actually isn't playing any animation right now, so that's why basically it doesn't go back to anything. But I didn't see it play the hit animation at all. Let me check the character sprite, and then we have hit, death, and walk. It was definitely playing the death animation. So on wander action, let's add export var animations, animation names, and then we'll need the character sprite. So at export var character sprite, or we could just say sprite, which is a animated sprite 2D. And we're going to make it play the walk animation. So sprite.play animations.walk. We haven't defined that. We will right now. So let's go to animation names at export var walk, tab, colon, string name, that'll be a walk. Okay, so we assigned the character sprite. We assigned the animations, quick load, animation names. Okay, so if we hit play, we can shoot the characters and they'll switch to the death or hit animation. Now it should stop moving. So to make that happen, we should take the velocity of the character and set it to 0. So let's say character.velocity equals vector2.0. Later it might be a little different than that. Okay, so for now, let's hit play. And when I shoot a character, you'll see that they stop until it switches back to the wander state. So we can fire these projectiles and they'll get hit. And once they take 4 shots, well, the health is depleted, so they're removed from the scene. So that's pretty close to what we want for the basic behavior for our character. So this part's going on a little long, so in the next part, we will finish on cleaning that up. So in this part, I'd like to get to where when we shoot an enemy and they get the hit animation, that it actually has a bit of a knockback during the hit state in the opposite direction from where they were hit. In addition to that, I think we should spend a little bit of time cleaning some things up. I did notice one bug here, so if you look at the play hit action, you'll see that because I copy and pasted from the play death action, that it's actually playing the death animation here instead of the hit animation. So if I save that and we hit play again, then now when they get hit, it should be that freeze frame of the 4th frame was what I set to the hit frame. So in addition to that, the intention of this project is that there will only ever be one set of names and key names, for consistency reasons across the entire project. So because of that reason, I think it might be appropriate to our project if we use a global name. So similar to calling something animation names, we can, in the project window, project settings, create a global object here. And then in any script, we'd be able to reference it basically by the name of the object, which would be something kind of like Blackboard keys, and then dot the property you're trying to access on it. So what I will do in the data folder is create a new script, and I'm going to call this global names.gd. And this can inherit, we could make it node, but object would be fine as well. Let's just start with object. It doesn't really need to run in the scene, so there's no need for it to be a node. So we'll create. And then we have global names.gd. So we need to create a object. And so to create a global object and put it in the globals of the project, let's right click on the data folder, create a new script. I'm going to inherit from resource because I want it to sit inside of our data folder like the other resources here. Let's go to data, and then for the path of it, I'll call it global names.gd, create. Okay, so this is extending a resource. We don't necessarily have to give it a class name because we're going to be creating it as a Singleton project-wide global variable. But what we do need to do is make sure that we get references to all of our names resources. So this is going to have the name global names. So we don't need to specify names here. So we could say animation, and then this would be a type of animation names. So I'm just kind of making it the short form of the name of the resources so that it'll be easier to be like global names.animation and global names.keys, for instance. So let's see, should we call it Blackboard or keys? Probably keys, I guess. Blackboard keys, and then at export var group names. Okay, and let's tab these over a bit to get them to sync up with each other. And we will create this resource. So I'm going to right click on data, create a resource, And we didn't create a class name, so it's not going to show up in the list. So I'll just create a default resource here. And this would be called globalnames.tres. So we'll click on globalnames.tres and we'll assign the global name script, just like that. Now we need to assign the animation names. So quick load that, the keys, Blackboard keys, and the group names right there. So we can go to project settings, and in globals, let's add a reference to it in data, and then I like list view. So let's do globalnames.tres and open that and add this. So let's see, it fails to autoload because it's probably not a node, right? Failed to create an autoload, path is not pointing to a scene or a script. Yeah, okay, so I guess I was wrong. It does need to be a node actually. So we'll create a node. I'll delete the globalnames.tres. And then let's right click, create a new scene. So this is going to be called globalnames.tscn, and we're going to access it with global names as the root name of the scene. And this will just be a basic node. It doesn't need any 2D transform. Okay, so we create that, we open up the scene, and we assign the script. So just like before, just like with the resource, we're going to quick load the animation names, the keys, and the group names. Okay, so if we go to project settings, let's add this in again. So we want globalnames.tscn, add. It's going to be called global names. So now in our scripts, we can do global names.animation.keys or .group. Okay, and that means we can go into any script which is referencing a animation names. And because we're only going to use global names for our project, we can remove the export variable. So it saves us a step whenever we create a new script. And then we just reference global names.animations dot the name we need. So for instance, if we go into character sprite here, well, first off, this script isn't going to be needed anymore because we're actually handling the death and the play death action. But if we were going to keep using this script, we could get rid of animation names, and then on death, we could just do global names dot animation dot death. So you can see now we don't even need to do an export variable and to keep assigning the resource and the inspector because we have this global value. Now there are disadvantages to this approach. For instance, if you import these scripts to a different project and that project does not have a global names scene set up, then it's going to start throwing errors here because you have to have now in project settings the global names. But you could of course just recreate that as you need. So it's not that much different than needing to recreate a resource and assigning it in the inspector, to be honest. But it's something to be aware of. So we're no longer checking for animation names because we don't need to assign it in the inspector, so we can just remove that. Honestly, we can just unassign the script to the character sprite because we don't need it at the moment. And let's see if anything else is using a reference to the names. So if we go to, let's see, object Blackboard setter, for instance here, we can get rid of the keys. I'll save the script, and okay, now we need keys.alive. So where do we get the keys from? Global names.keys.isAlive, and we just copy that down there, and it gives us our reference to the global object which has those properties. So once again, cleaning up the inspector, and hopefully you can see where I'm going with this, just making everything a lot easier. So in the isDead condition, global names.keys, we don't need a reference to keys anymore. In the play data action, we can do global names.animation.death. I'm actually going to change this symbol to be animations, and maybe we'll make group names, groups. Yeah, okay, just implying plural with all of them. Okay, that might mean we need to go back into here and add the S, otherwise we'll get an error, but easily fixable if it's just a misnamed property. Let's just check all of our scripts. And we don't need the animation names there. So we can go down to isHit. We don't need Blackboard keys anymore because we're just doing global names.keys. And then on play hit, we don't need animation names or Blackboard keys. So let's save that and update the lines that needed those properties. So here is going to be global names.animations.hit, and here's going to be global names.keys. And one direction probably has something too. So animations and keys. Let's get rid of those, save, and we'll see all the error lines. So global names.animations and then global names.keys. I'll copy paste the global names, copy paste it down here as well. Like if you were in a bigger project and you were going to be updating a lot of different scripts at once, you could use something like Visual Studio Code's find and replace tool. That really goes outside of Godot to like an external editor. But it's similar to if you do like Control R on the keyboard, you can rename string finds, and you can match case or whole words if you want. And then across your document, you can replace all. So in Visual Studio Code, there's the option of doing it across your whole project. So sometimes I use that and it's pretty handy. Okay, but yeah, basically instead of setting like 7 scripts having their own reference to animation names and Blackboard key names, now we just have that one global variable that has all of those, and there's only ever going to be that one global. So definitely if we need that consistency, ensuring every script in our project uses those same properties, then that's a pretty solid way to do it. Generally though, I try to stay away from globals, but I think this is a pretty good use for it. Okay, so let's check the player scripts, and we'll make sure there's nothing in here that needs updating. The facing component, hand anchor, the shooter does need it. So group names here, I'll get rid of group names there, hit save. Okay, so now we need the global names.groups. Okay, and that updates that script, so that's pretty much it. In our level scene, I don't think we had any scripts outside of these guys moving around, the player and these. So if we hit play, in theory, everything should work still. Let's see. Global names.groups. Okay, so let's see. So what went wrong here is that we have an assigned groups or animations on the node. So let me go ahead and check that. Global names. Yep, okay, missing the groups. So assign the group names. And assign the animation names as well. So it might be worth mentioning that because you have this global object, if you needed to update these values across your project, you could assign a different resource in this global, or you could go into each of these individual resources and change their values as you need across your project. But it is there if you need to edit it. So let's hit play again, and I think this time it should work fine. Okay, so we got our hit animation. It's just one frame, but later we'll try to make it a bit cooler. Our characters can die. Death takes priority over hit, which takes priority over wander, so it is working exactly as written at the moment. So now we'd like for our play hit action to actually have a knockback. So we could pull a value out of, let's say, the blackboard, which would be the vector of the direction that the character was hit in, at least the last hit, and then move the character basically backwards from whatever direction it was being hit from. Okay, so in order for our character to have a knockback effect trigger on it, then we need to get from the Hurtbox, probably on this hit function, a knockback value, and that should be determined by the projectiles properties or any attack that's hitting the character. And then eventually we want to get that set on the Blackboard setter so that on the play hit action, we can pull that data out and then use that to basically move the character in the direction it should be while it's in that hit stun state. So there would be something like a P knockback vector 2D in addition to that. But if I think about it, I might also add in how long the duration of the hit knockback should be, which could vary depending on the weapon. So maybe a big hit is a long knockback, and a tiny swipe at a character should only be a stun for a fraction of a second. So to handle all of that, since that would be 3 or more parameters, and we might add more later, we might also want to create an object to handle hits rather than just passing the damage value in here. So that'll mean that our was hit will change more to like a hit parameters as a object rather than passing a integer value. So we can basically add as much data to that object as we want. And as a result, we can have a much more complicated hit setup without creating too many extra parameters. So in our project, it might make sense to put it in data, but also weapons kind of makes sense. And since we're talking about things that are hitting other things to deal damage, I think putting our object script in weapons actually makes a little bit more sense. So I will create a new script in weapons, and I guess calling it something like hit data makes sense. So this will be an object, not a node. So basically, we don't need to add it to our scene hierarchy. It's just a pure data object. So that's why using object makes more sense than a node. So there's no need to have process or physics process running. We just need to pass data from one other object or node to a different one. And we'll do that with our data object. So hit data, create, and inside of our hit data, we can give it a bunch of fields. We don't make them export values though, because a object is never going to really show up in the inspector. So we're not exporting it to the editor to be edited. This is only going to be basically persisting during gameplay and only then. So our hit data is going to consist of the object that did the hitting, I think. So we could say the hitbox that attacked, that will be a hitbox 2D. We also want to probably get reference to the Hurtbox that got hit. So the Hurtbox, we probably want to have the damage that was incoming and then the damage dealt. So we could say damage dealt here, which is going to be an int. But before we calculate the damage dealt, we're going to have the damage expected. Yeah, that makes sense. And what else would we need? The knockback vector. So knockback, I guess we'll call it force. Since we're dealing with character sprite 2Ds, it's not exactly like a physics force, because we're not treating them like a rigid body in this game. We have to basically hard code the movements. And that's part of the difference between the character body 2D and a rigid body, which would be pure forces, like the projectile. So the knockback force is going to be, of course, the vector 2. Knockback duration. Knockback duration is going to be a float. And we could default this to something like 0.25 if we want. I'm also going to tab these all over so that I can see easily which type is which. Okay, yeah, that's a little bit cleaner there, and maybe this gets an extra tab. So when we create our hit data, there's a couple different ways we can do things. One would be that we don't create a custom init function, and then we'd have something like a create hit data function in another script, and we do something like var data equals hitData.new. That's not going to work right now because we need the class name up here at the top. So class name hit data. And then now with data, you can assign each of these properties individual, which could be handy in a sense that you aren't forced to actually include any of these properties when you create the data. But it might also be kind of messy because, especially if you create new fields that are required, you may forget to set them in your script. So I think I would lean slightly towards doing function underscore init. And then when we have our init function, we pass in the parameters, including the required ones and the optional ones. And then if we ever change it, we'll get errors in our code so that we'll know to actually go back and update it. So I don't think we would update hit data too much with new properties, but when we do want to make sure we account for that. So let's start with the required ones. P hitbox is going to be a hitbox. And I'm calling them P for parameter because I'm going to be saying like hitbox equals P hitbox. So we want to make sure we're specifying the property in the object and the parameter we're passing in as two different things. So that's a hitbox 2D. And then we're going to have P Hurtbox, which is Hurtbox 2D. And then we're going to have the expected damage. So damage expected, which is a int. But you know what, while we're ahead, there might actually be a situation like a healing projectile, for instance, down the road where we might change the health, but it's not necessarily damage. So let's account for that in advance. So we could call this like health expected and then health change. Okay, and then this should be P health expected there. So we're not actually going to pass in health change as a parameter here because when we create the hit, we haven't processed the health change yet. So we'll update the health change manually, probably on the Hurtbox or after that, to set back in the data what the health change value is for anything that needs to know. But we'll have the optional parameters, knockback force and duration. So P knockback force as a vector2, and that's going to equal vector2.0 by default. And then we're also going to have p knockback duration, which is a float, and then that'll just be equal to 0.25. Yeah, I guess so. And then I'll remove the default up here. So these are our required parameters, and then these are our optional ones. I guess the knockback duration will actually be 0 by default. So if there's no knockback, I guess that is what we want the default to be. So if we want a knockback, we'll have to set a manual direction vector and a manual duration here. So we can see I'm getting a expected indented block after function declaration. So we need to hit enter and do a pass. So we need to hit enter and give it a pass to actually add the function. And then up here, hitbox to D. I see. When I created the name hitbox, it was lowercase on the B. Yeah, I think that's fine. I might change that later, but I think calling it lowercase hitbox is okay. Okay, so change that, and then now we want to actually implement the init function. So this is going to be pretty simple. Hitbox is going to be equal to the p hitbox. The hurtbox is going to be equal to p hurtbox, and so on and so forth. So health expected is going to be equal to p health expected. Knockback force is going to be equal to p knockback force. And duration is going to be equal to the knockback duration. So I don't super like the property name health expected. I'm going to try renaming that in all cases across our script. So you double click this, you control R, and it's going to try to rename health expected, including where the variables are prefixed by p underscore, and it's going to change those to whatever we want. So I'm going to say maybe amount, because when you hit, there's an amount of change and you would expect that. So I think that's still pretty clear, but easier to type. So I'll rename, and now you see it's now p amount, amount equals p amount, and amount up here at the top. So just keeping like the shortest possible variable name that's still very clear about what it actually is. And if you need to specify more about what each is supposed to be, then you can go up here to the top and you can do a couple hashtags, or really just one. If you do 2 hashtags, it adds it to the documentation. Which actually, no, that should be there. So let's add in a comment here. The hitbox which hit the hurtbox, I guess you could say with a move or attack. And then here, the receiving hurtbox of the move or, and then over here, you could say the amount of health change expected on the target. I think actually the health change, because that's not part of the original data, I'm actually going to remove that from the hit data. We might not need it to be in the hit data because this is more of the reaction result, which could be emitted in its own signal on, say, the hurtbox, rather than the data of the hit being transmitted to the hurtbox, so to speak. So I don't know. Maybe we'll add it back in later, but I'll have to see. Okay, and then the knockback force is the direction, and the force amount or the magnitude. I guess magnitude of the knockback would be more technically correct. And then the duration is the length of knockback, keeping the character in the hit. Well, not necessarily. We'll just say the length of the knockback duration. Because not every character is actually going to play the hit action. Maybe some characters just completely ignore the knockback duration and they continue moving as normal. So it's not necessarily a certain thing that the play hit action will be going on every character. That's just the expected default for right now. Okay, so that pretty much clarifies this class pretty well. So if we were to click search help and look up hit data, we should be able to see all of the information we just typed up here as documentation for this class. The class itself doesn't have a description yet. If you want to do that, up here at the top we could say data properties concerning when a hurtbox is hit by a hitbox, move, attack, or action. Okay, so now if we look up hit data again, we'll see that that just pops up there. So it's like instantly created documentation, which is a pretty cool part of Godot. And I think we can even click the properties and jump right to them. Yep, pretty handy. So now back in Hurtbox for the hit function, instead of receiving the P damage int, we can actually just receive the hit data. So let's do hit data. And we can say p hit data underscore data. I'll also make that what gets emitted here. So hit data, when the hurt box is hit with the hurt data, we can emit that. And now from the hit data, we want to minus equals the p hit data dot amount instead of the p damage. So regarding the damage dealt, we can add that back into the p hit data. And I know I just removed that field. So we'll say p hit data dot actual or changed, actual change. Yeah, I guess actual change, sure. It's going to be equal to the damage dealt. So this is going to be a negative value. So since the change doesn't really specify if it's positive or negative, we should say -1 times damage dealt. Okay, now we need to add this hit data property back in. So under amount on hit data, the actual amount of health change that resulted on the target var actual change. It's going to be int. Okay, so setting the data back on the hit data, and then when we emit the data into this hit data, it's going to have that property. So it's basically taking the data, updating it, and then re-emitting it from the hurt box for anything that needs to respond to this. So we're going to emit the p hit data down here after modifying it, and then we return the damage dealt, I guess. Let's see. Actual change. Let's rename the values here. So I'm going to rename damage dealt to actual change. And then we'll say -1 here times the old minus the current health. So if it's dealing damage, it's going to be made negative here. And then we don't need to make that negative here. And we return the actual change. So let's give this a comment. So this hit function changes the health value on the health component. It adds the actual health value to the p hit data, and it will return the actual amount changed. So if this is a negative value, we know it dealt damage, and if it's a positive value, then we know it actually healed the character. So basically, the hit function can be used for both heals or damage dealing effects. That way we don't have to create separate functions for that. So that's going to do the hit. Was hit is going to trigger. We're going to get the hit data, which means if we go back over to the object Blackboard setter now, was hit is going to be expecting the p hit data. And if we hit play and tried to run it, it would probably throw an error and we just end up over here at an error point. But I'm just doing this preemptively. So the hit data is going to be that. So let's see, the global names keys is hit. Instead of setting a Boolean, what we can actually do is just pass in the whole hit data. And that will mean that on our play hit action, we can just pull all of that information from the one data object rather than just the fact that it was hit. But now we have access to everything else inside of the play hit script, like the knockback vector. P hit data, we'll pass that in, p hit data. And instead of keys is hit, we'll do keys dot hit data. Okay, so that of course means we need to jump into the keys, Blackboard keys, and we're going to update this. So instead of checking if the Boolean is hit, we'll check if there's an active hit object assigned inside of the Blackboard. So basically, if the character's hit, there'll be a valid object, and if it's not, then there won't be a hit object. So we'll have var hit data, and this is going to be a string name still, and we're going to be looking for hit data. Okay, so we can get rid of the property is hit. Now let's jump over to the play hit action, or the play hit condition, really. So we're going to be checking for var hit data is equal to p blackboard.getValue, global names, keys, hit data. And by default, that's going to be null, which is the default value. So we don't need this anymore. So if the hit data is not null, which can just be this. If hit data, then we return success, else return failure. So basically, if there's no hit data, then we're not doing the play hit action, which means that if we go up to play hit action now, we're once again going to be getting that hit data, and we can do that up here. And we can do that on before run. So var hit data, and the before run, let's see, we're going to be getting the hit data from the Blackboard. It's going to be equal to, and this should be p Blackboard. And I'm going to make this p blackboard to make it consistent with this over here. So the parameter blackboard is going to get the value. The key we're looking for is the global names.keys.hitData. So we do expect that this is going to be there. If it's not there, that's really a problem. So we're going to assert hitData does not equal null. Or we could say is instance valid hit data. So when you do an assert, it's only going to trigger these asserts during development mode, but it's a big problem if we try to run the hit action and we don't have hit data here. I mean, we're probably going to get an error anyway, so this isn't necessarily required, but we could have it there anyway. Hit data must be set for the play hit action to run. Just kind of like as an extra there. So we really want to emphasize we have to have hit data for this play hit action to work. Otherwise, we're going to run into problems. So since we got the hit data, and this hit data is going to be consistent for our entire play hit action, we don't need to keep pulling from the blackboard or anything. We just need to use the data as we would expect. So for our hit knockback, it's going to have a knockback stun, right? That's the knockback duration. And we only want the hit animation to actually play if there is a knockback stun of sorts. So if the duration is set to 0 seconds, then we would just skip playing the animation actually. So we can say if hit data dot knockback duration is greater than 0.0 seconds, then we're going to play the animation. We're going to connect to animation finished, and we're going to set is playing to true. Otherwise, we want to enforce that is playing is false because there's no knockback. There's no stun. So basically, as soon as we finish up with this function running one time, we're already done with it. So we should just return success. So is playing is going to be false. It's going to come to the tick on the next update, and it's going to return success down here. And what we want to do is instead of setting the Boolean to false, we want to set the property of the hit data. We want to set the variable, the hit data, to null. So we're going to take global names.keys.hitData. And we're going to set that to null. And because that's null, the next time it tries to look at the is hit condition, it's going to be basically null, and it's going to return failure, which means it's just going to move on to the wander action rather than the play hit action. So just like with the wander delay timer, we're going to have a knockback timer, though it's going to be specifically set up for each of the hit data. So if one hit has a 0.5 second timer, we're going to do that. Otherwise, it might be a 0.25 second timer or a 0 second timer. It makes sense to have the node here, wander delay timer, set up externally so that we can customize that for all of the wander actions for the character. But the play hit timer is specific to the hit, and we don't know about the hit yet, so I would just create the timer in code. So the play hit action, honestly, we could just do @onReadyVar hit timer of type timer. So honestly, we could just do a @onReadyVar. So @onReadyVar hit timer is going to be equal to timer.new. And then instead of connecting to the animation finished signal, we'll set up the timer, play it, and connect for the timer to timeout. So let's say timer or hit timer dot play, and we're going to get the hit data dot knockback duration. We're going to connect to the timeout. But you know what? Let's do that up here rather than in the before run. So we have the hit timer. When this gets set to a value on loading, then the hit timer is going to equal the value, and we want to do hit timer dot timeout dot connect, and we'll say on timeout. Okay, and we'll create that function at the bottom, or really, let's just rename this to be on timeout. Okay, so since the hit timer is just going to be set up here on ready, we just connect once. We really don't need to connect to it every time the animation stops or finishes. So we can get rid of this line and this line down there. Whenever the timeout occurs, is playing is going to be equal to false. And let's make sure that after the run that we stop playing the timer just in case it happens to be running. So function after run, p actor node, p blackboard, and then returns void, and we'll say timer.stop or hit timer.stop. Hit timer.stop. Okay, and that'll make sure that it is completely stopped until the next time we come in here, so there's no funny things going on with the signal callback. Okay, let me just give this a quick skim. We have the hit timer. We get the hit data assigned on load. When we stop playing, then we should set the hit data to null. I guess we can take this line and port it up here so that, no matter how we exit the after run, this will always set the hit to null after the hit action is done being played. Okay, so that should be p blackboard there. This can be _p actor because we're not using it, and _p _blackboard because we're not using it. You can see in the debugger that actually there's like a lot of unused variables. I can click on those and try to clean them up. So basically whenever a value is not being used, you can just underscore it like so to get rid of those warnings. And I got quite a few right now. So let's see, p actor, and here we have _p blackboard. Okay, so let's run the project and we'll see kind of where we're at. So when our hitbox hits the hurtbox, before we were passing in the weapon stats damage. So we can see that this now requires a hit data. So before we hit the hurtbox, we need to create an actual hit data. So we'll say var hit data is going to be equal to hit data.new. Okay, and make sure to spell that right. It should highlight green. And then we need at least 3 parameters for the init function. So if we check so I'm going to close out all these scripts over here. And if we check the hit data init, and you can do that, I think, just by right-clicking on new, we come down here to init. And you can see that we need these 3 parameters. Looks like there's also a bit of an issue going on here. Can't parse hitbox 2D. So it might be hit and then capital box for the B. Let's take a look. So I got hitbox 2D. Oh no, the reason is because I just wrote a line of code which isn't valid. Okay, so we need these parameters. So hitbox, hurtbox, and amount. So the hitbox is self, of course. The hurtbox is the one we just found, the hurtbox. Okay, and when you hit comma, you can see the parameters popping up. So next is the amount, so the damage, which is weapon stats.damage. And then we need the knockback force. For right now, we'll not do that. We'll come back to that. So just save that. And then when we are emitting the signal, rather than passing in the hurtbox and the delt, why don't we just do the hit data as one parameter? So hit data, hit data. Now we can wait for the delt damage to come back, which is also going to update the hit data. So let's pass in the hit data here, which gets updated, and then we can emit the hit data. Up to us if we want that to emit before the hurtbox receives it or after it. And then the hurtbox processes it and everything else. I don't know, that just kind of depends on what you want. Like if when the hit is done, if you want to have that final damage delt data being emitted with the signal, or if you want it to just be before the hurtbox processes anything, then you can put the hit.emit before this hurtbox.hit function. That is entirely dependent on kind of what you're looking for, like timing wise. But either way should work for the most part. It's just one will have the actual health changed like this. And then if you put it before, then it won't have that data. So invalid argument for hit data, but is end. Yeah, that just means we need to rerun it. So if we hit play, yeah, we're probably going to run into a few other minor issues. So let's see, is hit no longer exists? So yeah, when we're doing the wander action, instead of checking is hit, what we should be checking for now is hit data. So keys.hit data, and then this will be of type hit data, of course. So if the hit data is valid, so basically if is instance valid hit data, then we want to return failure, because if there's a hit to process, we want to break out of the wander action. So this is on the wander action that we're talking about right here, of course. From the previous video. And yeah, these are just the kind of updates we'll need to make when we kind of change our data structures around. We hit play. Yeah, I guess right now that's pretty much it. So let's shoot a character. Interesting. It just passes right through them. Let's see what the debugger says. Error calling hit. Because we changed the parameters. So let's click that. And this is on the projectile.gd. On hit expected 2 arguments. All right, so we need to go into projectile.gd and we'll check this. So on hit is actually going to be receiving the hit data. Right. So the projectile hit the target and now we need to free it. But in order for that to work, we have to have the right parameters. So p hit data, we're not going to be using it, so I'll underscore it in advance. Now this kind of also illustrates why having a object that your data structure for all of the parameters that are going to go into a hit is helpful, because your signal is always going to emit as hit data. What hit data consists of may change as you update your project, but instead of having 2 parameters become 3 parameters and then it breaks all of your signal connects, you can just always have it be hit data, and then you customize hit data internally and all your signals stay glued together. So one advantage of just having a single parameter for a signal like this, especially when the data structures are kind of complex. Let's close and play again. So if we hit play and we hit these characters, then we can see basically for a fraction of a second, it's probably just a single frame, but they do kind of stop playing the wander action. Because it's not about dealing damage, it's about whether the animation is going to play or not. Is on the is hit condition, we'll check if the hit data is there and return success. And so before passing this on to do the play hit action in the hit sequence, let's also check if the hit data.knockback duration is greater than 0.0, and then we'll return success. Otherwise, we're just going to return failure. The reason for this is that I don't want this to interrupt the wander action with the play hit action. So let's hit play and see if that works. So we shoot the characters and okay, that kind of broke them. Let's check the debugger now and see what's going on here. So it's in the wander action. Yes. So we can see that it doesn't actually remove the hit immediately. Yeah, okay, maybe what we can do is we only actually set the hit on the blackboard if we need it to be processed. So rather than checking the hit duration right here, we'll still have the play hit action exit out of the hit basically immediately if the knockback duration is 0, but it's still going to run the tick 1 time, which means it's going to be not in the wander state. So in the object blackboard setter, we'll only set the blackboard value if the hit data duration is greater than 0. So if hit data dot knockback duration is greater than 0.0, then we'll do that. And maybe this calls for a comment. So because the blackboard is going to be helping us control our logic here, and we only want the play hit data to interrupt the blackboard with the play hit action instead of the wander action, if the knockback duration is greater than 0, then I will set that there, that we only do that if the knockback duration is greater than 0.0. So that might not be the best long-term solution. There's probably a little bit more of an elegant way to write this, but I think that'll work for right now. So if I shoot a character, you can see now it doesn't interrupt the wander state at all because there's no knockback duration. So it stays in the wander state because the hit data was never set on the blackboard to interrupt it. Is hit condition never returns true. It's only failure. So now we need to actually give our projectiles that knockback stun. So let's check out the stats, the weapon stats. Okay, weapon stats basic. We want to add an extra property to that. So I'm going to edit the script. So we have weapon stats. Let's say at export var knockback. Yeah, sure. Let's do knockback force. And this is going to be a float because we don't know the direction yet. The direction is calculated based on the positions of when they are hitting each other. So this would be, I don't know, something like 100 pixels per second. And then at export var, the knockback duration is going to be maybe like 1/10 of a second. But you know what? I also noticed that kind of these properties are getting grouped together. So I'm going to go one step further in advance now, and I'm actually just going to create another data object for knockback. Yeah, so just bear with me here. Let's right-click on weapons, and we'll do a new script. So this will be a resource to define a knockback, and this will be knockback.gd. We'll create that, and then let's just pull these into that. So class name, knockback. Maybe we call it knockback stats, actually. Okay, and we name the script. So knockbackstats.gd for knockback stats. And then this will define the force and the duration. So the duration can be a float of 0.1 second. I think that's probably plenty, honestly. And And now we'll have weapon stats. So we can have @export var knockback stats. Okay, and if we check our weapon stats basic, we can see knockback is empty. So if we don't want a weapon to have a knockback, we can just leave this blank, and then we don't need to check the duration. We can just see if there is a knockback or not. We do want the basic weapon to have a knockback, so I'll create one. And we have the defaults of the force and the duration. This is also handy if we add more stuff to how this knockback should work. Okay, so now on our hit, so let's see, that would probably be in the hitbox 2D. We get the weapon stats damage. And we're going to use that to create the hit data. So let's see. The fourth parameter can be weapon stats.knockback. Okay, now that isn't a parameter inside of the hit data. So let's look up the hit data. And we'll have one variable here for the knockback, which is of type knockback stats. And the force and duration of an expected knockback on the Hurtboxes character. Okay, and we can remove the force and duration here. So as our extra parameter, we're going to have p knockback of type knockback stats. This can default to null. We don't have to set it. And then we remove these extra parameters here like that. And then we're going to have knockback equals p knockback. And we get rid of that bit. Okay, so basically we combined two properties into one new object. So we're reducing the number of parameters that this hit data has by kind of nesting the data objects. And also it gives us the ability to just check if the knockback is null or if there is one. And if there's not one, then we won't set the hit condition on the play hit action. So if we open up the Blackboard setter, now we can just check if the knockback exists. So if the knockback exists, then we can set the p hit data on the Blackboard. And maybe we do want to set the hit data on the Blackboard whether or not it has a knockback. So we'll just set that in there. So on the is hit condition, we do check if it's hit. We could also check here if the hit data has a knockback, but I think that might make sense to actually add an extra condition before we go to the play hit action. So let's create a new condition leaf here. Add a condition leaf. So I'll say hit has knockback condition, and then we'll create that as a script. So hit has knockback condition. I think we're putting everything in objects still, right? So we got our conditions here. I might actually group all these conditions into a folder soon. But for right now, I guess we'll do hit has knockback condition.gd. Okay, open that. Make sure it actually extends condition leaf. And then we'll create that. And we'll copy this tick function over like this. So I'll say if hit data.knockback. I guess we can actually eliminate the is hit condition from this sequence, and we'll just do if hit data and hit data.knockback. Now, the is hit condition could still be useful for other things, but here we're checking that there's a hit and it has a knockback. So really, I guess naming wise, this makes more sense. So we can actually just remove the hit condition from the tree. I'll leave this script in the project because that might be there for other things. So here we're checking if there's a hit data and the hit data has a knockback, we're going to return success. And I think that's good. So let's hit play and let's see if this works at all. So I hit this character and we get to the play hit action, which is good. But we have the hit data.knockback duration is greater than 0. So we're going to do hit data.knockback.duration. And then this is knockback.duration. And I think that's all we need to do to update that. So we have the knockback object on the hit data, and then we have the duration there. So let's shoot these characters again. And we have hit timer.play, non-existent function play on a hit timer. That's interesting. So the hit timer is null, supposedly. So the problem there is that it's called .start for a timer, not .play. So let's hit play one more time. We're going to shoot one of these characters. Okay, and he gets stunned. These characters get stunned. Okay, so let's see what the debugger says. Timer was not added to the scene tree. Either add it or set auto start to true. Okay, so I guess what we'll do on setting the timer is we'll add it as a child to our action leaf. Okay, let's shoot them again. Okay, and this time it seems to be playing. Timer was not added to the scene tree before run. Okay, so let's hit play again and shoot a character and see that timer was not added to the scene tree. We can see it's not, so maybe we need the ready function here as well. Function underscore ready, and we'll do add child, hit timer, set a breakpoint, hit play, and we'll make sure that works. Okay, so we have the hit timer, it's getting added now, and that would mean that when we hit a character, it should not throw a bug. But we can also see it never exits the state. So is playing getting set to false is what we need to exit the tick. But that's not really getting set there as well. I think maybe on ready doesn't work with set as I thought it did. So we can just bring this code down to here. And I believe on ready runs before the actual ready function. So we'll add the child and the hit timer connect down here. Okay, and we don't have a setter there. So the setter works really great for export properties, where you define something in the inspector and then it gets set on load. But I guess maybe for on ready, it's not as simple as that. So let's hit play and let's shoot a character. Okay, and now we can see they do get stunned for 1/10 of a second there. So that's good, that's what we're looking for. So at this point, we can see that our hit data is working, passing between objects because we have the 0.1 second stun on the character when they get hit. We haven't applied the knockback velocity yet, but since our hit data is set up for that, that should be pretty easy to set up in the next video. So next we will work on continuing with the hit state of our character. Now that the hit data is much more robust and set up, it should be easy to add in the knockback vector next. Okay, so even though we can hit our enemy and they do clearly go to the hit state where their movement stops, we do need to apply the actual knockback force vector for a period of time to our enemies so that they have a proper knockback. So the knockback direction should be in basically the direction that they got hit. So if the projectile comes from the right and it hits them on the left over here, then it should push them leftwards. Or at least that's how I want to try setting it up initially. So in our Hurtbox, we were already taking the hit data and passing that through the wasHit signal, which the Blackboard setter is using on wasHit to set the hit data into the Blackboard as well. So once it's in the Blackboard, we can just read it from playHit. And you can see on before run, we're already getting the value of the hit data and storing that inside of our script. So our hit data, if we right click here and check lookup symbol, has already been set up to have a knockback. So the knockback stats, as we covered in the previous videos, has a force and duration, and we might add more stuff to that. For instance, we would want a hit direction. But that doesn't really go in the resource for the knockback stats. That would be more of a runtime property that will include the knockback stats of the knockback itself, but it will also be set up with the runtime property taking the direction between the hitbox and the hurtbox and setting that as the knockback direction. So we're going to need another class that will just include the knockback stats inside of it. So if I open up the weapons folder, we have knockback stats down here. Let's right click on weapons and do a new script. I'll call it knockback. And this will be of type object. So it'll basically be a runtime object that will have a reference to the knockback stats. So let's create that and open that up. I'll give it the class name knockback. And we may want to define an initialize function. So I'll do function underscore init. And inside of here, we'll put in some parameters. So we're going to have p direction, which is going to be a vector 2, and then we'll have the p knockback stats, which is of type knockback stats. So when we bring in the knockback stats, we want to set the reference in here. So var knockback stats of type knockback stats, and we'll also save the direction. So var direction of type vector 2. And you know what, actually the stats here, I'm going to remove the knockback. That's kind of redundant. So it'll just be stats knockback stats. The class name's already knockback, so it's kind of implied knockback dot stats. So let's go down here to the init function and we'll say direction equals p direction. So just taking the parameters and saving that inside the object properties. And then we'll have stats equals p knockback stats. I'm okay with leaving the name here, p knockback stats here. Since this is only used in this function, we want to be very clear about what kind of class this is. I think that's okay, but you could also do p stats if you wanted to. Either works just fine. Okay, so we have our knockback instance, and we want to create that on hit. So if we open up our hit data script, you could just click over here to open it if it's not. So in our hitdata.gdscript, when we pass in the knockback stats, we want to calculate the direction between the hitbox and the hurtbox and use that for creating our knockback. So the knockback here is going to be type knockback. And then in order to create that, I'll say knockback equals knockback.new. And we need to give it the direction between the hitbox and the hurtbox and the knockback stats. So I'll say hit direction and then p knockback stats, or let's say p stats here. P stats. And then let's come up here to p knockback and make that p knockback stats. Okay. And then we don't need this line at the bottom. So to get the hit direction, we need to do hitbox dot position or global position dot direction to hurtbox dot global position. Okay, and that should pretty much be that. So in our init function, which we are requiring these to create, and it's an object, so it'll only ever be created by doing like hitData.new. We also create the knockback inside of here. So this means we need to update our other scripts possibly. Let's check the Blackboard setter. So we're setting the hit data, and then we come in here to the play hit action. Okay, so there's one more thing though. We only want there to really be a knockback if the knockback stats is valid for creating a knockback. So we'll say if p knockback stats, then we'll create the knockback. So basically, only if we pass in the knockback stats, we'll create a knockback from those stats. Otherwise, the knockback is still going to be null, which means that if we go into the hit has knockback condition, it's only going to succeed this if the knockback is created. So we go on from there to the play hit action, and we're going to have access to that knockback now. So rather than checking now hit data knockback duration, we'll just check if there is a knockback. Then we're going to play the animation and all of this. And what we'll do is we'll take the actor node and set its velocity to the knockback direction times the speed of the knockback, which will make a property up here for that. And then after run, we'll just set the movement to 0. And I think that should be good for now. Okay, so up here we want to say at export var knockback speed. And this can be a float. We'll set it to, let's say, 25.0 by default. So when we are running the play hit action, we do want to verify that the actor is a character body 2D. Movement would work pretty differently if we're using a rigid body 2D. So this action really only applies to characters. So let's get a reference to the character or the character body 2D. And we'll do that before run. So character equals p actor as character body 2D, and if character, or let's say if character equals null, push error. So we'll get the character reference from the actor. If that doesn't show up, then we know it's not a character body 2D, which is problematic because this knockback depends on it being a character body 2D. So that would be an issue. And so basically after that, we assume that the character is a character body 2D. And that means that we can go down here and say character.velocity equals, okay, so now we need to get the hit data. So hit data.knockback.direction. And now that I think about it, in the knockback stats, there's a force which we can use here for the velocity. So instead of knockback speed up here, why don't we make it more like knockback multiplier? Knockback multiplier. And this will be 1.0 by default. We can make it a export range, let's say 0, 1, 0.02. And that can be or greater. So we don't want it to be less than 0, or do we? I guess I could see a situation where you might actually make them knockback negative. So I'll remove the or greater there. We click on play hit action and we can see our knockback multiply. kind of defaults to or greater. So we can't actually set negative value there unless we do this. Hide slider or less. Maybe we try hide slider. Okay, and we can't really control that. So I'll just do export var. Yeah, okay. That means that you can do like negative 0.2 in there if you want to reverse the direction of the knockback, which would be pretty weird, but it's an option. So for our character velocity, we get the knockback direction, and then we want to multiply that by the force. But that would apply to every instance of a knockback. So I think actually doing a little calculation like this would make more sense on the knockback script. So I'll go into knockback, and then let's have a function called getForceVector, which is going to return a vector 2. And this will have var force vector, which is going to be equal to the direction times stats dot force. And then we're going to return that. Okay, so now we never need to manually make that calculation again. We can just take getForceVector in the play hit action, and we do it like this. HitData.knockback.getForceVector. And then we times that by our knockback multiplier. Okay, so basically in this component, we get the direction times the force, but we might want to be able to control how fast the knockback is on a character by character basis. So we also add in the knockback multiplier. So if you want to, say, have like a really sturdy character that reduces knockback by 90%, you would just take the knockback multiplier and make it 0.1, and now the character is 90% resistant to knockback. Yeah, entirely possible that you might move this out to like a character stats script. And maybe that does make some sense actually, because it is kind of a stat of the character. And there might be more than one action where you play the knockback. So let me think about that. I guess we can have a reference to the character stats. So character stats, or you know what, knockback can be an object stats. So we have our object stats reference, the resource from previous videos. I'll move into here and let's call it knockback multiplier. Yep. Okay, so now in the play hit action, we'll do object stats.knockback multiplier. Okay, so now we can just reuse the knockback multiplier just by referencing the object stats. If we go into the play hit action, we can quick load our invader stats, which is going to have the knockback multiplier inside of here. So we can customize how resistant the invader is to knockbacks just by setting this. And this property will exist on all object stats, which I would assume you would have one per interactable object in the game. Okay, so that sets our initial velocity. We want to stop it after the run, so that will be just character.velocity equals vector2.0, and we just set that after run. So let's hit play and see if this works at all yet. So hit this guy. Let's see, the hit timer.start, knockback.duration. Okay, so it's now knockback.stats.duration. Okay, and let's rerun the scene. I'll hit a guy. And I'm not sure if that is actually going or not. So we could do prints character.velocity right here. I'll also set a breakpoint. We'll hit play and see if that's anything that's not 0. Okay, so we have the character, and then we have the velocity on that, which is actually hard to read from the inspector. So I will hit play and we'll see what that was set to. Down here we can see that there is a force, but it's not exactly moving it that fast. So we probably need to bump up the default force on the projectile. So if we go into the hitbox 2D, we have the weapon stats. So we want to go into that. So we have our knockback stats, which I might actually rename knockback stats now because there is a knockback class. So we do have to be very specific there now. And then in knockback stats, we have the force. I'll just default that to 300. Now I know the reference to the knockback stats is going to break somewhere. So I'll hit play and let's see where that is. So here we're looking for weapon stats stat knockback, but what we actually want is knockback stats. So we hit play again. Let's shoot a guy. Okay, so what happened there? they never exit the state. Okay, we can also see that we're using a reference to the weapon damage and the knockback stats here, but it would probably be better if we just did weapon stats, save ourselves a parameter. Let's jump into hit data. Inside of hit data, I'm gonna make it just weapon stats. Okay, so P weapon stats. So the amount will be equal to P weapon stats dot damage, and the knockback is going to be equal to P weapon stats dot knockback stats. And then for here, we're going to check P weapon stats dot knockback stats. And down here, we'll do kind of the same thing, P weapon stats dot knockback stats for creating the knockback from the weapon. And yeah, all of that reduces us a parameter because the weapon will already have the knockback and the damage inside of it. So any other parameters we need from the weapon stats, we can just pull them in here like that. Okay, so if I set a breakpoint here and I hit play, we'll see what the issue is. So we come down in here to the weapon stats of the projectile, and we can see there's no knockback stats here. So that means that the knockback's not going to be created. But we can see that it's also problematic because our character gets hit, but the hit data still persists on the character. So because of that, it never actually goes to the wander state again. So we do need to fix that. Okay, and I guess what we need to do for that is if there's no knockback, then we just need to remove the hit data immediately. So let's see, if is playing is false. Let's see what's going on here. So I'm going to set one for here. If there's no knockback, it should do is playing as false, which should make after run go here, which removes the hit data. But let's see what's happening. So I'll shoot, and we never get there. That's probably because on the hit has knockback condition, we that we only pass if the hit data has a knockback, but we never remove it otherwise. So I'm thinking it's probably better to just check the hit condition like we originally did and not have this hit has knockback condition unless we're going to also remove the hit. But if we're doing that, it doesn't make much sense as a condition. So let's find the hit condition, and I'll add that in. Right click is hit condition. That'll be the top. And then hit has knockback, we'll remove that both from the project and from here, because that no longer makes sense. I'll check the is hit condition. All we're doing is checking that there's hit data. And then in the play hit action, we're still removing the hit data, regardless of whether there's a knockback or not. So let's hit play, we shoot. Okay, now we actually do get to the before run. We'll see that we have no knockback, so therefore we get to is playing as false, which means that the blackboard is going to remove the hit data from the character, and as a result, he should be able to move again. Okay, so yeah, bugs like that you've got to watch out for. Okay, now that that's working, we can set the weapon stats. So weapon stats basic, we wanted to recreate the knockback stats, so just new knockback stats. We'll use the defaults, 0.1 duration, 300 force. Okay, so if we hit play and we shoot a few times, then we'll see there's a little bit of a knockback, but it kind of doesn't work as consistently as you might think. I believe that's due to the physics of the grounded motion mode character body 2D. So one thing we could do is uncheck block on wall, which would allow it to slide on walls like the floor. And if I shoot now, that looks a little bit more consistent. Another thing we can just do is check if when we hit the character and we're creating the knockback direction, if the character's on the ground, and maybe in grounded mode too. And then if that's the case, then we just ignore the Y component and just do a left-right knockback. So in our hit data, maybe we do need the reference to the physics object. So I will make that an extra parameter here. So P hit. So we could put up here maybe P game object, which is going to be a physics body 2D, or game body, object body, or we could just say physics body. Yep. Okay, that makes more sense. Okay, so the body is going to be equal to the P physics body, and we'll put that in here. So we need the main physics body of the object that was hit. We're passing that in there so that we can check if it's on the ground. For creating the knockback. So I suppose we want to put that physics body into the knockback as well. That way we can have the knockback calculate whether it should be pushing left or right internally, and then we'll use that when we get the force vector back. So let's pass in the body, the hit direction, and the knockback stats. Yep, okay, and let's go into knockback. So I have the P physics body, which is a physics body 2D. We'll save a reference to the hit body. Okay, so just like before, we'll put the body in there. Body equals P physics body. That should really be first. And we should be having a force vector property, I think, too. So we'll say var force vector, vector 2, and we'll calculate that. So let's rename this to be calculate force vector. We'll call that on init. So force vector equals calculate force vector. Okay, and then now, basically after having this stuff set up, we already have this. We don't need to calculate the force vector from outside of the knockback. We just need to read from it. And then down here, we can adjust for the fact that the physics body is on the ground. Okay, so if body dot is on ground, is that going to work? Okay, we'll say if body is character body 2D and body is on ground. So if the body is a character body 2D and body dot is on floor, then we're going to adjust the force vector by removing the y component of it. So the force vector dot y is going to be equal to 0. We'll try that for now. Another option would be to change the direction to only have left, right, but we can see how that works. So let's hit play. Of course, we didn't add the physics body for the hitbox. So the hurtbox should have a reference to the hittable object. So let's look that up. Okay, in the hurtbox, let's do export var body, character body 2D. And we should assign that in the invader. So if we go down to Hurtbox, we assign the reference to the invader character body 2D. So we can pass that into our knockback scripts. Okay, so the hitbox is going to get the hurtbox.body. It's going to get itself. It's going to get the hurtbox itself. Oh, well, you know what? The hurtbox has a reference to the body, so we actually don't need that parameter. Let's remove that. Let's jump into hit data. Right click, look up symbol. Since the hurtbox has a reference to the body, we can just remove this. And then we can just do p hurtbox.body down here. And we don't need to reference that. We don't need this as well. Okay, so we're just doing the hitbox and the hurtbox. The hurtbox already has the body and the weapon stats. Okay, so now we just need to make sure whenever you use a hurtbox that you do reference the body, which in this case is the invader, the root node of our invader scene. Okay, we hit play. Let's see how it works now, if at all. Yeah, so there's no get force vector now. It's calculate force vector. So we want to just do knockback dot force vector because we calculate it on init, so there's no need. And then we can hit play. We shoot, and we should get a knockback on both. We can see that the Y component is set to 0. So very much the knockback depends on if we're hitting straight on or not. So I don't think that's quite what we want. This simple way in knockback would just be to make the direction left or right if they're on the ground. So we could say var adjusted direction equals direction. And then let's move this up here. So if the character is body 2D and on the floor, then we're going to make the adjusted direction just left or right. Then we're just going to make the adjusted direction left or right. So we'll get the sign of the direction. Direction.x.sign. So far, sign x is equal to the sign of the direction.x. If sign x is greater than 0. Basically, it's 1. And we could say equals 1. Then we're moving it to the right. So adjusted direction equals vector2 dot right. Else if sign x equals -1, then the adjusted direction is going to be vector2 dot left. And then the third case is that the direction x is 0, so we'll just keep it as 0, so we don't need to do anything there. So now we use the adjusted direction instead of the original direction. I know a lot of extra steps here. So one option you can go with is that you just have all your characters be rigid body 2Ds in your game. If you just want to just directly apply a force vector and you don't need to do any of these manual movement adjustments, then that is one advantage of doing rigid body 2Ds. Okay, so if we hit play now, we can see we hit the characters. They're going to get the full knockback, but the direction is still not quite right. And I think that could just be that at the moment of calculation, the hurtbox and hitbox positions are not quite what we would expect them to be. So what I might do is calculate the direction from the character body 2D, the one that we're hitting. Even though we hit the hurtbox, the direction would be based on where the physics body 2D is. So let's go to, where would it be? In Hitbox, I think. Okay, and we create the hit data. So what we might want is getting the hurtbox.body.global position. It might make more sense. I mean, it is the physics body after all, so that's really the position that matters. So let's give it a shot. And I'll fire a couple shots here. So far, so good. Yeah, all right. That might be more what we want. That's looking good. So given that we kind of fixed that body issue, maybe we don't need to recalculate this here. So maybe it was just because of the bad positioning on the calculations. I will comment this out for now because that could still be useful, but let's see how this goes. I'll fire, we shoot again down here. And yeah, the thing is that based on the direction, it might be mostly going towards the floor still. We can see in the output the direction of these vectors. So you can see that like when it hits from above, we get only 8 force magnitude to the left right, but 300 from up down. And because it's hitting the ground or colliding with the ground, it barely moves at all. That's why it's like that when it's on the ground. In that case, maybe it is best to have this here so that a knockback on the ground just slides against the ground every time and it's consistent. So now it's like this. The only thing we kind of got to change is that the knockback is too much, I would say. So if we go to weapon stats, knockback stats, let's change this default to 100. I'll hit play because that's going to update the basic projectile. Oh, I guess it didn't actually. Let's open up weapon stats basic and, oh, I should. I'll set that to 100. Let's reboot the project. So I'll hit play again. Let's shoot here. Okay, is the knockback a little better? I would say it's like still too much. Oh, I see. For some reason that is defaulting to 300. Do I have 2 copies of weapon set basics? No, I don't. Okay, it was just set to a higher value for some reason. Okay, so let's shoot. Yep, we get that short knockback. It's very little though, so I might actually increase the duration. I might want to increase the default duration as well too. So we make it 0.25 at 100 force units per second or something like that. So we have a hits. So in weapon sets basic, let's set that to the value we want to use. But I don't think it's actually using the duration properly. Let me set that to 1 second and then we'll hit play. We'll try again. So we have our, okay, it is actually using the duration. So 0.2 or 0.25 seconds. We hit them. So I kind of see now, when we hit them, it's like they are kind of wandering the other direction. So it's actually not that clear that the knockback is working, but if you look at the animation frames, it is playing the knockback for that 0.25 seconds. And it is going the right direction that we would expect now. So the knockback for the character body 2Ds is working. So I think what we need to do next is give more of a visual effect to when the characters are knocked back. Just in case the speed is too consistent with the base movement speed, it's a little hard to tell. So for instance, we could just turn the character red or flashing red with a shader when the character gets hit. So that's kind of what we'll work on in the next video, kind of getting the knockback hits to kind of wrap themselves up here. Okay, so in this part, we mostly need to take the invaders and make it so that when they get hit, it's not just a knockback, but also a visual indicator, probably making them flash red or something like that, to make the knockback more obvious. But before that, there are a couple minor flaws. So for instance, in weapon stats basic, if I was to take the knockback stats and make this none, then there would be no knockback like before, right? So I had the condition to check if the hit had a knockback, which was working before because that would mean that it would never do the play hit action tick if there was no knockback, which would mean that it wouldn't stop the character from moving without a knockback. But since I switched the condition back, if we hit, you'll see that just for a single frame, it does kind of stop their movement, which is an issue. So what I think I want to try doing is on play hit action. If there is no knockback, then I don't want to continue on to the tick. I actually want to interrupt with the actor and the blackboard. So let's do p actor and p blackboard. We'll create that function and then we'll exit immediately. So function interrupt, which is p actor, which is going to be a node, and then the p blackboard, which is a blackboard, of course. So what we can just do is return success. So if we do interrupt there, we return success and hopefully it will stop immediately. It does seem to still have like a little bit of a moment there where it's not actually continuing the movement. So if we check wander action, after wander, we set the character velocity to 0. We could remove that. And then now if we shoot, then okay, they're still going to have the same velocity until they're told otherwise. So maybe what we do is we check if the hit data has a knockback and then we set it to 0 here. Yeah, I mean that will work, I think. So if hit data dot knockback, then we'll set the character velocity to 0. Or if the character's not alive, I guess. So, or the character's not alive. Okay, I think that should work okay. So let's hit play. Okay, our hit data, well, of course the hit data also has to be valid. So I guess we can separate these into different conditions. So if the character is not alive, we're going to return false, of course. And then we can check the hit data. So if the hit is valid and the hit data dot knockback exists, then we'll also set it to 0 and return failure. But we only need to check the hit data knockback if we're setting the velocity to 0. So if the hit is valid, we'll return failure, but if it also has a knockback, we'll set the character velocity to 0. So whenever we create a knockback, we could just set the velocity to 0 inside of that script, but I wonder if that would be nested too much to make sense. So like in hit data dot knockback, if we check the knockback script, it could just be like on init, we take the body and we set its velocity to 0 if the knockback stats has a duration that's greater than 0. Yeah, maybe that would make sense. So our play death action should already be setting the velocity to 0. So we should be saying like actor.velocity equals vector2.0 here. So we don't need to do that on exiting the wander action. So we can kind of just return this to where it was before. So is alive or there is valid hit data, and then we'll return failure. Okay, so just like that. And so for the knockback velocity, we'll set the character's movement to 0. You know what? Maybe that makes more sense of doing on the play hit condition. So if there's a knockback, well, the character velocity is getting set to the knockback, and if not, then we don't actually want to change it. So actually, maybe we don't need to do that at all. So let's hit play and shoot. Okay, so our shots don't have a knockback right now, so they're working as intended, right? So if we hit play, it looks like they're completely ignoring the shots, which is what we want because the weapon stat basic has no knockback. So if we add in knockback stats now, and we hit play, then they're going to set the velocity to the knockback speed. All right. Yeah, okay, that's looking more correct now. Okay, so regarding the hit shader, I kind of pre-wrote this for the video. We'll try to cover everything here as I put it back in. But first we have to create a way to actually set the shader onto the sprite when the character gets hit. So I think creating a new action in the hit sequence would make sense for that. we could create a set shader action, and we need to target the character sprite 2D. So where you set a shader is going to be on the material section in here. So we would like have new shader material. So the default material here is just going to be nothing. So let's create a new action on the hit sequence. I'm going to add a child node. We're going to look for a action leaf. I'm going to move this above play hit action because we want it to play before the play hit action. And I'm going to call this the set shader action. Let's right click on it. I'll extend the script and we will set this in objects. So objects slash set underscore shader underscore action. We'll create that action leaf script. So the class name set shader action does exactly what you would expect. So we need a reference to the sprite. I'll say at export var sprite, which is going to be a sprite 2D. Does that work with animated sprites? Hold on. Assign. Oh, it does not. Okay, interesting. So we can say animated sprite 2D. Then if we assign that to the character sprite 2D, let's see, animated sprite. So actually, let me see. Is there a parent class for this? I think we could just use canvas item, which should have a material. Okay. So let's do canvas item, and I'll just call it canvas item. We assign the character sprite 2D. So this should also work with regular sprites now because it's using a parent class. And what we want to do is we want to set a material on that. So we'll do export var. Let's see, what kind of class is this? Is it just material? It's going to be of type, I guess we will try material, and we will see if that is the same thing. Okay, if you click on set shader action, we can click here. That doesn't seem quite right. So there should only be a couple here. Let's see what the parent class of shader material is. Shader material is of type material. Okay, so I think we want specifically shader material then. So shader material. Now we can click over here. What do we want to set as the shader material? We want a new shader material. We open this up and we need to create a shader for it. So you do new shader on this menu. So let's say hit shader. Or I guess just hit.gd shader works. And we'll put that in objects. I'll create a shader folder. Actually, let's create it in the root of the project. I think this maybe deserves its own category. So I'll create a shaders folder. And we have the hit shader. So we're going to open and save that. All right. Now we can click here and we get the editor window for shader. Okay, so I'm going to start by copy and pasting all of this in. Then we'll kind of talk about it for a little bit. We can see the shader going over there on the right. So just flashing between the base color and the red color. We can talk a bit about it. I'm going to hide that for right now because that is a little annoying. So I do want to caveat this section by saying I'm really new to shaders as well. So I'm just kind of experimenting probably almost as much as you guys are. But let's try to go through what I have for the setups. If you want to create a variable that you can set in the inspector for a shader, then you call it a uniform and then the type. So here it's a float. I have 2 timescale, so how fast to animate the blinking, defaulting this to 20. And then uniform float GB ceiling. So in terms of the green and blue color, how much do we want that to be able to reach? So when it's completely red, I believe, how much green and blue do we want inside of that from the base color when we're multiplying that for each individual pixel on the shader? Okay, so the void vertex, called for every vertex the material is on, not using that. Instead, we are calling the shader functions on fragment, which adjusts for every pixel on the 2D image, basically. So in order to basically loop through the animation, in a sense, I'm calling a sine wave function on the time times the time scale. So the more the time scale goes up, the faster this is going to animate, I believe. And then I get reference to the current color of the pixel in question. And I'm changing the color of the pixel in question. So this takes a vector 4, which is RGB alpha. So red, green, blue, and alpha. So the red value is always being set to 1.0. And then the green and blue value is going to be based on the original green and blue value of the image. and then we're multiplying that by where it's at in the time cycle. So remember, this is a wave, so it's going to fluctuate like up and down, up and down, up and down, which means we're going to have the green and blue showing, and then it's not going to show. And when it's not showing, then we get all red. And this is being multiplied by the ceiling value to basically limit how high it can go. We keep the original alpha of each pixel. So that's basically it. And what we get as a result, if I open up the shader material, it looks kind of like this. I think though, maybe rather than having a 100% red color, I might actually want it to be the original red color. So I could do text color.r, pull the original red value in, that'll always be there. So then it goes basically between red and kind of a pinkish red whenever it cycles. So basically, what we're going to do for the set shader action is when the shader enters, we're going to set the shader on the canvas item. So if we do function before, what's it called? Let's look up action leaf and then leaf and behave node. It's before run. So we can copy this into the set shader action like that. And all we need to do is say canvas item.material is equal to material. And when I exit the play hit action to finish the hit sequence, I actually want to also set the shader action. So I'm going to copy and paste that down below. I could say set shader action remove or remove set shader action. And now if we click on this remove, we can just remove the shader material here. So it's going to set the canvas item material to null. And that should just remove the shader. So if this is working correctly, then we should see the shader while the play hit action is going. And that is basically the gist there. So let's shoot. And as you can see, we get the hit shader to actually play on our enemies. And it's very obvious when they get hit now. I might want to control the knockback a little bit more. Maybe it needs to be kind of a progressive build up to the speed. So maybe it should be more like an acceleration. So if I hit play now and we shoot our enemies, we can see that they are going to flash that red when they get hit. So it's very obvious when they get hit now. So to test a little bit easier, we can set the damage to 1, so all of the characters will survive more than one hit. We hit play, and let's shoot our enemies a bit. Kind of bully them over towards the edge of the screen. As soon as we let off with the projectiles, they'll, resume their wander state. That's kind of what we expect. And if we keep shooting, we can kind of bully them into a corner. So if we wanted to, we could herd this guy over here. Okay. Yep. And mostly seems to be working. The knockback doesn't always actually go the right direction. So that's a bit of an issue. I wonder if that's just because of the position of the Hurtbox and the physics body. So for the Hurtbox shape, we can give it maybe another capsule shape, and I'll try making this just like a pixel bigger. So let's hit play, and maybe this will help with the Hurtbox issues a little bit. So when the character knocks back to the opposite direction we would expect, I think the code is executing as written. But basically the spawn position of this projectile is going to determine the knockback direction. So if I go right on top of them, then that might mean, like right here, that the projectile goes over here, but the character's over here, so it knocks it back to the left. That may or may not be intended behavior. So if that's something that bothers you, you can just change your knockback direction formula, and that should clear that up. Or if you like it this way, you can leave it alone. But it's not really problematic, it's just kind of how it's coded. So anyway, the hit shader seems to be working. And we could actually extend the knockback vector a little bit. So let's take the duration and make it 1 second and hit play. And we'll see if this actually gives it time to loop through. Okay, yeah, we can see the flashing definitely is happening there. It might not be obvious enough, so you could change the parameters of the shader. So if we go to shader, shader material, shader parameters are down here. So maybe we make the GB ceiling like 0.25, or then depending on how that's set up, that's going to make it more or less obvious. Yeah, but anyway, the flashing is definitely there. So that's pretty much, in a nutshell, about all there is to do about doing basic knockback on a character body So anyway, the main component of this video, getting the shader to do its flashing red hit indicator, definitely working there. Knockback could definitely use some tweaking a little bit, but I think that we are in a good state for the end of this video. So at this point, our enemies are basically working. They have their hit knockback, applying the shader, they have their death state, and they have their wander whenever they aren't doing a hit or a death. But they have no ability to really interact with the player. And in a lot of platformers, when a character would run into your player, they would deal damage to them. So we'll try to implement that in this tutorial. Also, one thing that I do think we should make a change on, if we go into the debugger for the behave tree, is that you can see that whenever the wander action is done, the selector composite restarts and it checks the death sequence and the hit sequence. But also in our code, we just check in here to see if we should interrupt the tick by returning failure so that these can go back. Basically, if the character's not alive or if there's an active hit on the character, then it would go here anyway. So we don't really need to be returning success when the timer times out. So what we could actually do is remove the return success so that this will never actually finish. It'll only be interrupted with a failure, or it will return running. So if we just do that, return running, we get rid of the is wandering variable, kind of like this, because if the character's in the wander action, he's always wandering. Then on timer timeout, we can just randomize the wandering, and then we restart the timer. So timer.start, okay, and that's pretty much it. So if we hit play now, we can, let's go to the debugger, we'll click on a character, and now you'll see that the wander action never actually leaves until we hit them and they leave their state. So that's going to just make the behave tree a little bit less annoying, where every half second it tries to check death sequence and hit sequence again. When that's really not needed, we can just keep the character in the wander action until something else interrupts it. So that aside, back to the player, there are a couple minor issues I'd kind of like to resolve. So one being able to jump for the character. You need to go to the, the player scene. Make sure that can ground jump is checked on player stats so that your character can jump again. For the last few tutorials, I had it off. It must have reset back to the default of off when I moved it to the character stats script, which this is a child of. So just checking that should allow jump to work again. And also on the projectile, I'm bumping up the gravity scale from 0.2 to 0.3. That'll just make it so that the projectiles fall to the ground a little bit faster. So if they're too floaty, I don't super like it. I do like them to be kind of floaty. It's up to you, basically, what you want the gravity scale to be. If you have it at 1.0, then they'll fall like the player does. So that's one of the handy things about a rigid body 2D in Godot. You can just tweak the settings here and completely change the physics on how an object moves, which is powerful, and that you can just move a few sliders and change how things work, but also kind of tricky to debug because it's a little bit harder to know precisely how it's going to work. Just by changing the gravity scale, you don't know, for instance, will this be able to shoot up an edge? It shouldn't have been able to because the gravity scale is different now, for instance. Okay, so we want the player to be able to be hit. There are a couple ways you can do that. One would be to use a finite state machine. If you go into the asset library and you search state machine, there's a bunch of examples here that you can use. And then when your character is basically able to move and jump on the ground, you can make a ground state. When you want them to take damage and remove the ability for them to be hit, you can put them in a hit state and all of that. So we're going to do something similar, but because in our project we're already using behave tree as a behavior tree for controlling our characters. Often this would be used more for AI, but I want to just take a crack at using it for our main character as well. So the idea will be that we do use a behave tree, and we'll probably use like play death action and play hit action, or these whole sequences really. But then rather than a wander AI, it'll be more like, okay, the character's in this ground state, and now we turn over control to the input devices like your keyboard or controller so that you move your player on the screen. So pretty similar to a finite state machine in some ways, and maybe a little bit overkill, but I want to have fun with it. So we will do a player behave tree. So in the player, let's go to the root and let's look for a behave tree. So the actor node path, I think this just defaults to the parent, so we probably don't need it, but let's make it like the invader. So we have a separate blackboard, so we'll do that too, in case we need it. So blackboard, let's assign that in the inspector of the behave tree, like that. The actor is the player, okay, so I guess no need to reassign that there. Tick rate 1.0. So I guess the idea here is if you needed to speed up an AI or a character, you could increase this or decrease it. I assume that's what that does anyway. We're going to process on physics. That's good because we're mostly moving the player. And now we just need to set up a tree. So I'm actually going to take all of this down to that and just copy that and paste it into the player. So the isDead condition, whether it's a enemy or a player, it's basically going to be the same. We just want to play the death animation when the character dies, and we just want the character to be hit, maybe apply the shader whenever the player gets hit as well. We could change the shader that we want to use here, so it doesn't have to be the same between enemies. But then the wander action, that's where things are going to differ. So basically, whether the character's in the ground or the air, we might change its controls a little bit. But then down here, basically, we are going to turn over control to the player or the player input. So we might even have like a ground player input action rather than the player input script that's always on over here. So let's actually create that ground player input. I'll right click on child node. Let's expand over here, leaf action leaves. We'll just have a standard action leaf here initially. I'm going to rename this to ground input action. And then let's extend the script. So it's going to be ground input action on player, create. Okay, and if I take a look at behave node, it extends nodes so it can have all the same input. So it can have all the same features as a regular Godot node. So if I want to, I can go into player input and I can take this unhandled input and we can put this into the ground input action. And then we just limit it so that the ground input actions are only going to be activated while the ground input action state is active. Let's start by just copy and pasting this over. I'll give it the class name ground input action, which is going to give the player controls for the ground state input. So the character's on the ground, this is what it can do on the ground when everything else is freed up. Okay, we don't need the wander action from the behave tree, that's for enemies. So just to get the function names, I'm going to look at the play hit action for a second. So we're going to have before run or active run to enable the ground input, and then we're going to have tick to set the movement direction while we're on the ground. So let's get that over here. Basically, function process is going to be replaced by function tick. Yeah, so it needs to return true or false. So this is just going to return running. And then we need the before and after. So the before run, just going to return void. I'll pass that for now. Let's copy this. We'll have the after run. Okay, and on before run, we're going to activate. And then after run, we're going to disable. So var active equals false. Before run, active equals true. After run, active equals false. And then before we do any unhandled input, we're going to check if not active, return. Okay, so that basically means that jumping and doing try shoot is not going to work if this state is not active. So we'll try with that for right now. This is probably going to need a little bit of tweaking. But let's actually remove the original player input for now. And I'll try hitting play and we'll see if this works at all. So player direction. That would need a reference to the actor. So this would be actually actor, actor.direction. So we actually need the node now. I think on before run, we could just get reference to the character. So player, it's going to be a player, yep. And then we'll say before run, player equals actor as player. Okay, we'll get rid of that little underscore there because we are actually using it. And then we'll say player.direction down here equals this. Okay, and then we don't need to export for the player because we're already getting that from the actor. Okay, now let's click on the ground input action. We'll assign the shooter and the actions, player input actions from the project. Let's try hitting play and let's see if this works. Okay, so the character is able to move, the character is able to shoot, and let's make sure that we're actually in that state. So If we look at the player's tree, you can see that ground input actions is running, and basically it works exactly like it was before. Okay, now for our player, to actually take damage, play a death sequence and play a hit sequence, we're going to need a setup similar to the invader, where we have a health component and we also have a object blackboard setter. So I'm going to copy and paste those over to player, health component for the player, and object blackboard setter. I'm going to copy that over to the blackboard down here. And let's move the blackboard above the behave tree. Now we can click on object blackboard setter, assign the blackboard, assign the health component, and we need a hurt box. If we click on the health of the player, well, we'll see this is using invader stats. We want to change that to player stats. So you'll be able to customize how much health a player has here if you need to. And then I'll be using that instead. So we need a hurt box for the player. So let's right click on the player. I'll add a hurt box. And then let's right click on Hurtbox and add a collision shape 2D. Let's make it something like a small sphere, maybe a circle shape or a capsule shape. Let's make sure that the player is in the run state so we can see where we're putting the collision shape, and I'll hit W to move it. Let's put it up there. I'll hit Q to grab these handles at the edge and shrink it down. So maybe I'll make it a little smaller than the collision shape for right now, I guess. And I'll rename this to be Hurt Shape 2D. If we click on the Hurt box, let's assign the health and the body, which is the player. And now in the object blackboard setter, we want to assign the Hurt box. Okay, now for the player to get hit by the enemy walking into the player, we would need the invader to have a hitbox that is always on. So let's right click on invader and I'll add a hitbox 2D. Let's move that under facing, I suppose, just in case, so that it's always facing the right direction. And let's see, weapon stats. We do need to set like how much damage it should do with that. So I can do new weapon stats, and let's save that as objects, characters, enemies, and we'll say invader collision underscore stats.tres. Inside of that, 10 damage, and maybe we do want a knockback, so I say new knockback stats. I'll say 50 force. Why not? Okay, and then we can close that. So our hitbox needs a collision shape, so add in a collision shape 2D. For the collision shape, maybe we want like a box in it to only hit whatever it's facing. So by default, we're facing the right. Sure, we'll try that. So new rectangular shape. Let's move it to the right side, and I'll shrink it down, hit Q to go to basically handle selection mode. And let's make it kind of favoring the player somewhat. So right around there, we could even make it like a capsule shape. So I'll change that to a capsule shape and shrink it down like this. Q to go there. Okay, now I think that matches like the curve of the character a little bit better. If I move it over just a tad, then I think that's pretty good now. I could shrink it a little bit. Maybe I put it there and shrink it. Okay, sure. We'll go with that. Let's rename this to be collision hitbox shape 2D. Okay, now if you hover over it, it's got a really obvious name. Okay, and we have the hitbox. So this is going to deal 10 damage with a 50 knockback whenever it collides with something that can hit. So we want to expand collision and make sure that this is going to mask out for the player only. So this will only hit the player, and it doesn't really need to have a ground. It doesn't really need to have its own layer because this is more of a look only box. In fact, you could even turn monitorable off if you want, because with a hitbox, nothing's looking for the hitbox. The hitbox is looking for hurt boxes, but it's not really necessary to toggle it off like that, though you could. It should be fine. So let's hit play, and let's see if the player can get hit. I'll walk into an enemy. Okay, nothing happens. All right, so let's find out why. First, I'm going to check the player, and we'll check the hurt box. Let's make sure that the collision here is on player layer. It's not, so we need to make sure the hurt box is on the player layer. Doesn't need a mask, so it should just be player 2. So let's try that again. I'll run into an enemy. Okay, we don't get hit. So I'll try setting a couple breakpoints. In Hurtbox, let's set one here for when we get hit, and then in Invader Hitbox, let's go in here, and let's see, Hurtbox.hittable. Let's set one here. So basically, if it passes being able to get hit, it should create a hit data. We'll see if it gets there at all. Okay, and we did hit a breakpoint, so let's see what happened. The Hurtbox, if we open this up, should be the player Hurtbox 2D. Okay, that's good. That's what we expect. Then we go down to the next line. We're going to get hit. So hit actually does happen, which is going to emit was hit. Okay, and we have the old health. The actual change was 10. So if we look at the health component, we should see 90 health. So the player's taking damage. It's still alive, so that's good. It's just that the behave tree is not actually triggering properly. Okay. So if we close and get rid of all the breakpoints, I think I know what's up. If we check the player, we have the ground input action. As we just set it up, it always runs and there's no interrupt for this. In the invader, what we did is our wander action, we just check for a is alive or is instance valid hit data, and then we return failure. But there might be other conditions we add into our code where we would want to interrupt, and that would mean that we'd have to keep editing these scripts every single time. And that might not be optimal. So if we go to player and ground input action, I'm thinking that maybe what we need to do is add in the interrupt function. So if we do interrupt on a P actor, or really I'm going to underscore that because we're not going to use it for anything. So underscore P underscore actor, and then underscore P blackboard. Type blackboard. This returns void. So the only thing we're going to do is set active to false. And if the tick occurs, but if not active, then we're going to return failure, let's say. It could also be success, but I think failure makes more sense since we're trying to break out of it and stop using it. So that means we need something else that's going to set the interrupt to occur. And as you can see, the interrupt is going to require us to do a actor and a blackboard. So we could just call this from any script and then set these to false, but maybe we do want to pass those in. So to actually trigger the interrupt on our ground input action, we may want a secondary script that can target a action and call the interrupt on it. So there's probably a handful of ways you could do that. One could be to have a parallel action running in addition to this, which can just basically, in response to hit being set, we trigger the interrupt on the ground action, and then we can separate the code for the interrupt from the condition itself and reuse that for other things. So I'll right click on the selected composite, add child node, and let's do a simple parallel composite. I'll put the ground input action there. And then let's right click, add another action leaf. So basically with a parallel, these two will run at the same time. And I want to say interrupt on hit action. Let's extend that script. I'll put it into, let's just say objects, open, create, give it the class name interrupt on hit action. I could put the interrupt code on the tick function of an action leaf so that every time it ticks, we just check if the hit data exists. But that's quite a lot of checks to do that on every single physics frame. So what I might do is just say before, or let's see, function before whatever it's called. Hold on. Play hit had after run, so it's before run. Okay. So before run, we're gonna get the actor, which is a node, and the blackboard, which is a blackboard. This is gonna return void. And we want to get a reference to, let's say, the hitbox. For our game, at least at the moment, there's only going to be one hitbox. So, but you know what? Maybe it makes sense to actually add an array of hitboxes. Maybe you have an enemy that is going to have 6 hitboxes, and you want any of them to interrupt an action. So we could say at export var hitboxes, which is going to be an array of hit. Hurtboxes, Hurtbox 2D, an array of Hurtbox 2D. So Hurtboxes, and before the run, we want to connect to all of their signals. So for Hurtbox and Hurtboxes, we're going to take Hurtbox.wasHit. We're going to connect to it with its onWasHit. And then function after run, is that what it was? Hold on, play hit action before run, after run. Yeah, okay. Then we're basically going to copy this up there. We're going to disconnect from the signals. So we can actually just copy this over here, make that a disconnect. Okay, now we need to create the function onWasHit, which is going to have hit data, if I remember right. And what we want to do is we want to interrupt the target node. So at export var target action, we're going to get an action leaf. And on that, we're going to pass in the actor and the blackboard. So target action.interrupt, and we need the actor and the blackboard. I'll get reference to those before run. So var actor, var blackboard, actor equals p actor, and blackboard equals p blackboard. So now we can go ahead and remove the underscores there because we are actually using those in this function. We pass in the actor and the blackboard just in case we need it on the interrupt. So the advantage here is that this code is never going to run until one of our Hurtboxes actually triggers its wasHit, and then it's going to interrupt the target action. So we assign the target action, which is ground input action, and we add in a Hurtbox, which is our Hurtbox 2D for the player. And hopefully that's enough for that. We should implement the tick function still, I guess. So function tick, which is going to be p actor node p blackboard, blackboard. It's going to return an int. And this will just always return running, I think. So if I understand simple parallel composite, if the main action, the ground input, returns false over here, returns failure, then this is going to stop too. So basically, it's only going to be doing the interrupt checks while this is going. We can test by setting a couple breakpoints. So let's see if this ever gets to there. I'll hit play. Let's run into an enemy. Okay, we got the interrupt action to actually trigger. Let's hit play. And as you can see, it's going to the set shader action, which is under the hit sequence. So we just need to make sure in set shader action, we assign the canvas material, which is our animated sprite. Let's go to the remove shader, set the animated sprite. And does the player hit action need something? Yeah, it needs the animated sprite. Let's hit play and let's see if we can get that knockback. Okay, yeah, as you can see, we lose control over the player while the hit knockback is occurring. The player can also die if he took too much damage. I think what happened there was that there was like no invincibility frames either, so we'd probably want to set something like that up, but we need to go to the death sequence for the player and assign the sprite, animated sprite. We can kind of see that on all of these play death actions and set shader actions that we need a reference to the animated sprite 2D. That's going to be quite common. So what we could even do is on our player platformer character body 2D, maybe just on the platformer character 2D, we have a reference to the sprite. So at export var sprite, which is going to be a canvas item. So we'll call it a sprite, but it's really a canvas item in case we need to use something that's not an animated sprite. And let's assign the animated sprite here. So what we'll be able to do in all of these actions is remove the export. So we don't need to manually do that. And then we just do actor.sprite.play, actor.sprite.play, or .animation finished. Yeah. Okay, now this does kind of make the assumption that there's a sprite property on the actor. But if that's consistent across all of our characters, that should work fine. Now we can go to the other actions like set shader action. And we can just do actor.sprite.material and get rid of the canvas item reference here. And on play hit action, we can also get rid of the sprite reference here and just do pactor.sprite.play animations. And yeah, that just reduces the amount of assigning in the inspector we have to do. So if I have that set up right, it should work the same way now. Yep, you see we just get reference to that sprite, whatever it is, whether it's a regular sprite or a canvas animation, whatever. If we check in the debugger now, there's no animation named hit. Yeah, that's probably one of our issues. So let's go to animated sprite 2D. I'll create a new animation. Let's call this hit. I'll get the frame from here, copy, and just paste that into hit. So it'll be the character facing forward as our hit frame. Let's hit play. We do want to make sure run is the default. I'll hit play again. On the ground input action, we do want on before run to tell the sprite to play the run animation. So pactor.sprite.play, and we'll say global names.animations.run, let's say. Okay, and we can make sure that's a real name by going lookup symbols, lookup symbol, and then do export var run, string name equals run. You can also set a default for idle. We probably need that later. So string name equals idle. Okay, now let's hit play. Let's see, we got the run animation going there. If we hit a guy, okay, it plays the hit frame. Yep, it goes back to running, but when our character's not moving at all, we should actually change it to idle. So on ground input action, I think we should default this to idle. And then on tick, we can check if the character's moving. If so, we're going to play run. Otherwise, we're going to play idle. We could say something like if player.velocity.x equals 0, then we're going to play idle. Otherwise, we're going to play run. Now, having this run on every tick might not be the most efficient. Player.sprite.play, since we already have that reference. But we can give it a shot. It should work for now. So as you can see, if a character stops running, then we just play that one frame. But you know what? I don't like that as the idle frame. That doesn't actually make a lot of sense. So let's actually just stop the animation if he stops playing. I think that makes sense. Okay, so up here, we'll play run. And then if the velocity x is 0, we're just going to tell it to stop. So that's something an animated sprite can do. Let's see, it does have a stop animation. It does have a stop method, so we can use that. So just tell it to stop if it stops moving, otherwise it's going to play the run animation. So now our run looks more like that. And if we get hit, we play that kind of sliding knockback, or we lose control. Obviously it's kind of like too strong, and now we've completely lost control of the character. Let me see where we're at. There's no animation with the name death. Okay, so we can go to our animated sprite, click in there. This should be a death animation. So death. And if we look at the interrupt on hit, it was already connected. So let's jump into that. We might not even need to make it a before run, after run sort of thing. We could actually make this maybe function_ready. And that's where we're going to do this. On before run, we get a reference to that. No need to disconnect on after run. And I think this is only going to actually interrupt the action if it's currently going. So we'll try this. And then that should clear up all those errors. So let's get hit. Okay, we get hit a few times and we're not reconnecting the signals. So it's all good. We still got a sliding knockback, and our character just slides. And we do need to make sure that death does not loop so that he gets removed from the scene. If we want to make the death a little bit longer, though, we could duplicate the frames a bit. So maybe 3 frames of death, so it's like 0.3 seconds. And let's make all of the FPS 10. 10 FPS, 10 FPS, 10 FPS. Okay, we'll hit play one more time. Let's get hit a bunch of times. We'll take damage, and our guy dies and fades from the scene. And that would probably be where we play a game over. So our behave tree is working as intended. There are some things that need to be cleared up. Like first off, game over screen. Second off, probably invulnerability frames. And reducing the force knockback. So we'll work on that kind of stuff in the next video. So now what we need to do is find a way to connect the combat text system to each of the health components as they spawn in. So groups don't exactly make sense because groups don't notify you when a new object is added or removed from the list of groups. but we need to connect to a signal that will occur on each of these health components when their health has changed. Now, grabbing each health component when they enter the scene is also probably a little bit tricky. So I think another solution would be to have an intermediary resource object. We could call it a signal bus, or maybe something like a combat state that has a signal. And then whenever we emit the health changed signal on the individual health components, we can also emit say combat state.healthChange.emit, and then we can just connect to it inside of the gameplay combat text systems. So let's go up to the root of our project. We could put this under data because it's kind of like going in the transmission of data, but I might prefer something like a new folder, and we'll call it state. So if I right click on state and create a new script, we'll call this combat state. And this will inherit from resource. Okay, we'll create that in there. So the combat state, we'll make that the class name combat state. And this will have a export var health changed, which is going to take a health component, a new value, a new health value, and the amount changed. Okay, and this should actually be a signal, not an export var. So signal health changed. Of course, we'll probably add extra stuff to this later on, but for now, that might be all we need. So if I right click on state and create a new resource, and we look for combat state, let's save that under state, combat underscore state. Okay, so we have the one combat state there now. So we can go over to our health script and get a reference to it. So at export var combat state of type combat state, and we do combat state dot health changed dot emit self current health and amount changed. All right. Now when we're setting up the health component, we want to go to the inspector and make sure we quick load that combat state. Quick load the combat state. Yep. Now there's also the option of perhaps making it a global object. So that you don't have to assign it in the inspector. I think that's mostly a matter of preference. Here, if you do leave it as an export, you do have the option of separating the resource into multiple resources of the same type that may exist in your project. But I think either will work okay for our situation. So now in the combat text system, we just need at export var combat state type combat state. Okay, and when that's assigned, we want to connect to the health changed signal. So if is instance valid combat state, well, at this point we'd be disconnecting from it. So combat state dot health changed dot disconnect underscore on health changed, and then we set the combat state to the value that we pass in during the setter function, of course. Then just take this down here and do connect instead of disconnect. So basically, if there's an old combat state, when we set the value here, we disconnect from the signal, we set the combat state, and we connect to the new combat state signal. So now we need the signal callback. So function underscore on health changed, which takes a health component. So p health, the new amount. So p new int, and the amount changed, p amount of type int. Okay, now from our combat text system, we can basically do whatever we want with it. The health component is a node 2D. If you haven't already set it to a node 2D, you can do that so that this has a location in the game world. That makes it helpful when we want to set text on it. So we need to basically have an instance of the text that we're going to instantiate, and then we put it right on top of the health area, perhaps by some offset, and show the amount changed, and perhaps red or green text, depending on if it was damage or if it was healing. So let's put a reference to a packed scene that we can instantiate. Export var text template, we can call it, which will be a packed scene. And on health changed for right now, we'll pass. So we need to create a new packed scene for text. Let's create a new scene. This will be user interface, and we want it to be, I guess, just a label. So let's right click, change type to label, and we'll call this health changed label. Sure. Let's put in some default text, like 100. Okay, so we can see that's like really tiny up there in the top left. So we might want to change the font size. You do that on label settings. So new label settings, font, let's say 36. Okay. If you want, you can change the font to something else as well in your project. You can also use themes for that. I won't really get into that in this tutorial, but there's template. Let's quick load that from the project. We want our health changed label.tscn. Our combat state, we quick load that to be our combat state.trs. Okay, so we have the reference there. We connect to the signal, and now we need to spawn the text template. So let's get the spawn position, which is going to be the phealth.global position. And we also need to instantiate the text instance. So text instance equals text template dot instantiate. We will add that as a child to, let's say, the UI. So we need to reference the UI parent. So let's say export var UI parent, and this will be some control. So inside of our gameplay scene, we can create the UI. I'll add a child node. Let's just say control. I'll rename this UI, and then I'll assign the UI parent as something we can put the text under as a child. Okay, so whenever we instantiate, we do UI parent dot add child, and that's going to be the text instance. Then we set the position to be the health values position. So text instance dot global position equals p health dot global position. We can also mention that this is supposed to be a label as the root. So that'll make it easier to do stuff like text instance dot global position, because now the code understands that it's a label, so it has all of its properties. Then we want to like move the text up. We also want to set its color depending on the value. So we'll set the text instance dot text to be equal to a string of the p amount. Okay. Now for our label, we might want to do stuff like read the text and then see if it's positive or negative. If it's negative, then we make the text red. Otherwise, we make the text green. So let's add a script here. We can put it in UI health changed label. That seems good. I'll create, give it the class name, health changed label. And we'll have some settings over here. So at export var. So let's say that we have a class for determining the colors we set inside of the game. So we could say at export var, maybe game colors or something like that. And this will be a game colors resource. So for that and data, we'll create that. I'll right click, create new script, game colors.gd extends resource. So in here we'll have export var positive, positive health, which is a color. We'll default this to color.green, lawn green, why not? Because we have this bit, setting it to a default value, this is actually unnecessary. And then we can do export var negative health, which will be color.red, and just pick a random red. Fabric, sure, that sounds cool. And let's give it a class name of game colors. Okay, now we need to create an instance of the resource. Right click on data, create new, and then we'll do game colors.gd, save it as game colors, save it in there. Now we need to reference these values in our health changed label. So over here, we just save that again, and we get the game colors resource. And we assign it in the inspector. It should pop up here. If it doesn't, we have to reload. So project reload. Okay, and there we go. We have the reference to the game colors. So we need to quick load this from gamecolors.trs, and now we have access to these colors. So the reason I did all that is just to make it consistent. So if we have anything else in the game that needs to reference colors, like maybe you have a text tooltip for an item and it shows how much healing it does or how much damage it does, then you can use these same colors there as well as in the health changed label. So just combining everything into one resource and then sharing it across the project. So we have the game colors. When we set the health changed label text, let's see if there's a signal for that. Control, not seeing it. This would be an integer. So text is going to equal the string of the p health change. And then basically, if this is positive, we'll show the positive health. If this is negative, we'll show the negative health. If it's 0, that's a good question. Maybe we just show negative. Or maybe positive. Okay, so if p health change is less than 0, then let's say the color. Let's see, how do we set the text color? Text.color. So we could set the self-modulate property on it, which changes the color of just this label component, but not children components. So let's say self-modulate equals game colors dot negative health. Otherwise, self-modulate equals game colors dot positive health. And then now in the system, we're going to look for a health changed label. So in gameplay, combat text system, we expect it to be a health changed label. So if not, or let's say if not is instance valid, text instance, then we're going to push an error, instanced a scene that is not a health changed label. And then we'll return here because we can't do anything with that. Oh, we should also remove it from the scene though. So text instance.free. Okay, just to make sure we clean that up from the scene. Okay, so assuming it is a health changed label then, we are going to, instead of just setting the text directly, we'll do text instance dot set health text, and we pass in the amount changed. Okay, and that's what we need to do there. So let's see if we hit play, if we can actually get them to instance at all. Let's see, node 2D, so it can't be assigned to node, right. So for the health component, we do need to make sure that we change them into a 2D node. So in player, I'm going to right click, change type, node 2D. And in invader, I'm going to right click, change type to node 2D. So let's hit play, and I'll try shooting a enemy. And let's see, invalid access to get current health on type null instance. I guess because these changed their base type, I need to reassign them now. So that's a little annoying, but let's go into invader and let's see. And then object blackboard setter will assign the health. And then in player, object blackboard setter assign the health. Hit play one more time. We'll try shooting. And it's still having an issue. So the Hurtbox needs that reference to the health. So the Hurtbox in player is down here at the bottom, assign the health. And then invader, gonna get the Hurtbox, assign the health component, hit play. And let's shoot. Okay, so the set shader action is not finding the sprite.material. So if we do actor.sprite, we can see that's not there. And that's for the invader. I must have just forgot to assign it. So in invader, we assign the sprite, which is the sprite 2D, the character sprite 2D, hit play. Okay, let's try shooting again. And our text does not at the moment. Okay. If we check world, oh, that's why. Because we're still loading the game world, we're not loading the gameplay scene. So we need to change our project settings to run, not the world scene, but the gameplay scene, so that all of our systems, like the combat text system, load, as well as the UI. So if we hit play, we can see that the text is way bigger than we would have thought. So we'll need to shrink the font size at the very least. Also, when the characters load, the health changed signal triggers. So we need to be careful about that and make sure that doesn't actually occur on the first load. Let's go into the health signal. We could say that the signals don't emit until on ready has actually occurred. So if we create a var ready, and then we say after ready equals true, make this a Boolean. So to pick up again, we want to make sure that we only emit health changed signals if this script is already ready, because on the first load, where we're just setting the health initially, the health hasn't exactly changed, we're just setting the health. So we want to make sure about that. Now, I was going to set up the ready Boolean, but it appears that ready is already redefined. It could be conflicting with the ready function there. Or, I don't know, there might actually be a ready property that I don't know about. So signal, I'm going to have a variable that would just say var ready done, which is false by default. And then when ready is done here, I'll say ready done equals true. If we wanted to be absolutely sure that all versions of ready were done calling, we could use the onReady signal. And I don't know, maybe, yeah, sure. I could just show how that would be done. So we could say ready.connect and then underscore onReady. And we move this to function onReady and just put ready done equals true. And what this would mean is that if we have a child class that's also calling ready and then it does super ready to get this code to run, that I think this would make sure that all versions of the ready function are done being run before it actually does this. So technically speaking, I think this would be a little bit more correct, although either would work in probably 99% of cases. So we have ready done, so we're just going to have to check here if ready done, then we're going to emit the signals. Otherwise, we're not going to emit the signals because this is like the first set. Another alternative would be, so I think that should work good. If we hit play now, we shouldn't see the 100s pop up. So as you can see, the numbers only appear after they start taking damage, not on the first load set of that value. So that works. Now going back over to the health change, the label settings, the font is way too big. So in our game, the camera, I think, scales it up 2 or 3 times. So if we hit play, it should still be pretty large on the screen. So we got that -1 there. And we probably would change it to something else, like a pixel art font. Actually, it does really bother me. I do want a font that works for this. Let's grab something. So a pretty good font we can get off itch.io is M5X7. So I'm going to download that to the project and we'll use that as our main font. And I'm going to create a folder in the project, the file system for it. I'll just call it fonts. And maybe I actually move the fonts folder into art. Fonts is probably only going to contain 1 or 2 files for like the whole project. And to have it in the root directory is like a little bit too much space, I would think, for giving it, if that makes any sense. So if you just pop it in there, go back to the project, it should show up as a .ttf file here, and you can use that in Godot. So regarding using the font settings, I think what I want to do is create a theme, and I'll do that on gameplay. I'll click on UI. This theme will apply to every control that you add to the UI. So if we expand theme here in the inspector, new theme, we'll expand that. I'm going to use the default font, just drag and drop. Default font size, let's say 12 or 16 maybe. You can see a preview down here at the bottom. I'm going to save this to the project, right click save as. Where do I want to put this? Probably in UI. So let's save this as UI theme dot whatever the default is. I think it might be TRES resource. And now if we hit play, when we shoot a guy, it should be using the new font. But I'm not sure if it is. So let's expand gameplay, UI, click on these. Maybe the label settings is just kind of overriding that. So if we go to the health changed label, we can undo the label settings because I think that's overriding the theme. Hit play and let's shoot at guys. Yeah, I think the font changed here. And you can see that this font is more like pixel perfect. There's no anti-aliasing. So those kind of pixel fonts work a lot better for these type of games. Let's say right click on health changed label, give it a add child node, a timer. Okay, and this timer can just be 1 second. Let's say one shot auto start. So it's going to play once and then we're going to connect to the signal. When this timer is up, we remove it from the scene. Inside of the health changed label, let's give it the reference to the timer. And then let's give it a move vector or maybe move speed. And this will be a vector 2. We could say equals vector 2. And I want it to go up by default. So that's going to be 0 and then -100 or so, I'm thinking. So this would be like the speed per second of delta time. And then we can use the function underscore process to move it. So let's say global position is plus equals move speed times delta. Now remember, this is a vector 2. So if we add a x value here, it can move to the right or diagonally as well. And then on ready, okay, let's move this below. Above process, I'll put function underscore ready. And then we'll connect to timer dot, let's say, timeout.connect, and we'll do on timeout as the callback. down here at the bottom, we'll put function underscore on timeout. And timeout is one word, so I should get rid of that underscore there. So on timeout, we're going to remove this from the scene. So I'll just say QueueFree. QueueFree just waits till the end of the frame before removing it. So anything else that is for any reason depending on this object will have a time to finish up its scripts before everything gets removed at the end of the frame. Okay, I think that's probably pretty much it. So let's hit play. Let's shoot. And I did not set a timer. So in the inspector, we have to go to health, change label, and assign the timer. Hit play, and let's shoot. Okay, so yep, there's our damage text. It moves too fast and it lasts for too long, I would say. So let's go into the script. I'm going to change this to -75, hit save just for the default. On timer, I'm going to make it 0.5 seconds. So let's hit play again and see if that's a little better. Okay, so it kind of works. Yeah, it's a little fast though. It's a little fast. So I'll make it -50 for the move speed vector. So let's hit play again. Shoot some enemies, and there is our floating combat text. Oh, and it also works when they hit us. So you can see we're taking 10 damage a hit. Pretty unfair considering the projectile only does 1, but hey. And you can also see that we easily get hit 2 or 3 times. So let me hit play and kind of re-demonstrate that. Watch as the player will be in the hit state and get hit multiple times during the hit state, which is not good. Yeah, okay, there we go. -10, but 2 times during a hit state. So being hit while the character's in a hit state and can't move is pretty unfair. So that's what I wanted to point out was happening behind the scenes, but now we can see it visually. So we want to take our player. I'll go into the player scene and make sure that the default animation is actually run. Let's play that. And now in the world, what's going on? So I'm going to jump into the level and move our player down a bit. Let's make him actually sit on the ground when the game starts. Same with this invader, I think. Doesn't make a lot of sense for them to start above the ground. And actually, if I look at this, I can see that the physics shape is making the invader above the ground too. That's a little wonky, so I'll jump into the invader scene. And yeah, we either have to move the character sprite down a frame, like that, or we'd have to move the physics shapes up a frame. But if we're moving the sprite, we should also move some of these other physics shapes. So I'll move this collision hitbox down. Okay, maybe this Hurtbox should actually shrink a little bit, and I'll move it down. So as long as the invader's going to stand on top of the ground, that's what makes sense. So back in world, we should see them flush against the ground. Didn't save level 1, so I need to save that so that the world can update. Okay, now he's on the ground in the world as well. So on the player scene, let's make it so that when our character gets hit or dies, that we set the character to be invincible. So there would be 2 ways to approach this. One would be that you take all of the incoming damage and make it 0. The other would be that you remove the ability to access the Hurtbox. Or I guess a third would be that you disable damage, but you still allow the Hurtbox to be hit in the case of a healing effect. So maybe we'd want the character to be able to be healed, but not to be able to be damaged when the character's in a hit stun. So if you disable the Hurtbox entirely, it wouldn't be able to be targeted by anything. So that might not be what we want. Okay, so in order to take our Hurtboxes and make them invincible, what I think I want to do is, as part of the sequence for the player behave tree, we'll add an action where we target the Hurtboxes and set a property invincible to make them invincible. So in the Hurtbox 2D, I will make a @export var invincible and not invincible. Okay, so by default, pretty much every Hurtbox is going to be off for the invincibility. So we need to create a action on the hit sequence. I'll right click here, add child node, and say action leaf. Let's rename this to be set Hurtbox invincibility. I'll right click here, extend the script, and let's put it in objects. So which is an array of Hurtbox 2D. And we want export var make invincible, or maybe just invincible. And this will be, well, just a Boolean. I guess we don't have to make it invincible by default. So just going to toggle the value to whatever we want, on or off, and we can add it twice, once to turn it on, once to turn it off. So function before run, which is going to take a p actor. We're not going to use that. Underscore p actor, type node, and then underscore p blackboard, which is a blackboard. And then this will return void. We're going to take each Hurtbox. So for Hurtbox and Hurtboxes, we're going to take Hurtbox.invincible, and that's going to equal our invincible property. And then we need to do function tick, which is going to have the same parameters here. So just copy those. This returns an int. After we set the invincibility property, we can simply just do return success. And that's probably all we need. So after we remove the shader, we want to set Hurtbox invincibility off. So I'll add in all the Hurtboxes here. Let's assign the Hurtbox for the player. Then I want to copy this node and paste it into the sequence. And let's move this before the play hit action. And I'm going to, and then I'm going to toggle this on with the same Hurtboxes. The final Hurtbox invincibility can say set Hurtbox not invincible. And the first one will be set Hurtbox invincibility. So now basically, while play hit action is running, it's going to be invincible. And once it's done, it's not going to be invincible anymore. So if we hit play, we should be able to take damage and then the invincibility turns off. Let's see if I can get hit twice. It would probably be easier to see if I open up level 1 and we duplicate a few more invaders so that there's a lot more chances to be hit, but we should only see the damage text appear once. So I'll go in here and you can saw that we only get damaged once, even though we're running through multiple guys. So that is one approach to invincibility. It does kind of depend on us having the behave tree, but if we're using that for all of our enemies and a player as well, then I think it's okay to set it up there. Although there's many other options. I did have other ideas in mind, like you could basically manage it straight in the Hurtbox by reading from the blackboard of this hit data. You could disable the collision shapes entirely until another event turns them back on. Therefore, the character wouldn't be able to be interacted with by anything that targets the player layer. Really just a lot of approaches. So in this part, I want to clean up all of the warnings that we've been getting so far in the tutorial series, just so that we're up to a good point before we continue. So let's start with all of these, the parameters never used warnings. So if we click on each of those and they say like, okay, delt hasn't been used, so underscore it, then we can just find it and then underscore it, or we can not assign it at all. So in this case, I'll just do Hurtbox.hit, and we don't need to assign the return value to anything. And this next one, pActor, I'll just underscore it for both of those function parameters when we don't use it. And let's do the same thing for any of the other tick or other action leaf related functions. Okay, and in this case we did use the blackboard, so we don't want to underscore that one. But in this one we're not using the blackboard, so we underscore it. And then here, underscore and underscore. Nope, just for the actor actually. Okay, here is another actor and blackboard. On this one, actor and blackboard, underscore them. On this was hit function, we're not using the hit data. We just interrupt, so we don't need the hit data. On the before run, looks like we're not using the blackboard. And I guess, no, we are using the actor. On after run though, we're not using the actor or the blackboard. So if I clear here and we hit run and let's just, do normal stuff, we should see a lot of the warning messages disappear. So now that most of those are cleaned up, we can finish up just with this last one. This tick doesn't use actor. And let's see. On this one, the variable Randy has the same name as a built-in function. We can see that if we type in Randy, we can see that you can generate a random number. And I guess even without having a random number generator object like we created in a previous video. So I'm just going to take this and say random integer and change the value down here. So now that this doesn't use the same name, there shouldn't be a conflict there. On this part, force vector is already shadowing an already declared variable. If we look at the top, we have the force vector there. So calculate force vector. We could just rename this to be calculated vector, and then return the calculated vector. So it's just important to make sure the names don't match properties, because otherwise there can be some confusion there. And let's see, here the spawn position is never used. So spawn position equals p health global position. What we probably want to do is take spawn position and replace it here. Okay, so we got the spawn position, we're setting it here, and that's just to kind of clarify why we're using p health.global position, because it's the spawn position of our text instance. And let's see, p new is never used, so we can underscore that parameter as well. And in this class, the combat state health changed is never explicitly used. So for that, I think we can do @warning ignore, and we're looking for unused signal. Okay, because the idea here is that we are going to use it through the combat state. We're just doing it through other objects. So our health object emits the health changed signal through the combat state, and that's getting sent to the combat text. So the combat text system, if we look in there, it responds to the health changed on the combat state. So we don't need to worry about how this isn't used internally in this class, because it's actually being used through the class by the health object. So we can ignore that for right now with warning ignore. Okay, let's hit play and see where we're at. I guess we have one more warning to go through. So that's object stats, resource not local to scene. So that's kind of what we expected, that an object stats should always be local to the scene, because they are going to be unique per object. So what I want to do here is set a breakpoint and see which object we did not set local to the scene on. So if we check self, it's a type of character stats. Let's see, is there anything that we can use to see which object this was? Unfortunately, it doesn't look like it. So I'll go through the scenes and just see where that's not local. So in player stats, if we open resource, we can see this isn't local to the scene. So we need to set that local to the scene. If we hit play now, okay, that debug message goes away. So that warning was just there because we want to make sure if there's multiple copies of the player, that each copy of the player stats or the object stats, which this is a child class of, is unique to that character. Now, originally we were doing that because the current health was also set on the player stats, object stats, but at this point, this is more just like a stat block that we use, not one that we modify. So it's possible that we might not need that to be there anymore. But just as written, we wanted to correct that warning, and we have. So that basically clears up all of the warnings that we've had in the tutorial so far. So now we can start working on other stuff in the final few parts of the series. So although our knockback is working, when they get knocked back, it's just a consistent speed, which could be more interesting. So one way we can change that is by creating a curve resource and then sampling from that resource to figure out at what point during the knockback animation, we could say, that they should be going either faster or slower. So we could have a build up of speed, or we could start really fast and then end kind of slow. So I think that this would be most appropriate in our weapon stats script, where we have our knockback stats. We'll just jump into knockback stats, and then we can add a curve here. So at export var curve, and this will be of type curve. I don't think it needs to be curve 2D here. So we'll start with a regular curve, and let's save this. Now if we open up weapon stats basic and we expand our knockback stats, then we should be able to see the curve resource here. So for the curve resource, let's do a new curve. We'll expand it, and you'll see this little blank graph. So let's start with a preset to make setting it up a little easier. If we click preset, we can do linear to start, which would pretty much give us the current value of, we just move at a consistent rate as we go from point 0 to point end. So on this graph, the duration is kind of our x value, and then the force is going to be our 0 to 1 in the y direction. So basically, as time progresses, the current velocity of our object is going to change. So let's click on the curve resource menu and choose a new curve. I'm going to go to presets, and let's start with linear. So in this graph, X is basically going to be our time, the duration. So at 0.25 seconds, that's actually the 1 over here. And for 0 to 1, we are going to basically be taking the current force velocity and multiplying it by this value to find the final force. So with this graph, what would be occurring is that at the start of our movement, it wouldn't move at all, and at the end over here, it would move our full amount. So if we wanted it to work as it did right now, we could go to presets constant and then just move these up to 1, like so. And then we'd basically be doing 1.0 multiplied times the force for the entire duration. Rather than needing to do that for a simple knockback like we currently have, I'll just make it so that we only multiply it by the curve if one exists in our knockback stats. So if we wanted to have a buildup of speed, we could do linear here. So we start not moving and we end moving at the full rate. So we'd start not moving and we'd move at the full rate up here. So we can start with that and see if we want to adjust this. In the script, I'll give it a comment. So on this curve, X is the time elapsed of the duration, and then Y is a multiplier for the force at the given time. So the Y multiplier and the X time elapsed. And this should be optional. So when you set comments like this, you can hover over the property in the inspector, and you can read those comments there, by the way. So when you set comments like this in the script, you can read them in the inspector by hovering over them like this, by the way. So now we need to take this curve and apply it to the force when we create a hit. So in hit data, I think what we want to have here is just to sample the current force. I'll go with something like get velocity. So I might start with something like the base vector, which will be equal to the direction times the stats.force. So that'll be kind of like our base movement amount before we apply the curve. And then if stats.curve, then we're going to adjust that by whatever this sample value, let's say time elapsed, which is a float. Time elapsed, of course, will start at 0. And then we'll sample the curve and multiply its value by the base vector. So sample value equals stats.curve sample, and that'll sample the time elapsed. So before that, of course, we want to add time elapsed plus equals the p delta. And then when we have the sample value, which should be between 0 or 1 at a moment in time, adjusted by a curve if one exists in the knockback stats. So we're no longer going to use calculate force vector because we want our knockback velocity to be dynamically adjusted by the curve. And that means that our direction, so we could actually just, let's say, rename this to adjust direction. And this will take the p hit direction vector 2. So instead of returning the calculated vector, which is the direction time, and then up here, we're going to adjust the direction. Call this the hit direction for the init. And then forget velocity. Okay, so one thing though, I think that this would work if we only have one object trying to get the velocity on a knockback per knockback, which usually would be the case. But if we have two objects at the same time passing in the delta, then the time elapsed is going to get kind of screwy. So I think a better solution might be to get a float, and then this time start is going to be equal to time.get. Let me go down here, ticks milliseconds, and I guess we want to times that by 1,000 to get it in seconds. Or hold on, no, divide by 1,000 to get seconds. Okay, and then we're going to basically take the time start in seconds and then use that to sample the curve. Okay, so this means we no longer need the p delta. We can just pass time start into this curve. Oh, not time start, but actually the current time minus the time start. So if our time elapsed would be, but I think to make this a little bit better, we can remove the divide by 1,000 here. So this will be in milliseconds. And then I'll cut this. So we calculate the difference in milliseconds first. and then, and like so. So then we're only dividing by 1,000 once. So this would just be milliseconds minus milliseconds, and then we convert it to seconds. So since I've removed a function from this knockback class, it's definitely going to break something in the game. So let's hit play, and we'll go to where we were. So since I changed a bunch of stuff in the knockback class, it's definitely going to cause some missing references inside of the game. So let's hit play and try to cause a knockback, and we'll see where we get issues. So the character velocity, instead of doing the force vector by the knockback multiplier, what we should be doing here is hitData.knockback.getVelocity times the object stats knockback multiplier. Okay, so we can see nothing really changed, and that's because we're only checking the velocity before run. Also, the attack of the enemy, we never set a curve, so it is just working as before. So what we actually need to do is, while we're doing the playHit action, we need to calculate this on every tick. So on tick, if hitData.knockback exists, then we're going to set the velocity again, like so. Then we should look for the invader collision stats and assign a curve to it. So I'll do a new curve, and let's do a preset linear. I'll hit play. Okay, and let's get hit by one of these guys. Okay, so nothing much seemed to happen there. Let's go into knockback, and I'm gonna set a keyframe here. And it looks like the direction was set to 0. So let's put a breakpoint there as well, so that when we get hit, we can see what direction we're getting hit from. Okay, and we can see if we look at the get move direction that we're taking the original direction out of the property, not the one passed in. So we want to copy and paste the name there, make sure we're using the p-hit direction. That's one reason I've been naming the parameters with the p underscore, to make it very clear that we are using the parameter and not a property from our class. Okay, so let's hit play and see if that's working better now. Okay, so our adjusted direction is x1. That's what we would expect. Let's hit play. Also set a breakpoint there for the curve. So our curve's calculating. We have the time elapsed in seconds, 0.015. That looks correct. Our sample value is 0.015. That's what we would expect as well. Let me get rid of the breakpoint so that I can just kind of see it visually. Okay, so we can kind of see with the projectile, it is sort of working, because we can see it sort of accelerates over time, is that when we're sampling the curve, it should be as a percentage of our total duration. So I should say var percentage elapsed, and this will be basically time elapsed seconds, let me see, divided by stats dot duration. Okay, I think that's right. So now that's what I want to be sampling. So let's shoot. Let me actually set a breakpoint and see if that's as intended. So if 0.016 seconds have elapsed, but we only need a quarter of a second for the movement to finish, then that should be 4 times the value here for the percentage elapsed. Okay, so that seems correct. And we hit play. Okay, and we can see that basically based on this, we would need to increase the base force by a lot, or we need to change the curve. So I'll search for stats, basic weapon stats. And you know what, maybe I'm just gonna change the invader collision stats to have the name weapon stats instead of just stats. That way I can search weapon and find it easier. But for our projectile, I think what I wanna do is have it start fast and end slow. But because it's gradually decreasing over time, I'm going to make the force 250, and then we'll hit play, and we shoot. Okay, so now we can see the knockback is more like a sudden movement that slows down over time. So doesn't that feel a lot better than just having a consistent slide? This looks a lot more like an actual knockback. Okay, then we hit these guys over here too. And I could even shorten the duration, like 0.15, and then make the force 300 for an even more sudden jolt. Okay, so we hit these guys. Yep. Okay, and there's our tiny little knockback, right? Okay, so we want to do something similar with the invader hit. So on the invader linear, we'll start fast and slow. You can even give it like Bezier curve handles if you do, like, let's say ease out. And we move this up here and this down below. Okay, so now we might want to click here, grab the curve handle, and do something like this. So because it has like a bit of a slope, that should be able to smooth it out if you set it correctly. But our first will be, let's say 150 over 0.1 seconds, 0.15 let's go with. Okay, so if I hit play and we get hit, I can see it's not actually moving the character. So I'm thinking something else is actually setting the velocity of the character. So we need to figure out what's going on there. Yeah, so if we check the player in the physics process, we're already setting the velocity here. That's kind of problematic. So we were trying to move that to the states, right? So in the ground input, I think we set the velocity or just the direction. Okay, so let's check what the super function has on platformer character. Platformer character, apply gravity, and apply move and slide. But in the physics process, we're setting the velocity to be equal to the stats walk speed times the direction. Now, we should move this out of here. I'll save it, and that should actually go in ground input action. So I'm going to paste that in there, and we do player.velocity.x inside of our ground input action. So this state, or this section of the behavior tree, is controlling the player velocity. Okay, this is going to multiply by the player.stats.walkspeed. Or if we don't want to have to manually pull the stats out of the player, we could just say player.walk direction, player.walk. And then we can put this back in the player class, but we just don't call it on physics process automatically. So you could say function walk, which is going to do this line. So the velocity x is equal to the stats walk speed times the direction x, but we have to call this function separately. And on physics process, it's going to do the move and slide, but we're only going to call this from the outside script of the ground input. So only when we're calling this are we going to just have this movement override everything else. So if we hit play, and now I go into an enemy, yep, okay, there we can see now we are actually getting the knockback to occur properly, because we're only able to do the walk movement when we are inside of that ground input. So that was basically just a remnant of the code from before we had the behave tree that we needed to work out and move into these states. So the walking only occurs when we're in this state, and in everything else, we don't have that option. So I can demonstrate that once again. We have our strong knockback from the enemy, perhaps even a little bit too strong or too fast. So I might increase the duration and I might lower the force. We're gonna play again, test that out. Okay, that's not too bad. So to give the player a little bit of extra invulnerability frames, what I might do is move the set Hurtbox not invincible out of the hit sequence, but put it back into this bottom sequence down here for the ground input. I might rename this to be ground free movement. And then I could add another one of these splitters so that I could have this trigger after a timer. So if I right click here and add a behave node composite, a simple parallel composite, I think you can have two at once. So if I want to give our player a little bit more invincibility frames, then rather than setting the Hurtbox not invincible at the end of the hit sequence, I can do it at the start of the ground input sequence after a set period of time. So I think all I would need for that is another parallel composite. So if I right click up here and we add in a composite parallel, I'll move this one into here and we'll say this is the ground state, sure. And this can be just ground movement, I guess. Maybe I call them parallel composites still, so that it's a little bit more clear. Okay, and then right here, I'm gonna do set Hurtbox not invincible. So I'll move that in there. But before this happens immediately, I wanna have a timer for it of sorts. So let's right click here, add a child node, and we want a time limiter decorator. No, that's not right. Decorator, and we want the delay decorator. Okay, so we put that in there, move this up a bit. The wait time is going to be however long we want the character to be invincible for after entering the ground state. So 0.1 second, let's say. And I'll move this under the delay decorator. Okay. So basically, after a set delay, it can do the set hurtbox not invincible. Yep. And it's no longer part of the hit sequence. So I'm going to hit play, and let's see if that works. Okay, so we got hit. Our character was invincible, and our character's invincible again. Okay, so now if we go into this bunch of dudes, it should be a little bit less abusive. I don't think 0.1 second was long enough. Let's make it a quarter second. Okay, so this actually took a little bit of testing to figure out. But what's going on with the delay decorator is that the before run will run immediately, even if there's a delay, but the tick has the wait time for a delay. So if I hit play here, you'll see that as soon as the game starts, the before run runs immediately. So that's why the delay wasn't doing anything. But if I hit play and continue, let's just remove that breakpoint, then you'll see that it takes a couple seconds for the tick to actually start. So if we want the set hurtbox invincible to work properly with these decorators, then I guess what we need to do is just take all of this, put it down into here, remove the before run, and then we'll return success. And then when we return success, this should stop operating, I would think. Well, let me see how many times that runs, and I'll remove this one temporarily. The other set invincible. Okay, so 2 seconds are going to occur. And then we're going to get the tick to run. We hit play. And yeah, it's done operating because it's already hit success. So this, I guess, should be all we need. 1 tick, and then we return success. So if I have things set up correctly now, then we take the delay decorator and set it to how much invincibility time we want after entering the ground state. Let's say 0.1 second. I'll hit play. And let's see if this works as intended. So we're going to be able to walk for a second. Yeah, it does seem to be there now. Let's make it 1 second to make it very obvious. So 1 second of invincibility after getting hit. Yeah, okay, there we go. That's working a lot better now. So I'll make this 0.25 seconds. All right, play. Then we can move our character, but we have like those invincibility frames. So it's a lot easier for us to escape the characters, the enemies, after getting hit, and this just feels a lot more fair as a player. So I'm not sure why the before tick works like that, but that seems to just be a feature of the behave tree. So something to be aware of, that the delay decorator only delays the tick function from operating, not the before enter from triggering. So you do have to be careful about that one. All right, so at this point, we've kind of improved the knockback. We have the curve to give it a more of a smooth, nice animation with a strong upfront knockback and a weak tail end knockback. And we've given our players some invincibility frames after re-entering the movement state. So that is just making the mechanics feel a lot better for this prototype. So I think that's where we'll wrap it up for this video. So one more thing I'd like to add to our game is the ability to report and track statistics such as how many times enemies have been slain inside of the game. So we would need one node to report that data and then another object, possibly the combat state resource, to receive that data and track it, and then maybe connect to that data through, let's say, a UI component in order to show that on the screen. So if we go to the invader scene, we can see our health component. On player, the health component is also here. And in order to know what type of enemy died, we'd probably need a reference to the root node of our character scenes. So in this case, it's the invader enemy. In the player scene, it would be the player character script. The health component already has a reference to the combat state, so that's easy enough. Inside of the health script, if we open that up, so on the health component, we could report that the character died and is alive, like the combat state health changed was reported. But that could be possibly problematic. If you have an enemy that has, let's say, multiple health components for different parts of the enemy, like a boss fight or something like that, then the enemy isn't technically completely dead until all of the health components have hit 0. So therefore, we would probably want to put the code in the invader script or the root object in case we need to customize that. So you could like extend and then override it or something. So if we look at the invader script, we have this platformer character 2D. So we probably want to put in a reference to the health component here at export var health of type health. So every platformer character presumably is going to have a health component. So when the health component is set, if one exists, then we'll do set value, the setter, and we'll connect to its signal for when the character is no longer alive. So if is valid instance is instance valid. The health, then we'll disconnect from the signal. Health dot is alive changed dot disconnect on is alive changed, and then health equals value. And remember that's the health component, not the value of the health, the current health. Then we just need this copy pasted again down there, but now we connect. And we need is alive changed to have a callback down here at the bottom. So function underscore on is alive changed. This is going to get the p value, which is the Boolean. So is it true or false that the character is alive? Or maybe p is alive would be a little bit more appropriate. So if p is alive, and we'll put a not before that because we're talking about the death state, then we're going to report on the combat state that this character has died. So I guess we'll need the combat state too. So at export var combat state, and this is of type combat state. So down here at the bottom, combat state dot report death, and that'll be self. And I'll quick load this in the inspector. So quick load combat state, go to the player scene and make sure that's set there too. Quick load. Okay, and now basically through the health component, we know if the character has died or not, and then we report the character being dead over here. So in the case of a character that had multiple health components, we would probably check on is alive changed that all of the health components for that character have reached 0 health before we report it as being dead on the combat state. Since you'd have to defeat all the parts of a boss before you can report it as being defeated. So you can override or create a separate script or anything you need for that, but basically the health component needs to be untouched. Since this is just managing one health component, but not necessarily all of the health for a character. So if we go to the combat state, we have the report death. So for the report death, we want to check what kind of node died. If it's one of the valid types, then we report it. Otherwise, we'll probably give a warning that it's not handled properly. So if p node 2d, and you know what, I'm going to actually just kind of rename this to be p node, and I'll actually just make it a node type. Theoretically, it doesn't have to really be a 2D node. Maybe a script actually is separate from the character body, and we want to allow for that too. So if p node is a let's say a enemy character 2D, then enemies died plus equals 1. And we could have if p node is player, then player deaths plus equals 1. And maybe for each of these we do return. And maybe we just want to make sure that at least one of these types is valid. So we could say var handled equals false. And whenever these run, we'll say handled equals true. But if not handled, then we want to push a warning. Try to report death on node. I'll do %string replaced by the node name, but no matching type was found. Okay, and then to replace that %s, we can do a %sign and then p node dot name. So this just takes this string value and puts it into here. So for these, I could just use the class of the root node. So if I extend enemy character 2D from platformer character 2D, then that would work here, kind of implied. Or the player class already exists, but I think that's a little less flexible because the nature of labeling it an enemy by using the class name like that. It means that any child classes have to inherit everything from the parent, including functions, how it operates by default, and properties, and so on and so forth. So really, I just kind of want to classify different objects in the game. So I might create so one way would be to create an enum variable, which has a bunch of types, though that has to be hard-coded. And instead what we could do if we want to be extra flexible would be to create a resource type. We could call it object classification, and then we assign one or more to any root node of a player, an object, a scene, and then just read that from here to see if the classification exists in the array of classifications, and if so, then we can report it as an enemy died or a player died. There might be some situation where maybe a object is both an enemy and a player, or a inanimate object but also a player, and we might want to include both of those in the handling of that. So let's see, to do that we could go to the data folder. I'll right click, create a new script. This will inherit from resource. I'll call it object classification .gd. We'll open this up, give it the class name object classification. This probably doesn't really need anything else. So I'll create a folder for object classifications. So object classifications, and I'll move object classification.gd into that. And then inside of here, I'll right click, create a new resource of type object classification. And then we can just give it the name of the classification. So I might have one for, let's say, object type player, and hit save, and then do that for any other type we need. So I'm actually going to rename the folder to be object types, object underscore types, and we'll rename the class to be object types. The class name can be, let's call it game object types, and hit save. I'll rename the script again, game object types, and the folder name game object types. So why am I calling it game object types? Well, there is a class object that is the root of everything inside of Godot. Every node, every resource is a object technically. So I want to be specific that we're talking about inside of the game, the gameplay objects, the ones you see on the screen, is what we're talking about here. So that would probably mean that we rename the object type player to be game object player. Let's create some more game object types. So if we look for game object types, we just create one of these for anything we need. So game object enemy, and then I'll right click, create a new resource, game object types. And then we'll say maybe game object NPC. Let's create one for inanimate objects. So maybe just game object inanimate, because I think that would be a separate category from enemy, NPC, and player. It's possible there could be a better name for that. Okay, so for each of these, we can put these into the combat state. So now in the combat state, our state needs to know about which type will get assigned to which variable here. So when an enemy died, which type of game object do we use to report that an enemy died, which of course would be the game object enemy. Did I actually create that? Yeah, I did. So we need a few export variables in the combat state here. Or maybe rather than importing them straight in the combat state, what we'll do is just create a global object. So a global object to hold all of the types and kind of universalize them in the project. And this will be game object types.tscn. I'll create that in the folder. Let's open that up. We'll assign a script to it. So this will just be game object types.tscn. So the script for this will be global game object types.gd. I'll create that. And then we can add our export variables here to assign each type to a property name. So at export var enemy will be, of course, game object types. And then we do that for each one we need. So at export var player game object types, at export var NPC game object types, at export var inanimate, which would be game object types. Okay, and now I'll just assign each of these in the inspector. So inanimate, NPC, player. Okay, so let's make that a global. So let's add the path for data, game object types. And I'll make this list view. We want the scene, game object types.cscn. Add that. Must not collide with an existing class name. Right. So maybe I rename that to be global object types. I'll go to project settings, and we'll add that in again, global object types. Add that. Okay, so now in the combat state, we don't need to specifically reference each of these individually because we can just use the global types now. But first, let's make sure that our object stats has a list of game object types that are assigned to it. So if we open up the script here for editing, so I just click a couple times and we get to character stats, but really I want to look at object stats. So this will be at export var types, which is going to be an array of game object type. Yeah, and that should really be a game object type, not types. So if I open up the script for game object types, let's make that a type. And then I'll rename the script as well. That probably does mean, and the global game object types, that I need to change the class name as well. So just to update that. Because if we're talking types, we're talking plural, so it really makes sense to make the base class name singular. Just tab things over a bit, and yep, that looks good. Okay, so our object stats has an array of game object type called types. So if we open up the invader and we look at the invader stats, we'll have this null array here. Let's reset that to a size 0 array, and I can add in as many types as I want here. So at this point, it becomes a little more flexible than an enum, because first off, you can create a new type in the file system just by creating that new resource. And secondly, you can assign as many as you want to this invader stats object. So it is just an enemy. So I will, for some reason, it still says game object type. So let me check object stats. Maybe I need to reset, add one in, quick load. Cannot get class game object types. Okay, I think the project needs a reload. So now we have game object type here, so I just need to drag and drop whichever ones I want to assign to invader. Invader is a type of enemy. And now if we go to the combat state, we can get the stats types. So if our types is an array of game object type, which is going to be equal to pnode.stats.types. All right. So this basically means that on any root node, we do need to implement the stats.type, but since basically any root object is going to have object stats, it should have this variable. So we do expect that to show up. So stats.types. And so we can check for the types that we need to, and if that type exists in the array, then we increment enemies died or player deaths, so on and so forth. So we can just be like, if types.has, and then we do global object types dot enemy, then we'll do enemies died +1 and handled equals true. And we can just do that for each type we want. So if types.has global object types dot player, then player death +1 and handled equals true. So we cut this bit down there. And so now we can basically just add in new types, reference them in the global object types, and we'll be able to handle them inside of report death. We don't need to worry about making the player character 2D script of a enemy character 2D script. So we don't need to like force inheritance. We can just have this separate type resource defined in order to set things. So enum would also probably work fine. But doing it this way does mean that you can create new types without messing with the code, where enum you have to hard code those in. Okay, and now we just need to make sure that each platformer character 2D is going to reference the health. We get this combat state report death going. So our player needs to assign the health component, and now invader already has it. So if we go to the combat state, we should be able to set a couple breakpoints here and see if we can get that to trigger. Oh, but we are going to need to set the weapon stats to a value where we can actually damage the player. And so maybe the invader hits for 10 again, and the weapon stat basic goes back up to 25 damage, so that'll make combat actually flow. And we go to hit play. So let's hit the enemy 4 times here and see if we get the debugger to trigger. So we had one error. Tried to report death on node invader, but no matching type was found. Okay, I'm going to put a check on platformer character 2D. So on ready, function underscore ready, I'm going to check that stats.types is not empty. So if stats.types is empty, push warning, no game object type assigned to %s stats. And that's going to be the name of this node. Okay, let's see. If I hit play, do we get any debugger messages? Yeah, we do. Okay, so we can see that all of the player, the invaders, they don't have any object types assigned. Which is weird because clearly it is there in this array. Okay, so I can't exactly say at the moment why this is happening, but the fix, or at least a fix for why the types array ends up empty at load, is that at load there's 2 assignments to the types array. So one is going to be the values we actually set in the inspector, and the other is where you make the array empty. I think usually it would flow in reverse actually, where usually it sets the empty array and then it gets the export values and assigns those. But what was happening right now is that it assigns the array that has 1 into there, and then it assigns the one that has 0. So when the game actually loads and everything's ready, that it would have 0. So as a setter function, you can just say that if the value is empty, we ignore it and return, so that only the setter that has an actual value in there is going to matter. I'm not sure why that is. It could have something to do with the init function and not being local to the scene, but that at least fixes it for now. So as you can see, there's no debugger messages. If I shoot a guy a few times, we can see that the enemy type is actually processed here. If we expand types, we can see the enemy type is there. So at least for now, that should work. Just as a safeguard, making sure that we actually only grab the array that has the data in it, because that's all we really care about. So we could also test this with the player. If I hit play and go take damage a bunch of times, we should be able to count how many times the player died. So we got the player deaths +1, so 1 enemy died, 1 player died. Okay, so we set up object types in the game, and now we have our simple counter here. So when player deaths changes or enemies dies changes, we can emit a signal on those. So I'll say signal player deaths changed, and we'll say count integer, and we'll have signal enemies died changed, which will be count integer. So to emit those signals on these properties being changed, I'll just say that when the property changes, that the signal gets emitted. So set value, and we'll say if player deaths equals value, we'll just return. Otherwise, player deaths equals value. Okay, so 2 equal signs to do a Boolean check, 1 to assign. And then, so if we assigned a new value, then we want to emit that value changed. So, player deaths changed dot emit player deaths, and then we have basically the exact same thing for the other property. So just copy paste that there, and we replace player deaths with enemy died, just like that. So when the number of enemies that have died in the game changes, we emit that signal. Okay, with those signals there, it's now very easy to connect it to UI. Okay, so now in gameplay, our UI is going to need some kind of game stats control. So I'll add a new scene, user interface. I'll rename this to be game stats. Let's change the type to be a panel so that it kind of has like a background theme there a little bit. And so I'll give this a script with the add script button. We'll save it under UI. So game stats.gd. It doesn't necessarily have to extend panel. It could just be control. unless you want access to the panel, then you can leave it as extends panel. And let's see, we don't necessarily have to give it a class name because we're only going to really use one in our game. And so this is going to need a @export var combat stats reference or combat state. Okay, and save that. Okay, so we need to save this TSCN and UI, so save. Okay, we need to get the combat state, so quick load that on the inspector. Okay, and that's going to give us access to player deaths and enemies' deaths. So we need labels now in order to display that information. So right click add label, and this will be, first one will be enemies slain label. Okay, and we'll duplicate that, and then this will be the player deaths label. So in the game stats script, reference both of those. @export var enemies slain label, which is of type label, and then @export var player deaths label of type label. Save that, assign the labels. Okay, now we want to connect to the signals in the combat state. So just like I usually do, first we'll check if it's valid. So if is instance valid combat state, then we're going to disconnect from any existing signals for the old one. So combat state dot enemies died changed dot disconnect on enemies died changed, and then combat state dot player deaths changed dot disconnect on player deaths changed. Okay, and assign the new value to the combat state. So combat state equals value. Copy this below. Do connect instead of disconnect. And now we need to, well, let's stop the game first. And now we need to create these callback functions. So function on enemies died changed, we have the p new count, and then we put the text on the label to reflect that. So enemies slain label dot text is going to be equal to enemies slain colon %s, or %d actually, because we're going to do a decimal value, and then we do %p new count. Should specify up here that that's expecting an integer. Okay, and now we do basically the same thing again. So I'll copy and paste that down below, get the different function name on player deaths changed. We use the player deaths label, and we change the text to say, let's say deaths, or player deaths to be more specific. So that's still using p new count, the parameter. And on load, we do want to get those values as well. So we'll say function underscore ready. And you know what, we could use a function to reuse the code too. So let's do function set enemy slain label with a p new count integer. And then this comes up there. And then we call this function down here, p new count. And on ready, we'll basically do the same thing. We'll just do calling this, and we're getting the value from the combat state. So combat state dot enemies died. And then we'll have another function. So function set player deaths label with p new count, type integer. We get this bit to there, then we'll call that down there. So we pass in the p new count. Okay, so on load, we also set the player deaths label to the combat state dot player deaths. Let's try hitting play and see if the text loads like it should. Okay, we can also give these text labels some default text. So I'll say like unset and unset. We do need to give it kind of like a hierarchy here. So I'll right click, add a child node, and we want a container, more specifically a VBox container. Move the labels inside of here, and then they'll be stacked on top of each other. We want to put the game stats into the UI. So game stats.tscn, drag and drop that in UI. And now it should be set there in the top left. Let's hit play and see where we're at. Okay, I can see that the text is being set, but it is really hard to read. And it's not following the screen. So if we want to make the text always stick with the same screen position, we should give it a canvas layer node. So right click, add child node, canvas layer, put that down there, and then move UI game stats into that. If we hit play, then, well, let me see if I can move out of the way enough. So then you can see up there we have the text showing. Now that's also going to affect the size of things. So the canvas layer is no longer going to scale with the game world. So we need to be aware of that. I'm going to take the font size and triple it for the UI theme to 48. In game stats, for the gameplay, for the game stats, let's make sure that this is big enough. So I'll say layout, anchors, top left. I'll hide the game world temporarily so we can see this. And so anchors preset, I'm going to change that to full rect. Okay, let's work on positioning and sizing the game stats. So inside of the game stats scene, okay, I'm going to make sure that everything is top left, I guess top left. And then the game stats, I'll give it the container size. So expand and expand to its children sizes, and then the VBox container. I think we also need to expand it. Okay, so if we do that and we go back to the play the main game, we can see enemy slain and player deaths show up there. We might need to give it a little bit of a margin container. So I'll right click, add a margin container in. The VBox becomes the child of that, and then the margin container. We can do theme overrides. I'll give it a 10 pixel margin on every side. Let's hit play. Okay, we can kind of see it spaced out a bit more there, maybe 20 pixels on the left even. And let's show the world again. Hit play. Okay, we can see our text up there. So we're going to need to make sure that that is visible, and that's going to require changing the... So I'll embed a new theme into these, which is going to change one thing, which is going to be the font color on the labels. So I'll do add label and font color. And so if we go over here to the inspector, we can choose the font color we want, and I'm just going to make that kind of like a red. So let's hit play, and we should be able to see our text up there in the top left pretty visibly. But you know what? I really need the panel to show as well. So in the game stats, let's give it a size and position, like 300 by 300 or 300 by 200. Hit play and see how that looks. Okay, so we got a panel kind of there in the top left. If we go to gameplay, we can position it with W and then move it a little bit away from the top left-hand corner, a little bit more to the right. Okay, so we can see it now. Let's test it by shooting a few guys. Okay, so the enemy slain seems to be working. Let's make sure player deaths is working up there. Okay, yep, there. So the counters are working. The data is being received, but we can see that the location where the hit damage is showing now no longer really makes sense because the canvas layer is different now. So our combat text system was putting it on the UI parent. If we open this up, combat text system, I might just change this to be parent, and this can be any node 2D. And what we'll do is we'll actually make it a child of the world, I think. So we can say parent.add child text to instance, and the parent is just going to be the world. So it'll move with the game world instead of moving with the UI. So if we hit play and we get hit for damage, okay, we can see that now that's working again. We can shoot, deal damage to these guys. That's all good. But perhaps we need a separate theme for the text template now. So I'm going to open up the text template, and I will give it a label settings. So new label settings. So this is kind of like custom for this object specifically. I'll quick load the font, M5X5, and font size 16. We'll just try that, sure. Okay, so let's shoot a few times. Okay, and now it's pretty much back to normal. We got our text working. We have our enemy slain counter and player deaths counter, and we could add anything else we needed up there. Stuff like basically tracking how much gold you have on the player would be mostly the same way. Whenever the gold changes, we just update it in the UI, possibly through a shared resource. And that's pretty much going to be it for tracking data statistics in the game. I think this part ended up being a little bit more complicated than I had actually originally anticipated, but hopefully you guys were able to follow everything. And I'll see all of you in the next part. So in this part, I'd like to create a game over screen when the player dies, just keeping it pretty simple and responding to an event. And then I guess we can have like a restart game button or something like that in place of like a main menu. But before that, I do want to take this game stats canvas, go into it where we have the game stats panel, and I'm going to make the panel less transparent. So if we take the theme in the game, the defaults, and I'm gonna add a panel item type, then we're gonna want to take the panel color, which is under the panel tab for style box flat. So we'll add that as a property we can edit, open up, I think style box flat, yep, okay. And then we can change the background color that we have by default. And then that will include the alpha as well. So it won't show right here because the game stats is currently not on the main gameplay window. But if I go to gameplay, it should update for that. So we hit play. Okay, we can see that it's only lightly transparent. So we can increase or decrease the transparency as we need with this background color. I might want it to be a little bit more solid even. So we hit play again, test it. Okay, it's pretty easily visible no matter what's under it on the screen. So that's kind of what we're looking for. Now we can start on the game over. So for the game over on our player, we emit when it dies through the combat state. So that would be a pretty easy way to throw in a game over scene. If I edit the vSource and then edit the combat state script, we can see that that occurs when an object that's player type dies. If there's only going to be one player object in the game, that should probably be fine. So player deaths will increment, but we might not want to respond directly to the player deaths changed signal because that value can be set outside of report death occurring. So what we might want is another signal for game over, and I'll emit that down here when the player deaths increments. So let's say game over dot emit. Okay, so then when a death is reported, we do the game over signal. And from that game over signal, we can have a UI pop-up. So we'll need to create a game over UI. It'll probably be something like a panel. So I'll change this control type to a panel that will cover the whole screen. Let's do a theme override and give it a style box of pure black. That way, when it fades in, it'll just completely cover everything. So this will be the game over panel. I'll save it in the UI and also rename this node game over panel. Let's give it a script. Okay, and inside of the script, we're gonna need a reference to the combat state. So export var combat state, type combat state. We'll quick load that from the project in the inspector. Okay, and when we assign it, we want to make sure that we connect to its signal. So set value, combat state equals value. So we can say if is instance valid combat state, combat state, then we'll connect to its game over signal, game over, and that's actually disconnect here. So on game over, and then we copy and paste this below when we set the new combat state and make it a connect. Okay, now we need the function on game over. So that's where we're going to show the UI. And actually, as a result, I think I want this node to always be active. The panel itself will actually be a child of this. So I'm going to right click and attach a panel underneath it, which is going to have that theme override. So style box flat, pure black. And then the root node will just be a control. Okay, so I'll take this control, I'll change the type to a control, and that way we can show and hide the panel from within the script. When you call show on a script that is hiding from within the script, if I remember right, it just won't trigger because hiding the panel also temporarily stops the code from executing. I think that's how it worked. So this is like a just in case where you will always have the game over panel showing, but the panel under it will not be. So I'll just actually call this game over UI, and then the panel is under it. So we need a reference to the panel. So we'll say at export of our visible UI, any type of control. What we're going to set that to is going to be the panel, of course. So on game over, the visible UI is going to show. And then on ready, function underscore ready, we're going to say visible UI.hide. Okay, now we can click on game over UI, assign the panel as the visible UI, and that'll pretty much be the basics. So let's hit play and see if we can get a game over to occur. And you know what? I'm going to increase the enemy damage temporarily. So weapon stats enemy or invader collision weapon stats, which is make it 50 damage. So I guess going Super Nintendo Mario where you die in 2 hits. Yep, okay, so there we had the death occur, and we did not get the game over signal. So if I go into the panel, and let's see if we can get that to display there. Oh, actually, it's probably because we haven't added the game over panel to the UI. So let's look for game over panel on the file system and just drop it under UI. And we want to make sure that that stretches the whole screen. And game over UI, the scene, it's set to full rect. So let's make sure it's full rect inside of the UI as well. So this should be full rect. So maybe the UI above it is not full rect. So UI full rect, and then game over full rect. Hide show, because the panel also needs to stretch to full rect. So this panel layout, anchors, and then full rect. Okay, there. Now that should be good. Yep, okay, we can hit play now. We'll get hit twice, and then it's gonna show the game over panel, which means that our screen just turns black. Now, that is not super helpful because it doesn't really show much of what we need it to show. So let's jump into the game over UI, and I'll add a, let's say, rich text label, and I'm gonna center it. So under layout, we go to layout mode, anchors, center, and I'm gonna just say game over in the text. And let's expand this box a bit. I'll recenter it. And I also want to center the text. Let's do BB code enabled. That way we can add some effects to this. Okay, maybe we don't want the size to be increased. I'll just reset that and reset the size. Let's see, fit content. Okay, so let's resize this to be the size we actually need it to be. In the rich text label properties, there's markup, custom effects. So we can add one in here. Let's do new rich text effect. Okay, let's expand the box and go to gameplay. We want to make sure it actually fits the screen when it's showing in game. So just expand it to what it needs to be. So that we have our game over. Okay, I'm gonna see if we can just paste the BB code to get it to work. So with BB code enabled, I'm just gonna put this in. Okay, so we add a wave effect. So you could just kind of copy and paste this as is. I'm basically pulling right off of the Godot wiki on BB code. So if we want that effect to end, we might also want to do a /wave. Not really necessary, but otherwise this would apply to any other text we add after it. So you can see after the /wave, it stops applying. We can also do rainbow. So let me put that in. Once again, I'm just copy and pasting. So we gotta have the left square bracket, rainbow. And then at the end, we can do /rainbow. Now putting a rainbow in a 1-bit game is kind of like not really staying on theme, but whatever. I think that works as a pretty cool game over screen anyway. So let's hit play, and we'll get hit a couple times. So we got our game over. Could stand to make it a little bit bigger. So I'm going to take the game over UI here, and I'm actually going to add a custom theme for the font size. We'll say 48. Okay. Now this basically stacks with the original theme. So the original theme applies the font, as you can see there, and then this only changes the font size, I believe. Okay, so we gotta stretch this to be big enough and hit play. So we get hit twice. There's our game over. Okay, maybe we even need it to be a little bit bigger. I'll make it 96, and let's just preload the font. Nah, let's not. Just in case we change the font later on. Okay, so 1, 2, we got our game over. We do want to make sure we center it in the screen too. So let's make sure that that is in the center. And I think what we have to do to make sure it's centered is check the anchors or something. No. We need to adjust the text position. So I think we can do that with BB code as well. So I'm going to do center code, and then we can have a /center over here. Feels like I'm writing a forum post from back in the day, all those BB code forums. And is there a vertical centering? I guess the thing to do for that would just be move it down a little bit. And on gameplay, it's kind of centered, good enough, right? 1, 2, and then we get our game over screen. But we might want to have like a fading animation for that turning on. Let's actually create an animation player. If we add an animation player child node, then instead of showing the panel directly, we could just play the show animation. So go to animation new, show, and this is going to take the panel. So let's see, property track on the panel, which is going to be like the visibility. So we want not self-modulate, modulate track on the, so property track on the panel, modulate, okay, and let's just make it a 1 second animation. So we start at 0% alpha and we end at 100% alpha. Might need to zoom in and make sure that we set these keyframes right. So it should be 0 and 1.0, and then this goes to 100% alpha. If I hit play, okay, there you can see we have like our fade in. So in the game over UI, so instead of just showing and hiding, we also want to play the animation. So if we do export var animation player, uptype animation player, then we'll just do animation player dot play, and we're looking for the show animation. Okay, we need to assign the animation player, and that should probably be good to go. Let's get hit twice, and now we get a fade in for our game over. Cool, that actually worked pretty nicely. Let's see. So we do need a button to restart the game. So I'm gonna right click on the game over UI. We'll add in a button. We want to position it under the game over. So let's do a VBox, add child node, a VBox container, position rich text node on top, and add the button under it. Okay, got to make sure the VBox container stretches to the whole thing. So in layout mode anchors, full rect. And where did my text label go? Expand vertical, I guess. And I guess this should actually be center. Okay, now I want to make sure it stretches to the child contents, or we can just expand it kind of like this, I guess. Move it down a bit. Where's the button? Okay, these anchors need to be adjusted too. Okay, so we need our button to be below that, kind of in the center. Let's say restart, and we can position that there. So our restart button, I want to attach a script to it to tell it what scene to load. So let's add a restart game button script in UI. So we're gonna export var restart scene, which is a pecked scene. This is gonna be the gameplay. So if we quick load from our project, if we find gameplay.tscn, then we can completely restart the game. Now, there might be some game worlds where instead of completely restarting all the systems, like I'm doing right now, just going for a new game, that you would instead load the world again, or you would load the level within the world, or you would load a save file. But this is just probably the simplest way to get started. So just keep in mind that you don't have to completely restart the game. You could just restart the level or load the contents of the same level or move your character to a save point, that kind of thing. So we're going to just tell the scene tree to change the scenes though. So function onPressed. We're going to take the tree. So get the scene tree, and then we're going to switch to scenes. Let's see, change scene to file, change scene to packed. I think that's what we want, which is restart scene. So that's going to completely restart our gameplay scene. It's going to restart the whole game. And the last thing we need to do is connect to that pressed signal. So function underscore ready. We're going to do pressed.connect on pressed. And that's pretty much it. So when the button is pressed, we change the scene to the restart scene, which is the gameplay. And I'm going to rename this button restart game button. So we hit save. I get hit a couple times, and then I'm going to hit restart. Okay, it did not work as intended. And also this is supposed to hide initially, so I forgot to put it onto the panel. So let's do that. And now I'll hit play again. We get hit a couple times. There's our button. We can restart. Let's see what the debugger says. I can't change to a null scene. Use unload current scene if you wish to unload it. So that's interesting. Let's do the unpressed. I'll hit play, and we'll see if it is in fact null when we get to that point. So I'm going to restart, and yes, it is null. Okay, let me try one more thing. Maybe it's because it's being loaded from within the parent scene. So I'll try a file path here. So this is going to be a string. We'll do export file. And then instead of change scene to packed, we'll do change scene to file. Put in the restart scene. And then we just put the path to the gameplay TSCN inside of here. Sometimes packed scenes are a little bit screwy, so we'll see if this works. So it does seem to be set in the inspector. If we do restart, oh, okay, there we go. We got that to load up. As you can see, the player deaths are still there. If we were to shoot enemies, I believe that statistic would also still be there as well. So there's a couple issues we need to work out. So if we want to reset the number of enemies that died whenever the gameplay reloads, we could do that. So I might add a script to gameplay, and then we'll reference the combat state. And just as an FYI, normally you would probably do this when you load the data, you just set the values. So like you load a new game and you set the values on load. So we could just say quick load here, and maybe we say function new game, and we say combat state dot enemies died equals 0. So we'll say function underscore ready, but I'm going to keep the player death count the same so that even when we restart, we know how many times the players died. Okay, last thing, the window here, when it's not visible, it's blocking the mouse input. So if you go and you hit play and you try left clicking to shoot, you'll see that it's not working because it's being blocked by the UI. So for the game over UI, let's jump into that. I'm going to click here. We want mouse to be changed to pass. And we want to make sure that the panel also is like that. So mouse pass. That means that even if you click here, the mouse actions can still pass through it. And under the rich text label, mouse should be pass as well. Yeah, we'll make that pass. But not for the game restart button, I think. So I'll hit play. Okay, we can't shoot still. Is the UI itself blocking it? Yes, it is. Okay, so let's make that pass. Now we hit play. We can shoot again. Yep, even if we're kind of in the middle here where the button is invisible. So if we get hit a couple times, our character will die. And then now we can hit the restart button. You'll see enemy slain restarted, but the player death count is still there. We can restart. Yep, okay, we get our health back, so it takes 2 hits. And that's looking pretty much as we want it to be for the game over screen. Yeah, so we have a player death count and an enemy slain count that restarts whenever the game restarts. So, pretty simplistic way of handling things. Obviously, with the new game thing, this would probably become a save and load data, or you can call new game if you want to restart the stats. But normally, I guess that would be from a main menu. I guess it's not really that different from what we just did, having the restart button there. But just keep in mind that like there's different ways of doing this, and you might need to adapt it a bit for your game. But that is pretty much the gist of having a game over screen, restarting the enemy's death count, and making sure that your UI does not block your mouse input so you can still interact with the character. Hello everybody, Chris here, and in this video I'm going to show you guys how to import and use sound effects inside of Godot. So we're going to be doing this for the 1-bit platformer series. So first things first, you'll need some sound effects to put in the game. Coffee Valen Bat has a pretty good pack on itch.io for some sound effects you can use. So sound effects for GB Studio, Game Boy games, it makes sense for 1-bit. So we'll go out and give it a try. Another alternative would be using this tool, BFXR. So the BFXR website might look pretty simple, but it's a pretty good tool for creating computer-generated sound effects by using slider bars. It doesn't really take any skill. You just kind of have to play with it until you get something that sounds interesting enough for sword attacks or item pickups, that kind of thing. I'm going to be trying the Sweet Sounds pack. There's plenty of other options on itch.io and other sites if you want to look for them. But you just need some sound effects for this tutorial. So when you've downloaded it, we can create a new folder in our project. I'm going to call it either sound or audio. Let's go with audio because it's going to have music and sound effects. So inside of that audio folder, we'll create a new folder, SFX for sound effects. And let's open it up in File Manager, right click, open in File Manager. And now you just need to copy over what you want out of the pack. So I'm not sure about this BGM format, but .wav will definitely work. So you can grab as many or few of these as you want. Perhaps we want a confirm, cancel sound effects, and let's do gun as well because we have projectiles, laser gun,
and maybe monster scream. So we can copy those over and put those in here. And let's just find some places that we want to actually instance these sound effects in the game. So an obvious example would be when we launch a projectile. So if we go to the player scene, let me zoom in here a bunch. We can close the behave tree. We're pretty much done with that for now. And we have our shooter script. So I think when the shooter fires, it would be a good idea to play the sound effect on the fireable. And we'll have to create that in there. So let's see, fireable basic has weapon stats basic. So inside of shooter, we can give a sound effect to our fireable. Maybe we put it under weapon stats because we'd probably want a sound effect for when we attack with other weapons as well. So in weapon stats, we'll add the sound effect, and then shooter will play it whenever we instance a copy of the projectile. So let's look for weaponstats.gd. I'm going to export inside of here a sound. So I'll say export var sound, and this will be a audio clip. And for this, if we hover over, let's say the laser gun sound effect, we can see it's an audio stream. So I think that's the class we need, audio stream, not MP3, but there are a few options here if you're using OGG Vorbis or MP3. Dot wave sounds tend to be pretty space inefficient, so in the long term you probably do want to use more like an OGG Vorbis, I think. So let's put in a audio stream of any type, and we can click on the shooter. We'll expand the weapon stats basic, and here we can see our sound. So we just got to drag and drop laser gun. I did test the laser sound. I think it sounds a little better for the kind of projectile we're shooting than the gun sound effect. So when shooter creates a projectile, if there is a sound effect in here, we want to instance a copy of it. So after the projectile launches, if there is a sound effect in, let's say, fireball.stats.sound. So if there's a fireball stats sound, we're going to want to play the shoot sound effect on probably the shooter itself. So I'm going to right click on shooter and add a audio stream player. So I'll say this is the shoot audio stream player 2D. Now we want to assign it to the shooter. So in shooter, I'll do @export var audio player, which is a audio stream player 2D. And then we want audio player to play that sound effect. So audio player dot play fireable dot stats dot sound. Okay, should be float, but is audio stream. Let's see. Okay, I guess we have to set the clip first. So let's see, audio player dot stream, I think, is equal to fireball stats sound. Let's click over here. Yeah, we can see this is the property of the stream. And then we play it from the beginning, which is the default here. So let's give this a shot. I'll hit play and we fire. So we can see invalid assignment because we have not assigned the audio stream player. So in the shooter, we need to assign the audio player. Okay, now we can hit play, and you'll see that we can immediately play the sound effect. You could even have multiple going at the same time, and basically plays perfectly well. Okay, so that's probably the easiest one, just a sound effect on shoot. We can also add ones on hit. So maybe the monster scream on hit. That's a bit loud. So this one, I would say, is a little bit dramatic for just getting hit. So maybe this bump sound effect would be a little more appropriate. I'll bring that into the project too. So temporarily, at least, I'll remove the monster scream and the gun sound effect, just because I don't think I'm going to use it in this tutorial, but I might bring them back later. So we have the bump sound effect. Whenever a Hurtbox gets hit, I think I'm going to default it to play the bump sound effect. So we can open up the Hurtbox script and give it a sound effect. So @export var hit sound, and this will be a audio stream. And then we want access to a player. So export var hit player, audio stream player 2D. Okay, now we can give the Hurtbox its own audio stream player. And I am going to set the hit sound for the player to bump. Maybe the player should have its own sound effect later on, but I'll just kind of make that the standard for now. And then we need to assign the audio stream player. So audio stream player there. And I did just assign the bump sound right in there. So you could actually make the argument that you don't even need the audio stream set on the Hurtbox because it's already set in the player. So I could just remove it from the hit player. As long as we set it in the stream player down here and we don't mean to change the sound effect, it would be fine. Otherwise, if you need to have multiple sound effects, you probably have like an array of sounds on the Hurtbox and then play one of them depending on the circumstances. But this would work just fine as is. Let's go to the invader as well. On the Hurtbox, I will assign a audio stream player 2D. So the Hurtbox grabs the audio stream player 2D, and that is going to use bump as the sound. So now if I shoot at the enemies, well, in theory, they would play the sound effect, but I guess I didn't set it up correctly yet. So in audio stream player, after it gets hit, if the hit player exists, so we can say if hit player, then hit player.play from the beginning. We shoot at them, and if you listen closely, it's definitely playing the sound effects. Okay, so that's good there. Now, where might you use a cancel or confirm sound? An example would be the game over panel. So the restart game button, we could have a confirm sound effect. So just as an example, I'll give this a audio stream player 2D. Or actually, does it even need to be? It could just be a regular audio stream player, couldn't it? Because the UI isn't exactly in 2D space, so this should work fine. I'll use the confirm sound effect. Restart game button. Okay, we just need to reference the audio stream player. So at export var, audio player. This will be a audio stream player. We assign it in the inspector, and before we change the scene, we're going to play the sound effect. So let's do audio player.play, and that's I mean, we would want the audio player to be there. We could say if audio player. If you want to make the audio player optional, then that would be one way you do it. So let's hit play. I'm going to die intentionally, and then we'll try the confirm button. Yep. Okay, that worked pretty good. So one last thing for this tutorial, if you do want to include music, you should probably import it to the project as either a MP3 or a OGG Vorbis file. So if we search the help for loop, and we scroll down to the bottom more or less, you'll see that two of the audio stream types, MP3 and OGG Vorbis, have loop supported. So if you toggle loop on, then it will keep looping through as the game progresses. So you don't need to necessarily change it unless your scene changes and you want to change the music. And you could just use the same audio stream players as before to do that. So specifically for music, I think that would probably go on an audio stream player, not an audio stream player 2D. Music doesn't really need to be positional. It's just kind of there in the background. So you don't want it to actually have a 2D position in your game, usually, unless it's coming from a certain source, like a music player actually in the scene. Then you can use the audio stream player 2D. And that would basically be about it for playing music. It's just a looping MP3 or OGG Vorbis file, and you put it on an audio stream player that probably rests outside of the scene as a regular node rather than a 2D. So that just about covers what you need to know for audio inside of Godot, at least for the basics. And as you can see, of course, it works super well. It can support playing many sound effects at the same time, and you only need a minimal amount of coding to get it to work. In fact, if I'm honest, I wish I had actually just put the sounds in at the beginning of the course. Probably would have made it a little more interesting, but hey. So that's pretty much where we're at. It's possible I'll still add extra tutorials to this series, though at least as a basic prototype, it is for the most part working. Of course, it would be nice now to add stuff like extra projectiles, maybe give the enemies projectiles, and then they can aim at the player, that kind of thing. But at this point, you guys should have a pretty good understanding of the basics of platformer mechanics, shooting projectiles in 2D, enemy collisions with players, behavior trees, and other miscellaneous things like setting up sound effects or game over screens and communicating data to the UI, like our little enemy counter over there to the top left. So thank you guys for watching. I hope you guys learned a lot, and until my future video content, I will see you then.